Hello guys, good afternoon everyone. Welcome to the session and yes, it's 12:30 p.m. and GATE 2023 electrical paper would have just completed and yes guys, we are live in front of you and बहुत ही धमाकेदार तरीके से we are going to do the complete exam analysis of electrical engineering. So here I have Ashton sir with me. तो sir, क्या लगता है कैसा पेपर चला गया होगा बच्चों का already?
Sir, I'm just guessing it that for past 2-3 years we are getting easy to moderate difficulty level for electrical engineering. So this time I was expecting, the whole team was expecting some good surprises in electrical.
Yes.
And we have not seen MSQ questions for past 2 years. So definitely this year it is going to be a big surprise whether we are getting MSQ questions in electrical or not. So guys, this is a big day for all electrical engineers. Just join fast and share this session to all your colleagues, all your friends, because this is going to be a complete, the most authentic analysis. And with me joining our favorite Ashu Jangra sir. Please sir.
हेलो गाइस, तो आप एक्साइटेड होंगे?
Yes.
तो मैं भी एक्साइटेड हूँ और आपको पता है कि सॉल्यूशन जो ऑथेंटिक मिलने वाले हैं वो आपको यहीं पे मिलेंगे, ठीक है? तो आई होप आप लोग भी काफ़ी एक्साइटेड होंगे और बहुत जल्दी अभी आपको सॉल्यूशन मिलना स्टार्ट हो जाएंगे एंड आप हमारे साथ जुड़िए
Yes.
और अपने आंसर्स को मैच कीजिएगा. तो सर, कलेजा सर.
Yes. हाँ जी स्टूडेंट्स. So guys, students अभी just might have started coming out of the hall. Very soon we are going to get how many MSQs? So as Ashto sir also said, last 2 years there are no MSQs in electrical, but this year कल रात में हम लोगों ने काफी डिस्कस किया. We are expecting. IIT is always full of surprises, but I believe that there are going to be MSQs this time. कितने होने वाले अभी बहुत ही जल्दी हमें ये डेटा मिल जाएगा. Guys, एक बार के लिए if we just go and yes, थोड़ा सा एक बार हम रिकॉल कर लें, कि लास्ट ईयर क्या एक्टिविटी हुई थी गेट 2022 में, सो दैट इमीडिएटली व्हेन वी गेट द नेक्स्ट डेटा इस साल क्या होने वाला है वो पूरा क्लैरिटी आ जाएगा. तो सर देखिए, लास्ट ईयर का ट्रेंड तो ऑलमोस्ट एक वैसे पैटर्न पे था जैसे गेट में एक्सपेक्टेड होता है. सर आप लोग की क्या ओपिनियन है इलेक्ट्रिकल इंजीनियरिंग के हिसाब से? इस बार क्या इसी टाइप का पैटर्न एक्सपेक्ट होगा या कुछ चेंजेस हो सकते हैं?
तो सर मुझे लग रहा है इस बार पावर इलेक्ट्रॉनिक्स पे थोड़ा अच्छा आना चाहिए. बाकी आप लोग बताएं भाई, पावर इलेक्ट्रॉनिक्स का आप लोग क्या एक्सपेक्ट कर रहे हो? बाकी पावर इलेक्ट्रॉनिक्स मतलब कोर वाला जो पार्ट है वो मुझे लगता है कि ज्यादा आएगा. बट आपको ये बात बता देता हूँ कि आईआईटी का जो ट्रेंड आ रहा है पिछले 2-3 साल से, वो नॉन कोर की तरफ ज्यादा आ रहा है. कोर को थोड़ा कम पूछते हैं. पावर इलेक्ट्रॉनिक्स में इसलिए बोल रहा हूँ बिकॉज पावर इलेक्ट्रॉनिक्स का आगे फ्यूचर में ज्यादा जरूरत पड़ती है. तो इसलिए पावर इलेक्ट्रॉनिक्स सर मुझे लगता है कि थोड़ा इस बार भी ज्यादा पूछना चाहिए. बाकी अभी हम पता करते हैं तो आपको पता चल जाएगा. जी सर.
करेक्ट. सो गाइस, आई होप आप लोग को पता होगा कि अगर हम कल की बात करें, राइट, इफ वी टॉक अबाउट द नंबर ऑफ एमएसक्यूज ऑफ यस्टरडे, तो आज का ट्रेंड भी हमारे पास बहुत जल्दी आने वाला है. नंबर ऑफ एमएसक्यूज की अगर हम बात करें, इफ कंप्यूटर साइंस की बात करें तो देयर वर 15 एमएसक्यूज. मैकेनिकल की अगर हम बात करें तो कल 8 एमएसक्यूज थे और अब बारी आ चुकी है डबल ई की. यस गाइस,
Definitely, sir, this is going to be a big surprise, and we are all very eagerly waiting for the latest information from the student side, because this is going to be a memory-based analysis. Because you don't get the question paper, you all are aware it is a computer-based test. But definitely, as soon as we are getting the questions, our back-end team, all the faculties are going to be solving the questions, and we will be coming up the most authentic solution for electrical engineering throughout. Now you see friends, it's not just about MSQ also. If you have seen the past previous year papers, you must have seen, as Ashu sir has well said, that more and more focus is given to the non-core areas. If you see, very good quality questions are being asked in non-core areas, but this time we are expecting very good quality questions in the core subjects like machines, power system, power electronics. So I think Rakesh sir has got some
नहीं, just waiting, but I think yeah, I am just going to get an update very soon. Okay, by that time एक एंट्रीज बना लेते हैं ताकि स्टूडेंट्स के सामने फटाफट से. So
क्या
guys,
लगता है सर आशु सर,
लाइव
क्या लगता है सर कितने एमएसक्यू आ रहे हैं सर?
सर मुझे लग रहा है कि इस बार कम से कम नहीं तो 10 से 12 एमएसक्यू तो आना चाहिए.
ओह राइट.
एमएसक्यू से पेपर का लेवल भी, बेशक एमएसक्यू कितना भी इजी आए सर, बट उससे जो पेपर का लेवल है वो अपने आप थोड़ा सा अप हो
बढ़
जाता है।
जाता है, क्योंकि आपको एक ही
ये
क्वेश्चन
चीज़
में
है।
3-4 ऑप्शन, जो चारों ऑप्शंस को खंगालना पड़ता है,
Yes,
ढूंढना पड़ता
exactly.
है कि कहीं छोटा सा भी गलती तो नहीं कर रहे हैं हम लोग।
तो इसलिए चलिए देखते हैं अभी फटाफट, जैसे ही हमारे पास पता चलता है हम आपको जरूर इन्फॉर्म करेंगे कितने एमएसक्यू हैं, कितने इवन न्यूमेरिकल आंसर भी। सर अगर आप देखें तो न्यूमेरिकल आंसर में भी बच्चे के पास ऑप्शंस नहीं होते ना, तो
रेफरेंस नहीं होता।
वो
Reference
उसको
नहीं होता।
पता नहीं चलता है कि भाई कौन से कितने सही आ रहे हैं, कितने गलत आ रहे हैं। तो ये भी एक इशू रहता है। तो इससे पेपर का लेवल जो है वो थोड़ा सा फर्क पड़ जाता है, थोड़ा सा डिफिकल्ट बन जाता है। बट बहुत जल्दी अभी आप देखिएगा कि आपको फटाफट इसके सॉल्यूशंस आपको मिलना स्टार्ट हो जाएंगे।
सर मेरा एक
So-
छोटा सा गेस है, जो जैसा मैंने कल देखा, आप लोग डिस्कस कर रहे थे, बच्चों जब आईआईटी कानपुर लेता है ना गेट का एग्जाम, तो मेरा सर अंदर से मुझे ऐसा फीलिंग आता है कि कहीं ना कहीं मैथ्स के क्वेश्चन बड़े अच्छे बनने वाले हैं। और जो मैथमेटिकल सब्जेक्ट्स है ना, लाइक कंट्रोल हुआ, सिग्नल हुआ, इस पे आपको काफी अच्छे क्वेश्चंस मिलेंगे। मैंने ऐसा ऑब्जर्व किया है, इसलिए मैं ऐसा बोल रहा हूँ। और कल हम लोगों ने 1-2 क्वेश्चन देखे भी सर मैथ्स में, जैसा कि देखा। तो इस बार सर शायद इस तरीके कुछ एक्सपेक्ट कर रहे हैं।
हाँ सर, मैथ्स का अगर आप देखें तो पिछले मतलब मैकेनिकल का तो मैंने भी 1-2 क्वेश्चन को देखा था, तो काफ़ी बढ़िया क्वेश्चंस मैथ पे पूछे गए थे। एंड एक क्वेश्चन तो ऐसा भी था जिसमें हमने टाइम भी काफ़ी मतलब अच्छा टाइम लग गया उसमें। तो मैथ्स में ऐसे अगर कंप्यूटर साइंस का भी देखें तो कंप्यूटर साइंस में भी मैथ्स का काफ़ी अच्छा मतलब आया था। तो मैथ्स उम्मीद है कि मैथ्स इस बार भी अच्छा आएगा। तो बाकी लेकिन मैं आपको एक बात बता दूं दोस्तों, 80% ऑफ द क्वेश्चन जो आएंगे वो थोड़े बहुत मॉडरेट लेवल ही रहने वाले हैं, सिंपल टू मॉडरेट रहने वाला है। बट आई थिंक 20% जो है वो थोड़ा सा आपको थोड़ा सा डिफिकल्ट होगा। और एक नई अपडेट सर,
यस सर।
ये Okay.
MSQ, so इलेक्ट्रिकल की स्टार्टिंग हो गई है MSQs की। So yes, electrical they have got six MSQs.
सर कुछ कहेंगे?
Sir, I was just asking the students, friends, just quickly join the session because we are about to start the complete solution, complete analysis will be coming up. One of the most authentic solution throughout, and it's not just the solution. We'll be also discussing what has been the weightage for different subjects and what are the type of questions being asked. And anybody who is live with us in this session who has appeared in the 2023 electrical examination, just tell us quickly, how was your experience? So electrical guys, how was the paper? Electronics will be starting in the evening session.
Yeah. Electronics paper will be
But
starting
electronics guys, something very important, because you are going to attend the session in the evening. Electrical paper discussion is going to be little helpful for you. I will not say that questions can be repeated,
Yes.
but definitely you will feel a trend and you will be in the examination mode. So this is going to be important. So everybody just quickly tell me in the comment section, how was your electrical paper for GATE 2023? Everybody.
Yes.
जो स्टूडेंट इलेक्ट्रिकल के हैं और जिन्होंने पेपर दिया है, जो ज्वाइन कर चुके हैं, हमें जरूर बताएं भाई इलेक्ट्रिकल का कैसा रहा आपका पेपर। एक बार फटाफट बताइए कमेंट सेक्शन में, सो दैट हमें भी पता चले कि पेपर का लेवल आप लोग कैसे सोचते हो और किस तरह का लेवल आपको लगता है कि क्या लेवल रहा पेपर का। जरूर बताएं। और फिर हम बहुत जल्दी स्टार्ट करेंगे डिस्कशन, क्वेश्चंस का डिस्कशन स्टार्ट करेंगे। तो एक बार बताइए कि भाई पेपर का लेवल किस तरह का रहा है, जो इलेक्ट्रिकल के स्टूडेंट हैं, जो हमें ऑलरेडी ज्वाइन कर चुके हैं, फटाफट बताएं भाई।
All right, guys. So MSQs की बिगनिंग हो गई है इलेक्ट्रिकल में। एंड यस गाइस, दोज आप में से जो एग्जाम हॉल के बाहर आ चुके हैं, यू कैन शेयर योर ओपिनियन अबाउट द इलेक्ट्रिकल इंजीनियरिंग. हाउ वाज द लेवल? Okay, definitely when MSQs come, paper becomes little more challenging as compared to without MSQ. ठीक है, but बाकी NIT और MCQ किस लेवल का था? Guys, come on, keep responding. Rajshri, don't panic right now. Your exam is at 2:30. Don't think you have done best. What can you do in remaining 1 or 2 hours? Right? Stay calm. That's the only thing and only one thing you have to do. Stay calm. Enter your exam hall. फोड़ के आ जाओ. 5:30 बजे के बाद आपसे भी बात करते हैं. Right? Okay, guys. So keep joining, keep sharing the session to all your friends.
Sir, what I feel is, apart from the MSQ that coming in 6 in numbers, I think the weightage given for MCQ is good.
Yeah. Usually, ये reverse भी हो रहा था कई बार.
Yeah.
But MCQs are good in number. Okay. देखिए, MCQs are relatively easier to handle,
Easy.
but at the same time, there is a element of negative marking.
Yeah.
So out of excitement, we try to mark so many questions. ज़्यादा करके आना है पेपर, ये हो जाता है. So you have to really avoid the negative markings here.
और सर कई बार क्या होता है MCQ क्वेश्चंस में जो 1 मार्कर होते हैं सर, वो मैंने देखा है, देखने में सर बहुत हलवा लगते हैं.
Yes.
जब आप बाहर आते हो एग्जाम हॉल के तो पता चलता है, अरे ये तो हमने गलत सोच लिया, और वो 1/3 नेगेटिव हो जाता है.
2019-18 में ऐसा हुआ है सर एक बार कि 1 नंबर के जो क्वेश्चन थे 1 मार्क्स वाले, दोज वर मोर डिफिकल्ट, तो उसमें कई बार ज्यादा टाइम लग जाता है, तो इसलिए हमेशा 2 नंबर वाले को ही प्रेफरेंस ज्यादा रखनी
So I
चाहिए।
think we are starting getting the questions.
Okay.
I'll just join you quickly.
ओके ओके, सो गाइस फटाफट बताइए भाई, जो इलेक्ट्रिकल के स्टूडेंट्स हैं जिन्होंने पेपर दिया है उन लोगों को क्या लग रहा है भाई, पेपर का लेवल कैसा था? कमेंट सेक्शन में फटाफट कमेंट कीजिए। अगर आप ज्वाइन कर चुके हो इलेक्ट्रिकल स्टूडेंट, फटाफट बताएं भाई, बताइए पेपर का लेवल किस तरह का लगा आपको?
सर द बिग सरप्राइज दैट हैज बीन रिवील्ड, दोस्तों सबसे बड़ा सरप्राइज, 2 साल से वेट कर रहे थे हम लोग को, तो ये लग रहा था कि यार ऐसा क्या हो गया, सब में आ रहा है एमएसक्यू, इलेक्ट्रिकल वालों ने ऐसा क्या पाप किया है यार कि एमएसक्यू नहीं आ रहा है। और हम लोग इतने सेशंस ले रहे थे सर, और एमएसक्यू क्वेश्चन के साथ एक सबसे खास बात ये है कि सर वो क्वेश्चन आपको बनाना पड़ेगा, बनाया नहीं मिलेगा आपको, और क्वालिटी क्वेश्चन नहीं मिलेगा। तो हम लोगों को काफी मेहनत लगती थी दोस्तों आप लोग के लिए एमएसक्यू की सीरीज लाने में, और हमारी जो एमएसक्यू की सीरीज थी आई होप उससे आपको कुछ ना कुछ बेनिफिट जरूर मिला होगा। तो एक बार जल्दी से अंजलि, राजश्री, जल्दी से आप लोग बता दीजिए, श्री कुमार, कि कैसा रहा, कैसा एक्सपीरियंस था?
अगर आप इलेक्ट्रिकल से हैं तो फटाफट कमेंट कीजिए कि भाई किस तरह का पेपर था, पेपर का लेवल डिफिकल्ट और इजी, मतलब मॉडरेट, किस तरह का आपको लगा पेपर? अंजलि सेइंग इट्स इजी। ओके सिकंदर, एफटी एंड सारी चीजों के वेटेज हम जस्ट लेकर आ रहे हैं। अभी हाल फिलहाल जो हमारे पास इंफॉर्मेशन है, एज पर द मेमोरी बेस्ड इंफॉर्मेशन वी आर गेटिंग दैट एमसीक्यू क्वेश्चंस आर 31 इन नंबर, NAT questions are 28, and the biggest surprise is MSQ questions 6 in numbers. We'll be coming up with the exact weightage analysis, that which subject got how many marks, whether it is aptitude, whether it is different core and non-core subjects also. Just be with us. तो बहुत जल्दी फटाफट।
राजीव is saying बहुत टफ था सर, हम लोग कल डिस्कस कर रहे थे टफ होगा।
ओहो, बट सर कुछ लोग ये भी कह रहे हैं ना, अंजलि सेइंग इट्स इजी, तो
मुझे लग रहा है कि सर रिलेटिव है,
रिलेटिव है चीज। तो एक बार वेट करते हैं सर, एक बार सब लोग क्वेश्चन भेज देते हैं, तो उसके बाद।
राजीव, आपको टफ क्यों लगा? कौन सा सब्जेक्ट आपको ऐसा लगा कि जो जिस वजह से आपने ऐसा बोला कि टफ है?
एग्जैक्टली,
आई थिंक मुझे लग रहा है किसी एक सब्जेक्ट में। ओके, एप्टीट्यूड का एमएसक्यू फर्स्ट टाइम आया, सो आई थिंक दैट इज ओके, बिकॉज राकेश सर इज ऑलरेडी सेड दिस, कल भी उन्होंने ये बात बोली थी कि एप्टीट्यूड में भी आ सकता है एमएसक्यू। तो ये तो आपको लेके चलना पड़ेगा, जब 65 क्वेश्चन है और एमएसक्यू इज अ टाइप ऑफ क्वेश्चन, तो किसी भी क्वेश्चन, मैं तो कह रहा हूँ सर वर्बल में भी पूछ सकता है, क्यों नहीं पूछ सकता?
बिल्कुल।
Totally different from conventional paper, Rajiv is saying. Rajiv, which subject you found that it is very difficult? किस सब्जेक्ट की वजह से आपको लगा कि डिफिकल्ट है? कोर पे फोकस था, नॉन कोर पे फोकस था?
थोड़ा सा बताएं भाई, कितने कौन सा, मतलब जो नॉन कोर वाला पार्ट था वो ज्यादा डिफिकल्ट लगा आपको, या फिर कोर वाला पार्ट ज्यादा डिफिकल्ट लगा? एक बार बताएं भाई सब लोग, सो दैट हमें भी पता चले। और फिर बहुत जल्दी हम एनालिसिस स्टार्ट करने वाले हैं, जैसे ही क्वेश्चन आना स्टार्ट हो जाता है फटाफट हम एनालिसिस स्टार्ट कर देंगे, तो आप हमारे साथ जुड़े रहें। एक बार बताएं भाई सब लोग जो इलेक्ट्रिकल के जुड़े हुए हैं।
आकाश इज सेइंग कंट्रोल सिस्टम वेरी डिफिकल्ट।
ओके, कंट्रोल सिस्टम,
अभी 5 मिनट पहले मैंने बोला था आईटी कानपुर करा रहा है, तो डेफिनेटली कंट्रोल सिग्नल ये डिफिकल्ट होने वाला है। मैथमेटिकल अप्रोच होती है सर उनकी, मेरे काफी दोस्त हैं जो पीएचडी कर रहे थे वहां से, तो उनका अप्रोच देख के मुझे लगता था यहाँ मैथ्स का थोड़ा ज्यादा है भाई वेटेज।
ओके, तो बहुत जल्दी अभी एनालिसिस स्टार्ट करेंगे। कंट्रोल कह रहे हैं कि डिफिकल्ट है, और राजीव कह रहे हैं कि टोटली डिफरेंट आया है जो पिछले साल जो कन्वेंशनल जो बना
जिस तरीके से पेपर आ रहा था। 1-2 बच्चे ऐसा बोल रहे हैं डिफिकल्ट है, एक ने बोला इजी भी था, तो देखो हो सकता है, रिलेटिव है, और कुछ लोगों को लग सकता है कि भाई बहुत डिफिकल्ट था, क्योंकि हो सकता है 1-2 ऐसे सब्जेक्ट हैं जिसमें आपको लगा हो ऐसा। तो सर एक बार थोड़ा सा इसको डिस्कस कर लेते हैं कि जो एक्चुअल वेटेज है इन टर्म्स ऑफ टाइप ऑफ क्वेश्चंस वो क्या रहा है इस बार।
सर ये दूसरा है, आई थिंक ये।
ओके,
हाँ,
स्किप
एक मिनट रुकिएगा दोस्तों।
स्किप
नहीं, ये दूसरा है।
नो, स्किप
हाँ। सो अगेन ये कंप्यूटर साइंस का है सर ये।
ओके,
मे बी स्लाइड थोड़ा नीचे देखते हैं, ये मैकेनिकल। तो बहुत जल्दी हम बता रहे हैं दोस्तों, आप थोड़ा सा वेट कीजिए,
अपडेट करेंगे सर,
इसको अभी अपडेट कर देते हैं।
ओके,
हाँ, इलेक्ट्रिकल का अभी हमें मिला नहीं है थोड़ा, मतलब अभी आ रहा है।
So we are just waiting for the authentic information, so be with us. And already as we have discussed that as far as this time we have got the news that MSQs are 6 in numbers. MCQ got the biggest weightage this time, and that it is going to be little more challenging because MCQ comes with negative marking, sir. एनएटी में नहीं किया तो ठीक है चलेगा, नेगेटिव तो नहीं हो रहा है, एमएसक्यू में नहीं किया तो चलेगा नेगेटिव, इसमें तो करोगे ना तो नेगेटिव भी होगा।
वो तो नेगेटिव होना ही है वैसे भी।
सोच समझ के करना इसको।
कंट्रोल सिस्टम डिफिकल्ट, आप लोग बताएं भाई, बाकी लोग बताएं कंट्रोल सिस्टम कैसा रहा, कंट्रोल सिस्टम डिफिकल्ट आया या फिर इजी आया, थोड़ा सा बताइए, जानकारी दीजिए कमेंट।
शुभम दयाल इज सेइंग सर आई गेस 60 हाईएस्ट टॉपर्स के जाएंगे, ऐसा वो बोल रहा है, तो इसका मतलब आई थिंक
मतलब
इतना तो सर हम जज कर सकते हैं कि अच्छे लेवल का पेपर आया है। और कल मैं और आशीष सर और बाकी फैकल्टीज यही डिस्कस कर रहे थे, 2-3 बार से इलेक्ट्रिकल का पेपर कुछ क्वेश्चन छोड़ दो ऐसा आ रहा है कि बिल्कुल ढर्रे पे आ रहा है, इस बार सरप्राइज हो सकता है।
हाँ, लेकिन सर एक बात है, अगर मुश्किल आता है ना तो वो सबके लिए अच्छा है, आप परेशान मत होइए। अगर आपका पेपर अच्छा नहीं भी हुआ है, आपको लग रहा है कि भाई मेरे कम अटेम्प्ट हुए हैं, पेपर थोड़ा डिफिकल्ट आ गया है, तो सबके लिए डिफिकल्ट है, आप परेशान मत होइए। आप देखिए एक बार, अब जो आप एनालिसिस देखेंगे कि किस तरह का हम कैसे सोल्व कर रहे हैं, क्या आंसर्स आ रहे हैं और किस तरह का लेवल हम लोग बता रहे हैं, तो उसके हिसाब से आपको पता चल जाएगा कि आपके कितने मार्क्स आ रहे हैं और उसके हिसाब से आपकी क्या रैंक बनने वाली है। तो ऐसा नहीं है कि भाई डिफिकल्ट है तो सबके लिए डिफिकल्ट है।
इवन सर जो अच्छे बच्चे हैं जिन्होंने अच्छी तैयारी करी, मुझे लगता है ये उनके लिए एक एडवांटेज है, क्योंकि इजी क्वेश्चन है तो सर काफी बच्चे कर लेंगे, बट आपने अच्छी मेहनत करी है। मैं कह रहा हूँ अगर 60 बोल रहे हैं, एक बच्चे ने 60 बोला है, मैं बोल रहा हूँ कि अगर किसी के 40 भी आते हैं और अगर 60 टॉपर के हैं तो 40 में भी आपको एक ठीक ठाक रैंक लग जाएगी,
बढ़िया रैंक मिल जाएगी। एग्जैक्टली,
कई बार होता है पेपर इतना हलवा आया कि आप 60-65 नंबर ला के भी रैंक हजारों में है।
एग्जैक्टली,
तो ऐसा हो जाता है, तो आई थिंक एडवांटेज है सर, ये तो अच्छी बात है।
इवन द इजी पेपर जब आता है तो थोड़ा सा मतलब एक सबके लिए फिर वो यूनिफॉर्मिटी सी हो जाती है उसमें, मतलब एक अच्छा बच्चा निकल भी नहीं पाता है।
और सर मुझे ऐसा लगता है पर्सनली, अगर आप गेट को देखें सर, तो मुझे लगता है कि इन टर्म्स ऑफ क्वालिटी एंड स्पेशली इफ यू टॉक अबाउट द टेक्निकल एरिया, आई थिंक गेट से अच्छा पेपर कोई नहीं होता है। और गेट हमेशा क्या करता है ना, वो आपको एक रास्ता दिखाता है।
एग्जैक्टली,
टेक्निकल सिर्फ ये नहीं है, टेक्निकल में ये भी है।
एग्जैक्टली,
टेक्निकल में जो आप मशीन पढ़ रहे थे, पावर इलेक्ट्रॉनिक्स पढ़ रहे थे, जो भी कुछ वो तो सर डील करेंगे, उसमें सिर्फ इस डायरेक्शन में आपको नहीं सोचना, ऐसे भी सोच सकते हैं। तो इस हिसाब से गेट का पेपर हमेशा से सरप्राइजिंग होता है दोस्तों, और इस बार भी। और दोस्तों लेटेस्ट न्यूज आ गई है, राकेश सर इज कमिंग अप विद सम सॉल्यूशन। सो गाइस जस्ट क्विकली हिट द लाइक बटन एंड शेयर विद योर फ्रेंड्स एंड कलीग्स एंड कीप जॉइनिंग द सेशन। राकेश सर।
Yes guys, so I've got just 2 questions and let's discuss the 2 question। बहुत ही easy से question मिले हैं अभी, ठीक है, और पूरा पेपर को देख के लग रहा है कि it's going to be on the easier side। Okay, तो चलो। Okay, एक simple graph based question है, which of the following options represent the given graph? Which of the following options will represent the given graph? And you have the option number A, right? X2 raised to the power minus mod x. Option number B है mod of x 2 raised to the power minus x. Option number C है x2 raised to the power minus x. And dear, the option number D is x square e raised to the power minus mod x. Yes guys, chalo. Okay, Akash says we have got this time MSQ in aptitude for the first time. Great. Okay, can you share that question, Akash? यहाँ पे या तो Telegram में, or else we are also receiving the questions, तो बहुत जल्दी उसको ले आएंगे. Yes guys, what is your opinion on this simple सा question है, बता दीजिए इसका आंसर. Okay, simple सा question है, इसका आंसर बता दीजिए quickly. Yes, very simple question and you can solve it by a very simple logic. Okay, you can solve it very simple logic. अच्छा, many of you are telling questions थोड़े different category के थे. No problem, अभी तो 2-3 question आए हैं, हम और भी देखते जाएंगे इसको. Tell me guys, anybody with the answer? अरे chat में एक बार यहाँ देख लेता हूँ. चलो. Guys, the simple logic is, इसका क्या simple से simple logic हो सकता है, आप ये देखिए ना. This is a odd function or not? Tell me. बिल्कुल भी ऐसा नहीं कि फंक्शन डिराइव करना है, ठीक है. दिस इज अ ऑड फंक्शन और नॉट, टेल मी यस और नो, राइट. द राइट हैंड साइड इज जस्ट द इन्वर्टेड इमेज ऑफ द लेफ्ट हैंड साइड. इट इज अ ऑड फंक्शन, इट हैज अ ऑड सिमेट्री. अच्छा, ठीक है, और बिकॉज इट हैज अ ऑड सिमेट्री तो एफ ऑफ माइनस एक्स शुड बी माइनस ऑफ एफ एक्स, ठीक है. अब अगर ऑप्शन नंबर डी को देखें तो इट इज प्योरली इवन, एक्स स्क्वायर भी इवन है, मॉडुलस फंक्शन भी इवन होता है, तो डी कैन नॉट बी द आंसर, राइट. अब अगर हम ऑप्शन नंबर सी की तरफ जाते हैं, ध्यान देना, सो व्हेन यू प्लेस माइनस, माइनस एक्स हो जाएगा बट 2 पावर प्लस एक्स, सो दैट विल नॉट बी सैटिस्फाइंग। सिमिलरली ऑप्शन नंबर ए मॉडुलस इवन फंक्शन है, ठीक है, तो माइनस एक्स नहीं आएगा, ऑप्शन नंबर ए ही जाने वाला है ना भाई, ऑप्शन नंबर ए जाने वाला है कि नहीं जाने वाला है? देखो, इफ द एफ ऑफ एक्स इज एक्स ई पावर माइनस मॉड एक्स, ई नहीं है 2 है, सॉरी, ऑल दी ऑप्शंस आर 2 ओनली, शायद वो बाय मिस्टेक लिख दिया मैं। देखो डियर, तो x 2 raised to the power minus mod x, what is going to be the value of f minus x? That is minus x 2 raised to the power minus of mod x, that is minus of fx. Yes or no? A is the correct answer. अब बिल्कुल इस पे फंक्शन पे कोई रिसर्च करने की जरूरत नहीं थी, इट इज अ क्वेश्चन बेस्ड ऑन ऑड सिमेट्री, इट इज अ क्वेश्चन बेस्ड ऑन ऑड सिमेट्री, बिल्कुल सिंपल सा क्वेश्चन था, ठीक है। चलो एक और क्वेश्चन यहां पे ले लेते हैं क्विकली, एक और क्वेश्चन यहां पे ले लेते हैं। व्हाट इज देयर, ये रहा, बहुत ही सिंपल प्रोबेबिलिटी का क्वेश्चन, इससे ज्यादा सिंपल प्रोबेबिलिटी का क्वेश्चन मतलब मुझे नहीं लगता इससे बड़ा गिफ्ट आपको आईआईटी कोई दे सकता है। सो गिवन अ फेयर 6-sided डाइस, ओके, वेयर द फेसेस आर लेबल्ड 1 2 3 4 5 6, ठीक है, एक डाइस बेस्ड क्वेश्चन है, लेबल्ड 1, सबको पता है डाइस में 1 to 6 होता है, नथिंग न्यू इन दैट, ओके। व्हाट इज द प्रोबेबिलिटी, क्वेश्चन इज बेस्ड ऑन डाइस dear, what is the probability, okay, what is the probability of, just a second, what is the probability of getting 1 on first roll, okay, and 4 on second roll? 1 on first roll and 4 on the second roll, and 4 मतलब the dice is tossed 2 times, ठीक है, and what is the probability of getting this event? डियर वेरी वेरी सिंपल ना, इसके ऑप्शंस, अच्छा ऑप्शंस भी हैं, ठीक है, करेक्ट, ऑप्शंस लिख देता हूं, द 1/8, 1/36, 5/6, 1/6, 1/8, 1/36, 5/6 and 1/6. Tell me guys, without using the pen and paper ये आंसर आ जाना चाहिए. Tell me. Now look into the options. Okay, आपके पेपर में options could be differently arranged. Look into these 4 options and tell me how much time do you take to solve this. साफ बोला है, getting 1 on the first roll and 4 on the second roll. मतलब it is definitely the outcome 1,4, and when a dice is tossed 2 times, you have total sample space of 36 outcomes, right? This is only one event, so probability become 1 divided by 36. I'm telling you ना, इससे easy शायद probability का question IIT क्या पूछेगा आपसे, okay? Because you don't have to apply any counting, बिल्कुल दिमाग नहीं लगाना है, आंसर आपके सामने, right? Okay, so one of the easiest. तो गाइस, आशुष हंगरा सर कौन सा सब्जेक्ट ले आया?
सर पावर इलेक्ट्रॉनिक्स।
ओ माय गॉड, तो वेरी वेरी कोर पावर इलेक्ट्रॉनिक्स से क्वेश्चन यहाँ पे आपके सामने आ गया है।
तो चलिए दोस्तों, पावर इलेक्ट्रॉनिक्स से स्टार्ट करते हैं। और पावर इलेक्ट्रॉनिक्स के 2 क्वेश्चन मेरे पास आए हैं, आप एक बार वेरीफाई कर दीजिएगा कि क्वेश्चंस जो हैं वो करेक्ट हैं या फिर क्वेश्चंस में थोड़ा मॉडिफिकेशन है। जरा देखिए दोस्तों, क्वेश्चंस जो है मेरे पास, एक मिनट थोड़ा सा आप कीजिए इसको। ओके, तो जरा देखिए दोस्तों, एक क्वेश्चन है मेरे पास, आप लोग बताइएगा कि ये करेक्ट क्वेश्चन है या नहीं है। यहाँ पे आपके 2 स्विच लगे हैं और ये डायोड लगा हुआ है, यहाँ पे फ्री व्हीलिंग डायोड है, और एक डायोड आई थिंक यहाँ पे भी लगा हुआ है। एक बार कंफर्म कीजिए दोस्तों कि क्या ऐसा ही क्वेश्चन था या केवल एक ही डायोड लगा हुआ था। और यहाँ पे है करंट सोर्स, और यहाँ पे मेरे पास है एक सोर्स है 20 वोल्ट का, 20 वोल्ट का वोल्टेज सोर्स है मेरे पास। एक बार आप कंफर्म कीजिए, और जो करंट सोर्स है उसकी वैल्यू जो है वो है 5 एम्पियर। एक बार कंफर्म करें, मुझे बताना है एवरेज आउटपुट वोल्टेज। और जो S1 और S2 का जो स्विचिंग इंस्टेंट है वो आपको दे रखा है। जरा देखिए, स्विचिंग इंस्टेंट कुछ ऐसे दे रखा है, यहाँ पे 3 सेकेंड है, और उसके बाद ये 10 सेकेंड पे फिर से ऑन होता है, और नेक्स्ट 13 सेकेंड तक के लिए ऑन रहता है। ठीक है, ये आपका 10 सेकेंड पे है और फिर 13 सेकेंड तक ऑन है। दूसरा जो S2 का जो दे रखा है, ये मेरा S1 का है, ऐसे ही S2 का भी दे रखा है दोस्तों। S2 का जो स्विचिंग इंस्टेंट दे रखा है वो है 5 से लेके और 6 तक, 5 से लेके 6 तक कुछ इस तरह का है, ऑन है, और फिर 10 पे आप मतलब फिर उसके बाद ऑफ है। तो आप अगर ध्यान से देखें, 5 से लेके 8 तक ध्यान से अगर आप देखते हैं, तो मैं ये कह सकता हूं कि 3 to 5 3 to 5 जो है no switch is conducting. एक बार confirm कीजिए, please confirm whether this question is correct or not. The switching frequency is 100 kilohertz. Switching frequency is 100 kilohertz and the time period is in this time is in microsecond. एक बार confirm कीजिए दोस्तों. Please confirm me whether the question was same or something different. So this is my V naught T, output voltage V naught T. We need to calculate the average output voltage. Please confirm, guys. Please confirm. 5 to 8 second है sir. 5 to 8 second or microsecond. 5 to 8. Yes, this is 5 to 8 and 0 to 3. 0 to 3 S1 on है. And the diagram, please confirm the diagram also. Please confirm the diagram also. Let me check the diagram once again because some other student also sent me the same question. So let me check, guys. Let me check the same question. Yes, the diagram is confirm. I think the diagram is same. So let's calculate this question. Now you can see that there are two switches, S1, S2, and there is a current source. The current is continuous. You can see that S1 is on for 0 to 3 seconds. So from 0 to 3 seconds, so from 0 to 3, S1 is on. This is on. Now the supply voltage is directly connected to the output. So you can say that the output voltage is 20 volt. Okay, output voltage is 20 volt. Output voltage is 20 volt. You can say from 0 to 3 seconds. Now from 3 to 5, no switch is conducting. It means the current is freewheeling. So the output voltage is 0. So from 3 to 5, output voltage is 0. You can see that output voltage is 0. Now from 5 onwards, from 5 to 8. Now 5 to 8, this switch is open and this switch is closed. This switch is closed. Now you can see that from 5 to 8, since this switch is closed, S2 is closed, so the output voltage will still be 0. Okay, output voltage will still be 0 because the current will flow via this path. So output voltage from 5 to 8, it will be again 0. It will be again 0. Okay, some is saying diagram is correct. Okay. So output voltage from 5 to 8 is 0. Now from 8 to 10, you can see that 8 to 10. 8 to 10, again current need the path. So there is no switch which is open. So now you can see that since there is no switch open, so current will freewheel. Current will freewheel, so the output voltage will again 0. Now from 10 to 13 again. From 10 to 13, you can see that S1 is on. If S1 is on, then output voltage will again be 20 volt because this terminal is available here and this terminal is directly connected to the output. So you can say that the output voltage will be 20 volts. So the output voltage shape will be like this. Now be confirmed that whenever this switch is not conducting, whenever this switch is off, current will freewheel. Okay, and whenever this S2 is on, then also the current will freewheel. Current will freewheel like this. Okay, so I hope it is clear to everyone. Now this is the output voltage shape. I need to calculate the average value. So the time period is 10. So the time period is 10. You can see that this is the time period and the area under one period is 20 into 3. So 60 is the area. 60 is the area of this shape divided by the time period 10. So the average output voltage came out to be 6 volt. Tell me, guys, how many of you have correct this? Tell me, guys, tell me. So the answer is 6 volt. Let's come to the next question, guys. Let's come to the next question. So if this diagram is correct, I hope it is clear to everyone. If this diagram is correct, then answer is 6 volt. Please check whether the diagram is correct or not. Now let's come to the next question, guys. Okay, so let's come to the next question, guys. So the next question is so the next question is again from power electronics. So let me tell you the question again, and the question is let me check the question because next question is again from power electronics, and please confirm me the diagram because I don't know whether the diagram is correct or not. Okay, so let me draw the diagram again. So I have this thyristor and there is one more diode connected here. Please check this, guys. There is one more thyristor. Actually, it's thyristor T2. And there is one diode. One diode, and this is a thyristor. Please tell me whether the question is correct or not. And you have a current source. And you have a current source of 10 ampere. Current source of value 10 ampere. Okay. and I connect a source here. Okay, the source value is 100 sine of pi t. 100 sine of pi t. Okay, this is the source value. This is the source value. So the question is, please tell me alpha is given as 60 degree. Alpha is given as 60 degree, and this voltage is V naught T. Now, what we need to calculate is tell me what we need to calculate. Find power to 10 ampere current source. T1, T3 alpha is given as 60 degree, and for T2 the firing angle is 240 degree. Okay, for T2 the firing angle is 240 degree. It is given in the question. For T1, T3, this is T1, this is T3, and this is T2, and this is diode D. For T2, for T1, T3, firing angle is 60 degree, and for T2 the firing angle is 240 degree. Please confirm whether it is correct or not. The ripple for the tell me whether it is correct or not, because the statement which is written is not clearly visible to me. So please tell me, guys, whether this is correct or not. Whether this is correct or not. Tell me, guys. Tell me, everyone, the question. Please please confirm me the statement of the question. Please confirm me the statement of the question. V naught T. We need to calculate the power absorbed by 10 ampere. Is it correct? We need to calculate the power absorbed by 10 ampere. Tell me, guys, is it correct? Okay, Munawar Hussain is saying microsecond. Okay, in the previous question, Munawar is saying it was microsecond. It was microsecond. So let me check that. Yes, in this question he is saying that this is microsecond. It doesn't matter whether it is in microsecond or in millisecond or in second. It doesn't matter, because whenever you are calculating the average value, then you have to multiply this 3 with this 20, so it will become 60, divide by the time period length. So now if it is 3 microsecond, then this will be 10 microsecond, and if you take the ratio, it will cancel. Whether it is in second or in microsecond, it doesn't matter. Okay, so I hope it is clear. So the answer will be 6 volt. Answer will be 6 volt. Okay, let's come to the next question, guys. So the next question is this question. It was 100 sine pi t. 100 sine pi t. 100 sine 100 pi t. Okay, this is written 100 pi t. Is it correct, guys? Tell me. Let me check. 100 sine pi t or 100 sine 100 pi t. So tell me, everyone. And the alpha for T2, T3 was 60 degree, and for T1 alpha is for T2 alpha is 240. For T1, T3, it's 60 degree. Is it correct or not? Tell me, everyone. Is this question correct or not? Tell me, guys. Tell me fast. So let me check the original file also, because some other student also sent me the same thing. 3 single phase rectifier consisting of 3 thyristor are 1 diode. Find power to 10 ampere constant source. Alpha for T1, T2, and okay. The resistance for the resistance positive, I don't know what is written. Okay, so it is 100 pi t. This is 100 sine 100 pi t. Let me erase this. Okay, so this was 100 sine 100 pi t. Tell me, guys, is it correct now? 100 sine 100 pi t. Now let's try to solve this question. Let's try to solve this question. We have this as supply voltage. Okay, now this is my omega t. This is 0. This is 180 degree. Okay, 180 degree. This is 360 degree. Now the firing angle for T1, T3. Firing angle for T1, T3 is 60 degree. It means T1, T3 are fired at this instant, pi by 3. Okay, at this instant, T1, T3 will get fired. Okay, and the current will flow via T1, T3. So the output voltage will be same as the supply voltage. Whenever T1, T3 will conduct, the output voltage will be same as the supply voltage. Okay, so you can say that this output voltage from this 60 degree to 180 degree, output voltage will be same as the supply voltage. I hope it is clear. Now from 180 to 240, again we have 60 degree interval. At this instant, the thyristor, which thyristor, tell me? The thyristor T2 will get fired. The thyristor T2 will get fired. But what will happen from 180 to 240? Tell me, guys. What will happen from 180 to 240? Will thyristor T1, T3 will conduct? They still continue conducting, or diode will start conducting? Actually, the diode will start conducting. Why? Because this side has become positive, this side has become negative. So the diode will get forward biased. Okay. So now the current will flow via T3 and D. So you can say that from 180 to 240, T3 and diode D will conduct, and the output voltage will be 0. Okay. So up to this instant, the output voltage will become 0. At this instant, at this 240 degree, T2 will get fired. As soon as you fire the thyristor T2, what will happen, guys? The current will change its path to diode D and thyristor T2. Okay, so the current will flow through D and T2, and the output voltage will be negative of the supply voltage. So this will be my output voltage. I hope it is clear. Okay, so it will be up to 360 degree. And then after, again, at this instant, tell me, guys, what will happen? After 360 degree, tell me what will happen. At 360 degree, again, at this instant, we are firing T1, T2. But if you are firing T1, T2, before that, diode D and thyristor T2 were conducting. Now what will happen at this instant? At this instant, T1, T3 are not get fired. Okay, remember. So the current will continue flowing via T2 and diode D. So it means the output voltage will go negative. Okay, output voltage will go negative, and at this instant, again, it will become positive, and it will become 0 up to this instant. I hope it is clear. Okay, so the shape will be like this. Okay, so the shape, output voltage shape will be like this. I hope it is clear to everyone. Okay, this will be my output voltage wave shape. Okay, let me repeat this again. Let me repeat this again. At pi by 3, at 60 degree, you are firing T1, T3. So T1, T3 will start conducting. Okay, and the output voltage will be same as the supply voltage, but it will be output voltage will be equal to supply voltage only up to pi instant, only up to 180 degree. What will happen after 180 degree? From 180 to 240, what will happen? From 180 to 240, actually the diode will get fired. Why? Because this side will become positive and this side will become negative. So you can say that this thyristor and this diode are under common anode configuration, common cathode configuration. So the anode voltage, whichever has the higher anode voltage, that will start conducting. So diode will start conducting at this instant, and now the current will flow via T3 and diode D. Okay, via this path, the current will flow and the output voltage will remain 0. Now, what will happen at 240? At 240, you have fired thyristor T2. If thyristor T2 get fired, then the current will flow via T2 and diode. Now, output voltage will be negative of the supply voltage. So this will be my output voltage. Now, what will happen at 360 degree? At 360 degree, T1, T2 will not get fired. So current will continue flowing via diode and T2, and the output voltage will remain as negative of this voltage. So output voltage will remain like this. Okay. So this will be the shape of the output voltage. Now I need to calculate the average output voltage. Check the period. So the period is, tell me the period, guys. The period of this wave is, tell me what is the period. Tell me the period, guys. Period is, I think, this is not 180. Period is 360 degree. You can see that this peak, this triangle will repeat at this point now. So you can say that the period is 360 degree. Period is 360 degree. Now I need to calculate the area under one period. Now tell me, what is the area under one? This is the 360 point. Okay, let me erase this, and this point is 360 degree point. Okay, now I need to calculate the area under one period. How to calculate the area under one period? First calculate this area. Okay, first calculate this area, or rather you can take, no, don't take 0 to 360 degree. Rather you take alpha to, this is alpha to 2 pi plus alpha. Okay, this is my one period. Now I need to calculate the average value, and average value will be area under one period divided by the time period. So the area under one period will be, first let's calculate this area and then calculate this area. Okay, so tell me, what is this area, guys? What is this area? This area will be integrate from this point alpha to pi, and the peak value is 100 sine of omega t d omega t. Okay, plus this area. What is this area, guys? What is this area? So I integrate this from this 180 plus alpha, so pi plus alpha to 2 pi plus alpha. Okay, pi plus alpha to 2 pi plus alpha. Now what is the equation of this wave? What is the equation of this wave? Equation of this wave will be minus of Vm sin omega t. Okay, minus of 100. because it is the opposite of this supply, na? So minus of 100 sine of omega t d omega t. Okay, this is the area under one period divided by time period. Okay, divided by time period is 1 upon 2 pi. Okay, I hope it is clear. So I found the area under one period divided by time period. You can see that the area, the time period is, you can see the time period is 2 pi. So 1 upon 2 pi from alpha to pi, this is the area, plus from pi plus alpha, this is pi plus alpha, to 2 pi plus alpha. Okay, again this is the wave. So now let's calculate this. Take 100 common. So if I take 100 common, so 100 upon 2 pi. Okay, now tell me what is the integration of this. Integration of sine is minus cos, upper limit minus lower limit, so it will be 1 plus cos alpha. Okay, 1 plus cos alpha. Now let's come to this. This is minus sine. Integration of minus sine is plus cos. Okay, integration of minus sine is cos, upper limit minus lower limit, so plus of cos of 2 pi plus alpha, this is upper limit, minus lower limit cos of pi plus alpha. Okay, I hope it is clear. So this is my average output voltage. Now we can calculate this. Cos 2 pi plus alpha is again cos alpha, and cos pi plus alpha is again cos alpha, minus cos alpha, and this minus will become plus. So it will become 100 upon 2 pi, 100 upon 2 pi, 1 plus, tell me guys, cos alpha plus cos alpha plus cos alpha. It will become 3 cos alpha. Okay, and alpha is 60 degree. So cos 60 degrees half. So 1 plus 3 by 2. Okay, 1 plus 3 by 2 is 5 by 2. So what I can write is 100 upon 2 pi, 100 upon 2 pi into, tell me guys, into this value, and this value is 1 plus 3 by 2. 3 by 2 is 5 by 2. Okay, so it will become 5 by 2. Is it clear guys? Tell me everyone, is it clear? So 1 plus 3 into cos 60. Cos 60 is 1 by 2. Okay, so it will become 5 by 2. Now I can cancel it. So it will be 25. Okay, 25 into 5 is 125. 125 upon pi. 125 upon pi is the output average value. Multiply by 10. So 125 by pi multiply by 10 is the output average voltage. So the output average voltage will be 1250 upon output average voltage, this 125 upon pi into 10. This is the power absorbed. This is the power absorbed by the current source. Now you can calculate the decimal value. So the decimal value you can calculate from this, and the answer will be, tell me guys, what is the decimal value? Tell me everyone. Do it fast. Do it fast. What is the decimal value? Do it fast everyone. Let's calculate the decimal value. Okay, so let's calculate the decimal value, and let me tell you the decimal value also. So it is 1250 divided by 3.14. So the answer came out to be 398. Okay, answer came out to be 398 watt. If it is correct, if the statement is correct, then the answer will be 398 watt. Now let's proceed to the network theory. Network theory, sir? Okay, so network theory questions. So you can discuss with sir. And
so hello everyone, how's your exam? I hope आप लोगों का अच्छा exam गया होगा. So tell me, how was the level of network theory paper, network theory questions actually? So, okay, so we are going to discuss two questions of network theory right now, and one of the question is from two-port network. As you can see, can you tell me the data is correct? Tell me guys, the data is correct or not? Also tell me, in this question we have to find out the power dissipate across the load resistor. Okay, right. So how to solve this question? Question is simple. Just if you observe this question has been asked many times. This type of question has been asked many times in our previous year GATE examination. Also, we have solved this type of question in our vision batch and also in our app classes. So I hope you have done this question right. So let's discuss this question. So if you observe this one, you will see. First of all, we have given a two-port network. The Y parameter is given. Wait a sec. So Y parameter is given. Also, you can see one branch of 3 ohm is connected parallel to it. Whenever the parallel branches of parallel networks are connected together, we have to add those branches, add those network, right? So let's discuss first of all. Find out the Y parameter of this particular branch. Okay. This is plus minus V1. This is plus minus V2, I1, I2. Okay. So if you simply apply the KVL, it will be minus V1 plus 3 times of I1 plus V2 equal to 0. From here, I1 comes out to be V1 by 3 minus V2 by 3. Yes or no? Now, if we have a I1, we can also find out the equation in terms of I2. So in terms of I2, we can write down from the particular network that I2 is equal to minus of I1. So from here, I2 comes out to be minus V1 by 3 plus V2 by 3. Okay, fine. Now from these two equations, equation number 1 and equation number 2, what will be the Y parameter here? The Y parameter is going to be 1 by 3 minus 1 by 3 minus 1 by 3 1 by 3, or basically we can change it into decimal, so it will be 0.3 minus 0.3 minus 0.3 and 0.3. Okay, fine. Now these two networks are parallel, so we can add both of these Y parameter. So let's add these Y parameter. Extra page, yeah, notes. Okay. Okay, so the total Y parameter will be, we have Y parameter of single branch 0.3 minus 0.3 minus 0.3 0.3, right? And here plus Y parameter, which is given in a question. I guess it is given around 2.3. Let me see the question. So it is 5 minus 2.5 minus 2.5 or 1. So it will be 5 minus, wait a second, 2.5 minus 2.5 or 1. Okay, let me check. Yeah, correct. Now if we add these two, it comes out to be 5.3 minus 5.3 minus 2.8 minus 2.8, and it's 1.3. 1.3. Okay, and actually it is only 1. It is only 1. Okay, so this comes out to be a Y parameter, बच्चों. Now if I have a Y parameter, I can find out the equation of overall parameter, है ना? कैसे? We can simply write down, we can simply write down in a general form that I1, I2 is equal to 5.3 V1 minus 2.8 V2 minus 2.8 V1 plus 1.3 V2. Now this is the equation number 3rd. Now this is equation number 4. Now these two equations actually represents that network equations of the complete network. Let me show you the question again. Now see here. Now if you see, this is actually plus minus V1. If you see, actually this is actually plus minus V1. This is complete I1 plus minus V2. This is completely I2. So from here, one more equation you will get, that V2 is equal to minus 6 times of I2. Very, very important equation. Here you can see, because the current I2 is flowing in this direction, it will be plus and it will be minus. So it comes out to be minus 6 times of I2. Correct? Yes or no? And from here, I can say V1 comes out to be 20 volt, because there is no any other element connected with 20 volt. So V1 comes out to be 20 volt. Simple. Now let's bring to our remaining equations. Okay, so one more equation we got, that V1 is equal to 20 volt. Let's suppose it is equation number 5, and V2 is equal to minus 6 times of I2, equation number 6. Now you have a 4 equation. You have to find out the current I2. Why? Because we need to find out the power dissipate across load resistor. So let's see how you will solve this equation. Can anybody tell me which equation I will put in which equation? Here you can see, bachcho, carefully. If I put V2, or I can say equation number 6, equation number 4, then the whole equation comes out in form of I2 and V1. And V1 we already know. So if V1 we know, from here we can find out I2, and hence we can find out the power dissipation. So simply I will put equation number 6 into equation number 4. Okay, this equation. 0.8 V1 here, minus 7.8, I guess, correct, minus 7.8 I2. From here, I2 comes out to be minus 2.8 divided by 8.8 multiplied by V1. Let me check. Now V1 given is 20 volt from the equation number 5. So it comes out to be minus 2.8 divided by 8.8 multiplied by 20. So let me solve this equation. And tell me, have you solved this question? Yes or no? Have you solved this question? So, bachcho, it comes out to be 6.36 minus 6.36. Okay. अगर किसी डेटा में कोई गलती हो तो बता देना, ठीक है। तो -6.36 comes out here. Finally, we need to find out power across the load. So that will be I2 square multiplied by RL. So 6.36 whole square multiplied by RL. RL given is 6. So from here, it comes out to be 242.69. Okay, so you are getting 242.69 watt as the answer. So tell me, are you getting this question? Are you getting this answer? Yes or no? हाँ बट मैथ फैक्ट्री के लिए अभी राकेश सर आएंगे, चिंता मत करो. जस्ट आफ्टर नेटवर्क थ्योरी ही विल कम एंड ही विल डिस्कस दैट. ओके, सो एनीबडी सॉल्व दिस क्वेश्चन? नोबडी? ओके, कोई नहीं. So let's get back to next question of a network theory, but it's a good question. This question has been asked many times in your GATE examination previous year. Also, we have done this question in our vision class. Now let's discuss the next question. A very simple question. I'm not sure, but if I make a guess, this question comes for 1 mark, right? So it's a very simple question. We have given few values here. That I1 is 8 ampere, V1 is 8 volt. We need to find out the voltage between VAB. Okay, so let's discuss. So first of all, see here that these two 3 ohm resistors are in parallel. Similarly, here you can see that 2 ohm and 2 ohm are in parallel because they have shared the common node. So we can simplify this circuit like this. That we have 0.5 ohm here. 3 ohm and 3 ohm are parallel, so it will be 1.5 ohm. 2 ohm and 2 ohm are parallel, so it comes out to be 1 ohm, right? Finally, we have V1 also. So here you can see the network becomes so much simple, right? अब क्या होगा, हमें सिंपली इस वोल्ट नोड के अक्रॉस, टर्मिनल के अक्रॉस वोल्टेज फाइंड करना है, VAB, राइट? पूजा सेट 4 वोल्ट, लेट्स सी 4 वोल्ट आएगा या नहीं. So we have to find out the voltage across these two terminals. So here you can see we can apply the voltage division rule here because we have 2 branches in series and connected across the terminal voltage V1. So if I apply the voltage division rule, it will be V1 multiplied by 1.5 divided by 0.5 plus 1.5. So 8 multiplied by 1.5 divided by 2, it comes out to be 6 volt. है ना? Let me check calculation. Yeah, correct. So it comes out to be a 6 volt. Okay, simple question था networks का, ये I guess 1 mark का ही होगा, है ना? So we have discussed 2 questions of network theory till now. One from the 2-port network, one from a simple basic analysis. So now Rakesh sir will come and he will discuss the remaining questions.
Thank you, sir. So guys, control system, maths aptitude. Okay, few questions I have, combination of them. So let's get started discussing all of those questions. Okay, where is that question? Yeah, चलिए एक मैथ्स के क्वेश्चन के साथ स्टार्ट करते हैं गाइस. एक मैथ्स के क्वेश्चन के साथ स्टार्ट कर लेते हैं. Yes guys, so yeah, एक बार बताते जाइए, how was your paper? Okay, how was your paper? Unless and until we get all the questions, we'll not comment because अभी तक के questions तो tough नहीं बता रहे हैं. But yeah, some of you are telling tough, so let's wait for the other questions. Okay, so I'm bringing you 1 question from maths here, 1 question from aptitude and 2 from control system. So एक question है. Okay, there is a vector W given which is 1, 2, 3 का transpose. 1, 2, 3 का transpose. Okay, question is find a vector. Simple question है. Find the vector normal to the plane defined by W transpose X is equal to 1, right? And your options are 3, 0, -1 transpose. Option number B है sir 1, 2, 3 का transpose. ऑप्शन नंबर सी है सर -2 -2 2 and 2, नहीं -2 and 2 ट्रांसपोज. और ऑप्शन नंबर डी बोला है 3, 2, 1 का ट्रांसपोज. टेल मी डियर, वेरी सिंपल, ठीक है, एमसीक्यू क्वेश्चन है, कितने मार्क्स का, यू कैन ऐड ऑन टू दैट इंफॉर्मेशन, राइट? आई डोंट हैव कि कितने मार्क्स का है. इफ यू रिमेंबर गाइस, ये क्वेश्चन कितने मार्क का है, तो यू कैन ऐड ऑन टू दैट इंफॉर्मेशन. 1 मार्क का हो सकता है मेरे हिसाब से, बट यू कैन ऐड ऑन टू दैट इंफॉर्मेशन गाइस. आप लोग पेपर दे के आए हैं आज भी. ओके, व्हाट इज अ वेक्टर नॉर्मल टू द प्लेन डिफाइंड बाय. तो सर एक बार देख लेंगे ना, W ट्रांसपोज X इक्वल टू 1 कैसा प्लेन बनाएगा. सो W ट्रांसपोज that is 1 2 3 and X will be the unknowns X Y Z equal to 1. So the equation that is going to come X plus 2Y plus 3Z equal to 1. Yes guys, anybody able to recall ये कितने marks का question है. Okay, so this is like a surface phi equal to constant and vector normal to a surface can be obtained by the concept of gradient of phi. Can be obtained by what? Can be obtained by the gradient of phi. Tell me. Can be obtained by gradient of phi. इतना ही तो करना है. What is the vector normal to the plane defined by and vector normal to the surface is equal to the gradient. अब कितना हो जाएगा gradient? del phi by del x लिया तो only 1 आएगा. del phi by del y 2, del phi by del z 3. So I plus 2j plus 3k, writing it in the vector form 1 2 3. तो आंसर आया. बोलिए, do you get it as 1 2 3? Do you get that as 1 2 3? Yes, option number B is the correct option. It is 1 2 3. Okay, 1 2 3. It is 1 2 and 3. Wait, weightage PPT send some electrical faculty also. Yes, चलो ठीक है. आई थिंक किसी को मार्क्स याद नहीं आ रहा है. नो इश्यूज, कोई बात नहीं. ठीक है, आई गेस 1 मार्क का होना चाहिए. चलिए अगले क्वेश्चन की तरफ चलते हैं. ओके, लेट मी टेक द नेक्स्ट क्वेश्चन हियर. व्हाट इज दैट नेक्स्ट क्वेश्चन विथ मी? ये ले लीजिए. नेक्स्ट क्वेश्चन है, tell me the number of triangles in the given picture. The number of triangles in the given picture. देखिए ऐसा ही कुछ डायग्राम था क्या? ऐसे कुछ डायग्राम था और ऑप्शन रख देता हूं मैं यहां पे. एक है 12, दूसरा है 16, तीसरा है 20 और चौथा है 24. यस, टेल मी टेल मी टेल मी टेल मी, इसका आंसर क्या निकाला? टेल मी, बोलिए गाइस, कितना होना चाहिए ये? बोलिए कितना होना चाहिए ये? ओके, प्रियंका सेज 20. गाइस शेयर करते जाओ अपने ओपिनियन को भी, ताकि आपने जो किया है पता चलेगा. ओके, देखो अगर पहले इसको एक स्ट्रैटेजिकली हम सॉल्व करें. सपोज इफ आई कंसिडर दिस 1 हाफ, ठीक है, लेकिन सिर्फ एक हाफ से नहीं होगा. ठीक है, लेकिन एक मैं अप्रोच आपको बता रहा हूं. पहले अगर एक हाफ लिया तो एक तो अच्छा, मेनी ऑफ यू आर कमिंग विद 20. बहुत बढ़िया, राइट, बहुत ही बढ़िया, बहुत ही बढ़िया. शुभम, क्वेश्चन तो एज फार एज द मेमोरी बेस्ड क्वेश्चन वी हैव गॉट, क्वेश्चन यही है. ठीक है, अगर आपके पास कोई दूसरा इमेज है, नहीं, अच्छा डिलीट कर दिया कमेंट, बहुत बढ़िया. ठीक है, तो ये एक बिगर ट्राइंगल तो है, केवल हाफ पोर्शन की बात करते हैं. फिर ये 2 ट्राइंगल में, देखो एक बड़ा था, फिर मैंने उसको 2 ट्राइंगल में डिवाइड किया. ठीक है, सो आई हैव 2 मोर ट्राइंगल्स, ऑल द ट्राइंगल्स ऑफ एनी पर्टिकुलर साइज. ठीक है, नाउ लेट मी टेक दिस मिडिल लाइन. इस मिडिल लाइन को लेते ही ऊपर एक और बड़ा ट्राइंगल आ गया. ठीक है, और उसके 2 सब पार्ट्स भी बन गए. क्लियर, उसके 2 सब पार्ट्स भी बन गए. ओके, देन कम हियर. ओके, देन कम हियर. राइट, नीचे आते ही यहां पे 1 + 1, 2 मोर ट्राइंगल्स और ये 2 बड़े वाले सेंट्रल ट्राइंगल्स. कितने हो गए? इसको एक बार चेक करने की नीड है. राइट, ये कितने हो गए? इसको एक बार चेक करने की नीड है. टेल मी. या चलो एक बार फिर से इसको हम देख लेते हैं. ठीक है, इफ यू हैव एनी कंफ्यूजन्स. क्लियर हुआ? देखो, इफ यू हैव एनी कंफ्यूजन, एक बार इसको फिर से देख लेते हैं, क्योंकि मैंने स्टेप बाय स्टेप आपको बता दिया ना. ठीक है, तो स्टार्ट करते हैं. ओके, ये एक बड़ा ट्राइंगल. ठीक है, देन इट हैज 2 ट्राइंगल्स. देन इट हैज 2 ट्राइंगल्स. यहां पे आइए, सेंट्रल लाइन, ऊपर एक बड़ा ट्राइंगल प्लस 2 मोर ट्राइंगल्स. सिमिलर पिक्चर है ना, आइडेंटिकल ट्राइंगल हुआ. नाउ create these lines, so you have 1 here and 1 here, you have 2 more total. ठीक है, तो एक्चुअली कितना हुआ? दिस इज इक्वल टू द 8. राइट, अगर ये 8 है तो लोअर वाले पोर्शन में भी 8 होगा, तो नंबर 1 8 × 2 इक्वल टू 16 हो गया. लेकिन अब व्हेन यू कम टू द बिगर पिक्चर, दिस ट्राइंगल विल बी कंबाइंड. राइट, सो आई हैव 1 मोर हेयर. ठीक है, एंड आई हैव 1 मोर हेयर. सिमिलरली तो 2 और ऐड कर देंगे. मैं यहां से इरेज भी करते जाता हूं. ठीक है, +2. राइट, और अभी हमने इस डायगोनल के अलोंग ब्रेक किया था. व्हेन यू ब्रेक अलोंग दिस ट्राइंगल, देयर आर 2 मोर ट्राइंगल्स टॉप एंड बॉटम में, सो ऐड टू 2 मोर. टोटल आंसर 20, आप में से कई लोग 20 दे रहे हैं, 20 ही होगा। इसको बिल्कुल भी कोलिनियर नॉन कोलिनियर पॉइंट से ट्राई करने का मत सोचना, लेंदी होगा, राइट। इट इज अ ऑब्जर्वेशन मेंटल रीजनिंग क्वेश्चन, इट इज नॉट अ कॉम्बिनेशन बेस्ड क्वेश्चन वेयर यू काउंट द पॉइंट्स एंड देन थिंक अबाउट कोलिनियर एंड नॉन कोलिनियर पॉइंट्स, बहुत ज्यादा लंबा चला जाएगा उससे, ठीक है। तो ये एक सिंपल सा क्वेश्चन था गाइस। जिस भी क्वेश्चन के मार्क्स पता है ना, एक बार अपडेट कर दो, व्हाट इज द मार्क्स ऑफ दैट क्वेश्चन? 1 मार्क है, चलो ठीक है। आई हैव क्वेश्चंस, आई हैव क्वेश्चंस, आई हैव 2 more क्वेश्चंस, ठीक है। सो दिस वाज 1 मार्क, आई हैव गॉट द अपडेट, ठीक है। वेक्टर वाला क्वेश्चन जो प्रीवियस था, किसी ने मार्क्स अपडेट नहीं किए, कोई बात नहीं, बाद में अपडेट कर लेंगे। ओके, नेक्स्ट क्वेश्चन की तरफ जाते हैं गाइस, कंट्रोल सिस्टम्स। ओके, नेक्स्ट क्वेश्चन की तरफ हम जाते हैं, दैट इज द कंट्रोल सिस्टम्स। ओके, देखो एक क्वेश्चन, तो पहले सिंपल वाले से स्टार्ट करते हैं। 2 क्वेश्चन कंट्रोल सिस्टम के आए हैं मेरे पास। ओके, द ट्रांसफर फंक्शन y by r, वेरी सिंपल, द ट्रांसफर फंक्शन y by r। ओके, मैं एक बार ब्लॉक डायग्राम आपके सामने बना देता हूं। चलिए, ऑप्शंस लिख दूंगा तो आप लोग भी थोड़ा सा रिकॉल करके मुझे बता पाएंगे कि क्या करेक्ट आंसर होना चाहिए। चलिए डन, और ऑप्शंस लिख दे यहां पे, एक बार ऑप्शंस को भी मैं लिख देता हूं आपके सामने। मार्क्स ऑफ द क्वेश्चन आप मुझे बताएंगे कितने मार्क्स का क्वेश्चन है। s+2 डिवाइडेड बाय द 3s+2। ऑप्शन नंबर बी ले लेंगे, दैट इज गिवन एज 3s+2 इज डिवाइडेड बाय द s+1, ठीक है। आई थिंक ये भी s+1 ही है। ऑप्शन नंबर सी अगर ले लेंगे तो दैट इज 3s+2 इज डिवाइडेड बाय द s-1, और ऑप्शन नंबर अगर डी लिया तो दैट इज द 2s+3 इज डिवाइडेड बाय द s+1। आपके पेपर में ऑप्शंस रीअरेंज हो सकते हैं, बट डजंट मैटर, ओके, डजंट मैटर। तो चलो क्रॉस चेक कर लेते हैं यहाँ पे। लेट अस क्रॉस चेक द आंसर, लेट अस क्रॉस चेक द आंसर्स। देखो गाइस, देखो गाइस, मैं आपको एक मेथड बताता हूं। मेथड नंबर 1, इस क्वेश्चन के लिए आप ग्राफ बना सकते हो, है कि नहीं, ग्राफ बना सकते हैं। बट गाइस, अगर आपने मेरी प्रीवियसली कुछ क्लासेस की हो, ठीक है, वेदर इन द विजन कोर्स जो हमारा रेगुलर पेड कोर्स है, या यूट्यूब पे भी, जब ब्लॉक डायग्राम छोटा सा सिंपल सा सुंदर सा ब्लॉक डायग्राम होना, व्हाट इज द मेथड आई टोल्ड यू, व्हेन इट्स अ शॉर्ट एंड स्वीट ब्लॉक डायग्राम, यू कैन डायरेक्टली गो बाय इक्वेशंस, 1 लाइन में यू विल गेट द आंसर। Okay, you can go for Mason's gain formula, you can go for signal flow graph, right? दूसरा alternative, if I take the second alternative, see how the answer is going to be simple. The answer is going to be something like that we know this is 2R and this is 3R, gains are given. Okay, so what is the output at this node? This is 2R, ये 1 का कोई मतलब नहीं, that is unit gain, तो 2R added with just y multiplied by 1 by s यहां पे करके। Okay, so what is the output y? One line equation, what is the output y? It is 1 coming from 3R, okay, और दूसरा आ गया 1 by s multiplied by the 2R plus y। इतना ही तो करना है, just one line solution it can have, just one line solution it can have। y के टर्म्स एक साथ अरेंज करेंगे तो bring 1 by s लेफ्ट साइड, 1 minus 1 by s is equal to r अरेंज किया यहां पे तो 3 plus 2 by s, राइट। सिंप्लीफाई करके y by r कितना आ जाएगा, दैट शुड बी द 3s+2 डियर, डिवाइडेड बाय यहां से जाएगा s-1, 3s+2 अपॉन s-1, आंसर इज द c, राइट। मिश्रा से आंसर इज c, बहुत बढ़िया, राइट। तो आंसर इज गोइंग टू बी ऑप्शन नंबर सी, आंसर इज गोइंग टू बी द ऑप्शन नंबर सी, ठीक है। तो ये रहा कंट्रोल सिस्टम का एक क्वेश्चन। इसी के साथ कंट्रोल सिस्टम के एक और क्वेश्चन की तरफ हम मूव करते हैं। ओके, एंड द क्वेश्चन इज स्टेट स्पेस एनालिसिस पे बेस्ड क्वेश्चन है। क्वेश्चन में यहां पे लिख देता हूं। ओके, सो यू आर गिवन अ सिस्टम, यू आर गिवन अ सिस्टम, स्टेट स्पेस मॉडल गिवन है आपको एक क्वेश्चन का। ब्रीफ में लिखते हैं क्वेश्चन, यू आर गिवन द स्टेट स्पेस मॉडल with the matrix A 0 1 -1 and -2, with the matrix B equal to the 0 1, with the matrix C is equal to 3 and -2, and with the matrix D equal to the 1, with the matrix D equal to the 1। okay, question क्या है, for the input sin omega t, for the input sin omega t where omega is positive, okay, what is the value of omega, what is the value of omega for which Okay, for which steady state output, what is the value of omega for which the steady state output, okay, will be 0 is, what is that frequency? बताइए, what is that frequency for which the steady state output will be 0? NAT type question है, NAT क्वेश्चन है. देखो इस क्वेश्चन को अगर फटाफट से सॉल्व करना है, आई गेस 2 मार्क्स का होगा, ठीक है, आई गेस 2 मार्क्स का होना चाहिए, तो यू कैन अपडेट मी. सो गाइस, ओनली थिंग दैट यू शुड अप्लाई की व्हाट इज द टाइप ऑफ द स्टेट स्पेस मॉडल गिवन, अगर टाइम सेव करके सॉल्व करना है. Okay, this represents a controllable canonical form. CCF model given है. Okay, and because it is the CCF model given to you, what is going to be my transfer function? What is going to be my transfer function y by u? That can be written as, देखो ये रहा b का वैल्यू, मैं मैपिंग कर देता हूं. This is the b, this is known as c0 c1. d यहां पे एक्स्ट्रा गिवन है तो +1 कर देंगे. And this is the constants of the characteristic equation. आपका होना चाहिए आंसर b into डायरेक्टली वैल्यू रखते ना. सो 1 इज मल्टीप्लाइड बाय c0 c1. c1 इज द कोएफिशिएंट ऑफ s, तो -2s plus 3 divided by s square. Now first we start with the constant of characteristic equation with the opposite sign. ठीक है, यहां पे है -2 तो यहां पे आ जाएगा +2s. लेकिन there is a d matrix which is not null here, तो +d करेंगे. This part represents what? This part represents the C5B plus D. CCF है, ठीक है, विजन कोर्स में भी और यूट्यूब पे भी लेक्चर्स अवेलेबल है, यू कैन रेक्टिफाई इट, आई हैव टॉट यू देयर. ओके, यही टाइम करने सेव करने की टेक्निक्स हैं. ओके, सो नाउ दिस इज इवेंचुअली इक्वल टू 3 minus 2s divided by s plus 1 का whole square plus 1, and let's say this is the transfer function ts. So what is the frequency domain, frequency response? That will become 3 minus 2j omega divided by 1 plus j omega का whole square added with the 1, and this is equal to the 3 minus 2j omega, right, plus यहाँ पे open करेंगे तो 1 plus j omega square, so j square minus 1, तो 1 minus omega square plus j2 omega whole divided by denominator को open करने का need नहीं पड़ेगा, 1 plus j omega whole square. So you are going to see minus 2j omega and plus j omega will get cancelled. So what is the frequency response of the system? That becomes 3 plus 1 and 4 and minus omega square divided by 1 plus j omega whole square. Now dear, आपका जो input given है, that is the sinusoidal input. Input ut is given to be sine omega t, sine omega t. So what should be the output dear? The output y of t should be equal to, इसका amplitude तो 1 है, तो 1 is multiplied by mod of tj omega into sine of omega t minus, sorry, plus phi j omega. Okay, प्लस 5j ओमेगा. तो देखो ये 0 कब हो जाएगा? आई टोल्ड आउटपुट इज 0, सो मैग्नीट्यूड, देखो पूरा मैग्नीट्यूड निकालने का जरूरत नहीं है. यू आर एबल टू अंडरस्टैंड कि 4 इक्वल टू ओमेगा स्क्वायर, द फ्रीक्वेंसी रिस्पॉन्स 0 एंड हेंस मैग्नीट्यूड विल बी 0. सो दिस इज इक्वल टू 0 at 4 minus omega square equal to 0. तो omega equal to 2 आ गया. omega positive, plus minus 2 नहीं लेना है, omega is given to be positive. So that is why dear, the answer to this numerical answer type question is 2. ठीक है. अब कुछ लोग कमेंट्स कर रहे थे पहले कि कंट्रोल सिस्टम डिफिकल्ट आया है. अभी तक तो 2 क्वेश्चन आया है, मैंने बोल रहा हूं ना पूरा देखने के बाद कमेंट करेंगे, बट एज पर दीज 2 क्वेश्चंस इजी है. फर्स्ट ट्रांसफर फंक्शन तो बहुत ही इजी. ओके, एंड दिस इज अगेन इजी इफ यू नो व्हाट इज द करेक्ट अप्रोच फॉर द स्टेट स्पेस क्वेश्चन. व्हाट इज द करेक्ट अप्रोच फॉर द स्टेट स्पेस क्वेश्चंस. तो बोलते जाइए कैसा गया आप लोग का. और भी कंट्रोल सिस्टम के क्वेश्चंस आते हैं तो डिस्कस करेंगे, बट व्हाट डू यू थिंक, हाउ इज द लेवल ऑफ ओवरऑल कंट्रोल सिस्टम? जो क्वेश्चंस आप लोग देख के आए हैं, जो लोग आप देख के आए हैं, और अगर कुछ और क्वेश्चंस हैं तो प्लीज आप मेरे टेलीग्राम में या बायजूस के टेलीग्राम में शेयर करते जाइए, बिकॉज वी कैन डिस्कस दोस सॉल्यूशंस. ओके, वी कैन डिस्कस दोस सॉल्यूशंस. यस गाइस, कम ऑन. Yes. What do we have? Weightage? Okay.
So electrical guys, how is going the analysis and how you find the paper this year? I am getting news from various students, and our faculties are also giving some tips that how difficult or how typical this year's question paper was. So we are coming up with the weightage analysis for different subjects.
So questions to discuss हो रहे हैं और होते रहेंगे अभी, but Ashutosh sir is ready and I am also there with sir. What is the weightage analysis for this year? देखो, इसको तो डिस्कस करने का नीड नहीं है, ये तो फिक्स रहता है. और मैथ्स, इज इट ट्रू? मैथ्स यहाँ पे 11 मार्क्स का आ रहा है, राइट? ओके, नो इश्यूज, इसको चेक करेंगे. आईआईटी ने एक बार सरप्राइज दे दिया कि आपको यहाँ पे. चलो, सो गाइस, आशुतोष सर, पावर सिस्टम एक्सपेक्टेड?
पावर सिस्टम का सर नॉर्मली 8 to 12 क्वेश्चंस रहते हैं. पिछली बार शायद 8 या 9 क्वेश्चंस आए थे और इस बार 7 क्वेश्चन आए हैं. बट अभी तक मैंने जो क्वेश्चंस देखे हैं, क्वेश्चन काफी कॉन्सेप्चुअल हैं सर, डायरेक्ट हैं. थोड़ा मेमोरी बेस्ड क्वेश्चंस मिले हैं तो कहीं कुछ डेटा मिसिंग है, तो वो अभी हमको क्रैक करना है. बट अदरवाइज आई वुड से द कोर क्वेश्चंस इन टर्म्स ऑफ पावर सिस्टम एंड मशीन्स, machine is little easier side. Machine is on the easier side.
Okay.
Power system is little typical in terms of theory.
मशीन कहाँ गया? मशीन भी 11 का है, पावर सिस्टम भी 11 का है, बट पावर सिस्टम मोर कॉन्सेप्चुअल, मशीन रिलेटिवली इजी. ऐसे कोई ना कोई एक कोर को पकड़ के ज्यादा उसके डेप्थ में चले जाते हैं. पावर इलेक्ट्रॉनिक सरप्राइज लग रहा है सर मेरे को. आप कमेंट करेंगे ओनली 6 मार्क्स ऑफ पावर इलेक्ट्रॉनिक्स इज लाइक अ सरप्राइज. आई थिंक
4 questions only.
Right.
These are surprise because if you see 3 subjects like machine, power system and power electronics, these are the 3 main core subjects for electrical engineering, and this is the first time I think we are getting only 4 questions for power electronics.
Yes. So कंट्रोल सिस्टम एक्सपेक्टेड है 8 to 10 मार्क्स के रेंज में आता ही है. सो एक्सपेक्टेड है. 2 क्वेश्चन अभी कराए, वो दोनों तो इजी लगे मेरे को. बाकी और क्वेश्चन देख के आएंगे. टोटल 6 क्वेश्चन है. नेटवर्क थोड़ा सा इलेक्ट्रिकल में 9-10 मार्क्स तक आता है, बट इस बार 8 है, बट दैट इज ओके सर.
As usual.
डिजिटल इलेक्ट्रॉनिक्स यूजुअली 2-3 मार्क्स का आ रहा था, इस बार 4 है, बट ओके, आता है इतना. सो देयर इज नॉट अगेन अ बिग डेट. एनालॉग इलेक्ट्रॉनिक्स 6 मार्क्स. तो देखो, एक्चुअली तो इलेक्ट्रिकल के लिए सर ये एक सब्जेक्ट है, एनालॉग एंड डिजिटल, एज पर द सिलेबस. अपने आप में 2 सब्जेक्ट है, बट इलेक्ट्रिकल के जो लोग हैं उसको 1 मानते हैं. तो लेकिन टोटल 10 मार्क्स हो गया यहाँ पे, राइट? सिग्नल एंड सिस्टम सर, ये एक थोड़ा हायर.
सिग्नल को सर अच्छा वेटेज मिला, और मैंने ऐसा सुना है, आप बताइएगा कि क्वेश्चंस की क्वालिटी भी अच्छी है.
ना, सिग्नल्स का अभी तक मैं ऑनेस्टली देख नहीं पाया. मैंने कंट्रोल सिस्टम और मैथ्स एप्टीट्यूड के क्वेश्चन करे हैं, लेकिन अब मुझे लगता है कि तुरंत मुझे जाके सिग्नल्स के क्वेश्चन देखने पड़ेंगे, राइट? और जो कि 12 मार्क्स का आया है. तो गाइस, नेक्स्ट आई थिंक बहुत जल्दी हम लोग सिग्नल्स डिस्कस करेंगे यहाँ पे. सर मेजरमेंट का सर मुझे ऐसा लग रहा है कि नेक्स्ट ईयर या नेक्स्ट टू नेक्स्ट ईयर बच्चों को सरप्राइज मिलेगा, क्योंकि मेजरमेंट के साथ ज्यादती हो रही है. पिछले 2-3 सालों से सर 2-3 क्वेश्चन पूछे जाते हैं और बच्चों को लगता है सर पढ़ना बहुत होता है. तो सिर्फ एक क्वेश्चन है और
सर बच्चों को पढ़ना बहुत.
हाँ, जहां तक मैं, आई एम नॉट फ्रॉम इलेक्ट्रिकल, बट आई नो कि पढ़ना तो मेहनत तो उतनी करनी पड़ती है.
आई थिंक सर दिस इज वन ऑफ द मोस्ट लेंथी सब्जेक्ट वी कैन से, बिकॉज इन टर्म्स ऑफ सर इतने इंस्ट्रूमेंट्स हैं, इतनी सारी चीजें, बट उसके बाद एक क्वेश्चन आता है. सो इट इज लिटिल डिस्करेजिंग, बिकॉज आप किसी, और सर इंस्ट्रूमेंटेशन एक ऐसा सब्जेक्ट है, मेजरमेंट, जो आई थिंक इसके बिना सर कोई सिस्टम, कोई डिवाइस काम ही नहीं कर सकता.
करेक्ट है. इलेक्ट्रोमैग्नेटिक फील्ड, मैंने आपको बोला ही था, पिछले 3-4 साल से आप देखोगे तो इलेक्ट्रिकल में 5-6 मार्क्स टच कर रहा है, और इस बार भी 5 मार्क्स के लिए पूछ लिया गया. तो बाकी सब तो रेगुलर है यहाँ पे गाइस. तो अभी भी आप कमेंट करते जाइए, बताते जाइए हाउ इज द लेवल, और क्या आप लोग कितना यहाँ पे एग्जाम में मचा के आए हैं. और मुझे लगता है सिग्नल सिस्टम के वेटेज को देखते हुए बड़ी लालच सी आ रही है कि क्वेश्चन जाके देख लिए जाए सिग्नल सिस्टम के. तो कंट्रोल और सिग्नल्स के और क्वेश्चन, मैथ्स एंड एप्टीट्यूड के और क्वेश्चन लाते रहेंगे. डिजिटल भी देखना है, डिजिटल भी 4 मार्क्स का है सर.
हाँ, डिजिटल आई थिंक डिजिटल तो सर हमेशा ही ऐसे ही आता है, बट आपने जैसा बोला अगर कंबाइन करके देखें तो अच्छा खासा वेट, एक इलेक्ट्रिकल इंजीनियर बच्चे के लिए अच्छा खासा ठीक ठाक वेटेज है, क्योंकि आप इसको कंपैरिजन करेंगे मशीन और पावर सिस्टम से. अगर आप देखें, इसमें 3 क्वेश्चन पूछे गए, इसमें 3 क्वेश्चन 6 क्वेश्चन, तो आप देखिए पावर सिस्टम और मशीन दोनों में 7 क्वेश्चन. तो कोर को और नॉन कोर को इक्वल वेटेज दिया, इस तरीके से देख सकते हैं. बट जैसा हम लोग स्टार्टिंग में बोल रहे थे सर, मैंने हल्का सा गेस लगाया था कि आईआईटी कानपुर करा रहा है, तो मैथमेटिकल जो सब्जेक्ट्स हैं वो थोड़ा सा डिफिकल्ट साइड पर होंगे. और ऐसा सुनने में सर, कंट्रोल सिस्टम कैसा था
सर? अभी तक 2 क्वेश्चन आए, बट वो दोनों तो इजी है. मतलब 1 क्वेश्चन इज ब्लॉक डायग्राम, वो तो बहुत इजी है. दूसरा कंट्रोल सिस्टम का है सर, अगर बच्चों को टेक्निक्स पता है सॉल्व करने की तो इजी है, अदरवाइज उनके लिए लेंदी होगा. स्टेट स्पेस मॉडल से एक क्वेश्चन है, ठीक है. अगर आपको टेक्निक्स नहीं पता है कि कंट्रोलेबल कैनोनिकल फॉर्म क्या होता है, तो आपके लिए लेंदी क्वेश्चन हो गया, डिफिकल्ट नहीं बोलूंगा. और अगर आपको पता है तो वो क्वेश्चन आपके लिए बहुत ही ईजी होगा. तो इट्स ऑल अबाउट कि आपने कितने डेप्थ में पढ़ा है. हाँ, मैंने बच्चों को फिर भी बोला दैट अनलेस एंड अंटिल वी गेट ऑल द क्वेश्चंस वी विल नॉट कमेंट ऑन द एग्जैक्ट level, because control system has 6 questions. I have discussed 2. Without the rest 4, we can't say what exactly is the
तो दोस्तों
syllabuses.
आप सभी सेशन में बने रहिए, क्योंकि अभी हम बहुत सारे क्वेश्चंस डिस्कस करने वाले हैं। अभी आशु सर अपने क्वेश्चंस लेके आ रहे हैं, और भी सारे फैकल्टीज अपने अपने क्वेश्चंस लेकर आएंगे दोस्तों। और
तो
इसके
ये तो
साथ ही साथ
ये तो वही डिस्ट्रीब्यूशन जो
Yeah.
हमने अभी डिस्कस किया, जस्ट इन द फॉर्म ऑफ पाई चार्ट है। हाँ, तो सर ये एक बार पिछले 2-3 साल का कंपैरिजन जो हम बात कर रहे थे, वो बच्चों के लिए अगर देख लिया जाए तो पावर सिस्टम्स तो ऑन एन एवरेज 10, 12, 11 आता है, वही ट्रेंड रहा।
सर आप पावर सिस्टम मशीन में देखेंगे और पावर इलेक्ट्रॉनिक्स में ज्यादा आपको डिफरेंस नहीं मिलेगा। आई थिंक इस साल थोड़ा सा पावर इलेक्ट्रॉनिक्स में कुछ चेंजेस आए हैं। अगर आप देखें 2022 में सर 11 क्वेश्चन थे, बहुत अच्छा खासा वेटेज था,
करेक्ट
9, 7। तो आई थिंक 2-3 साल के बाद सर थोड़ा सा एक एब्रप्ट चेंज देखने को मिलता है,
देखने को सब्जेक्ट वाइज मिलता ही है। ओके, मैथमेटिक्स स्टूडेंट्स एक बार मैं चेक करता हूं, हो सकता है एक आध क्वेश्चन यहाँ शफल हो, बिकॉज मुझे ये डाइजेस्ट करना इजी नहीं हो रहा है, क्योंकि मैथमेटिक्स आईआईटी ने अनाउंस किया है कि 13 मार्क्स का होगा, राइट? सो इफ दे गिव 11, सो दे हैव बिट्रेड यू, बट ऐसा होना नहीं चाहिए। आई विल चेक इट फ्रॉम माय साइड गाइस।
सर एक्चुअली क्या होता है सर, मेमोरी बेस्ड भी होता है।
एग्जैक्टली, मेमोरी बेस्ड होता है ना, मेमोरी बेस्ड होता है, ठीक है। और कभी कभी सर क्या है ना, मैथ्स और सिग्नल्स के कुछ क्वेश्चंस भी रिलेटेड होते हैं, जैसे ट्रांसफॉर्म थ्योरी से रिलेटेड है,
बिल्कुल सर,
या कुछ इंटीग्रल के ऐसे क्वेश्चन है जो ट्रांसफॉर्म से सॉल्व होते हैं, लव को लगता है मैथमेटिकल। सो इट्स ऑल अबाउट थिंग। ओके, तो देखिए मेजरमेंट सर आप बोल ही रहे थे, 2020 में एक सरप्राइज था
सर।
हो सकता है ऐसा 3 साल खत्म होने के बाद 2024 में, तो देखो ऐसा नहीं कि आप मेजरमेंट्स को लाइटली लो। इट्स अनफॉर्चुनेट दैट द सब्जेक्ट इज गेटिंग 2 मार्क्स, बट यू नेवर नो, अगर नेक्स्ट ईयर 5, 6, 7 मार्क्स का आ गया तो फिर
सर ये गेट में ही नहीं, किसी भी कॉम्पिटेटिव एग्जाम में होता है कि आपको सरप्राइजेस मिलते हैं, बट आपको तो पूरा सब्जेक्ट पढ़ना है, पूरा सिलेबस पढ़ना है, तो वो उसमें आपको बिल्कुल भी कमी नहीं रखनी है दोस्तों। सर अगर हम सिग्नल सिस्टम को देखें तो आई थिंक सिग्नल सिस्टम इज स्लोली गेटिंग द,
हाँ, ये एक सब्सटेंशियल जंप आया
एक
है।
कंसंट्रेशन आ रहा है सिग्नल सिस्टम की तरफ। आप देखो 9, 8, 8 एंड 12 एकदम से जंप हुआ। इसके अलावा सर अगर हम इलेक्ट्रोमैग्नेटिक फील्ड थ्योरी को देखें,
हाँ, तो ये पिछले सालों से 5, 6, 7, 8
एक एवरेज बना हुआ है, कुछ खास
बना हुआ है,
नहीं है।
और मुझे ऐसा लगता है इलेक्ट्रोमैग्नेटिक्स का जो सिलेबस है इलेक्ट्रिकल के लिए वो बहुत ही कंसाइज भी है।
बहुत concise है।
इलेक्ट्रॉनिक्स के लिए काफी सारे टॉपिक्स है, बट यहाँ पे आपको केवल इलेक्ट्रिसिटी एंड मैग्नेटिक्स पे अफेक्ट।
सर मुझे ऐसा लगता है कि इलेक्ट्रिकल वाले जहां खत्म करते हैं वहां से इलेक्ट्रॉनिक्स वाले शुरू करते हैं।
तो बहुत ही सिंपल सा स्कोरिंग सा। अभी मैं ईएमटी के क्वेश्चन देखता हूं, बट सपोज कर रहा हूं इजी रहे होंगे, बट आई विल जस्ट चेक एंड लेट यू नो। ओके,
सो गाइज एक बार जल्दी से कमेंट सेक्शन में बताइए कि आप सबका एक्सपीरियंस कैसा रहा, हाउ यू फेल्ट अबाउट द एग्जामिनेशन।
अच्छा गाइज, आप लोग के लिए एक बहुत ही इंपॉर्टेंट न्यूज वापस से। आप लोग को पता है 15th February नाउ द गेट एग्जामिनेशन फॉर डबल इज ओवर। इलेक्ट्रॉनिक स्टूडेंट्स वुड बी स्टार्टिंग नेक्स्ट वीकेंड। वी हैव द सिविल एंड इंस्ट्रूमेंटेशन पेपर, बट ऑन द 15th of February the response key by IIT Kanpur will be uploaded on their portal, and as soon as the response keys are available, for the very first time BYJU'S Exam Prep is coming up and they have lived the rank predictor. Yes guys, so if you want to get the link of this, ये भी link है, but for you it can be easy. You can just go and description में जाएंगे, the link is available in the description. Just open the link, press notify me, okay, so that ओके देखिए ये मैंने लिंक को क्लिक किया, तो गाइस मैंने भी लिंक को क्लिक किया। सो व्हाट इज दैट, देयर विल बी अ विंडो कमिंग अप एंड यू जस्ट हैव टू डू वन थिंग, प्रेस नोटिफाई मी, सो दैट व्हेनेवर द रिस्पांस की आर आउट एंड व्हेनेवर द रैंक प्रेडिक्टर इज लाइव, okay, you will get an update and you can enter your marks. You don't have to enter your marks actually, you just have to enter your response key. The portal will tell you how much marks you have scored. चलो वो तो आप खुद भी कैलकुलेट कर लोगे, but more than that the portal will tell you कि what is your expected rank. Okay, and because thousands of students are going to enter the data, तो I think काफी अच्छा बच्चों को एक रैंक मिलने वाला है। So result before gate result टाइप का सिचुएशन बन जाएगा।
सर इसकी एक और इंपॉर्टेंट बात है कि ये सिर्फ आपको आपकी एक एक्सपेक्टेड रैंक ही नहीं बताएगा, आपको एक सही डिसीजन लेने में बहुत मदद करेगा। कि बहुत सारे बच्चे कंफ्यूज होते हैं कि सर मुझे एमटेक करना है, कि मुझे पीएसयू में अप्लाई करना है, मुझे किस तरफ जाना है।
Exactly.
वो क्लैरिटी आपको यहाँ से काफी हद तक
Exactly, that is otherwise you have to wait till mid-March to get the exact
Yes,
rank and
sir.
then you take your next decision. Okay, so better guys, you can just check your results and rank right now, so that you know you will come to know कि whether you are going to get some IIT and PSU and you can prepare accordingly. Sir, interview preparation भी एक बहुत important phase होता है, and somewhere I know
ओके ओके
ओके चलिए सो पूरी टीम ने एक वेटेज एनालिसिस भी यहाँ पे बना लिया है. वेटेज एनालिसिस हमने डिस्कस कर ही लिया, बट दिस इज द हाइलाइट्स ऑफ द पेपर. सो आशुतोष सर.
सर जैसा कि हम लोग सुबह भी बात कर रहे थे, कल रात में भी लेट नाइट डिस्कशन कर रहे थे कि इलेक्ट्रिकल वालों को सरप्राइज मिलेगा, और एक बच्चा है, आई थिंक उसका नाम है मिसारा. मिसारा इज सेइंग दैट थोड़ा डिसअपॉइंटमेंट है. तो दोस्तों थोड़ा सा इस बार इलेक्ट्रिकल में बच्चे सरप्राइज हुए होंगे. कुछ क्वेश्चंस काफी डायरेक्ट हैं, जैसे मशीन्स में कुछ क्वेश्चंस आए हैं बिल्कुल डायरेक्ट क्वेश्चंस हैं, आसान क्वेश्चंस हैं, कन्वेंशनल क्वेश्चंस हैं. क्वेश्चंस आर क्वाइट स्ट्रेट फॉरवर्ड, बट स्टिल देयर आर सम एरियाज. फॉर एग्जांपल अभी पावर सिस्टम मैंने देखा नहीं है, मैंने 2 क्वेश्चंस देखे हैं, तो कन्वेंशनल अप्रोच पे हैं, इजी क्वेश्चंस है, बाकी क्वेश्चंस मैं देखूंगा अभी. बट इसके अलावा जो मैथमेटिकल सब्जेक्ट्स हैं उनमें कुछ डिफिकल्ट क्वेश्चंस देखने को मिले. जैसे कुछ बच्चों ने बोला कंट्रोल के, सर ने बोला अभी कंट्रोल के शायद कुछ क्वेश्चन सर देखेंगे तो बताएंगे, और सिग्नल का भी सुनने में आ रहा है कि अच्छा है. तो हम कह सकते हैं कि अगर हम सर स्टूडेंट पॉइंट ऑफ व्यू से बोलें तो मॉडरेट टू टफ ही माना जाएगा इस पेपर को, और आई डोंट थिंक सर बहुत हाई स्कोरिंग इसको हम कह सकते हैं.
करेक्ट है.
Second, sir, difficult paper as compared to last year. I think not last year, sir. Couple of last year, you can say for past 2 years, we have seen that electronics is getting good quality questions.
Yes.
In comparison to electrical.
Last couple or last 3 years, in fact, right? Electrical का जो toppers mark है, जो cutoff भी है, that is going to a higher range, and electronics
Yes.
people will getting a difficult. So now looking into this, I am getting a doubt. Maybe electronics का शायद इस बार easy ना आ जाए, but rest we don't know. Let's wait till evening. Right? Let's wait till evening.
Yes, first
Great.
student.
Okay, great. Thank you, Gate.
So MSQ questions are 8 in numbers, and that is a big surprise. वो शायद सर पहले 6 थे, उसको correct कर लिया गया.
Because
8 हो
it
गया
is all memory based. So
Memory
we are
based.
getting more and more questions. So we have come to the accurate data now. Guys, one more thing. Difficulty level moderate to tough. If it is moderate to tough, so don't worry. I'll tell you one simple thing. If you have really prepared hard, we have been always telling you, then the tough papers will be more beneficial for the students who have prepared hard, right? And yesterday also we told that electrical this time definitely chances of getting the MSQs, and yes, here the MSQs are there क्योंकि खाता नहीं खुला था, और इस बार electrical का खाता खुल चुका है in terms of MSQs, right?
सर इसके अलावा अगर हम कुछ सब्जेक्ट्स को कैटेगराइज करें, अभी तक जो क्वेश्चंस हम देख पाए और जो फैकल्टीज से हमने रिव्यू लिया है, द फीडबैक वी हैव गॉट फ्रॉम द फैकल्टीज अक्रॉस द बोर्ड दैट सम सब्जेक्ट्स लाइक क्वेश्चंस फ्रॉम मशीन, मैथमेटिक्स एंड पावर सिस्टम्स, दे आर इजी टू मॉडरेट लेवल, एंड द न्यूमेरिकल टाइप क्वेश्चंस हैव इंक्रीज्ड in numbers. You can see it is 26. It is a very good number. It is a very good number because NAT questions you don't have a reference, so you don't have this idea in your mind whether you are in the right direction or not. Whatever you get, that has to be your answer.
Right.
Yeah, we'll be coming up with power system also. 2 questions I have solved, so I will be coming after some time.
Right now,
Yeah.
Naveen sir is ready
Naveen
with
sir, your
measurement.
favorite.
Correct.
Naveen sir is coming up with some questions, sir.
Yes. Not this one, no?
16 next.
Achha, this one only, na? Sure.
Right.
Sir, the stage is all yours.
Thank you, sir. Hi, guys. How was the exam? Went well? Is it good? Respond, guys. I think same as every year, measurement has little weightage, to say exactly less weightage. I think every year we will be getting around one question or 2 questions. It seems this year also only 1 question, and that too about the question is from measurement of power. Thank God, at least this time they have given the question from measurement of power. Since so many years I used to say each and every year, every time we'll be getting question from measurement of power, but this time luckily we got. I think it is 1 mark question or 2 mark question. Hi Bhargav, how are you? How are you, my dear? Is it 1 mark question or 2 mark question? I don't know the marks, but this is the question. He has given a question on 3-phase star connected load. He has given balanced load, and he has given it's like the current coil is in R phase, and the pressure coil is in between Y phase and B phase, na? So it will be, the wattmeter reading will be, you will get, how do you get wattmeter reading? Just a minute, my mic is not setting. ठीक है, if it is 1 mark, then okay, fine. So we got a question like this. The current through R phase is around 2 amperes. And he has given 400 volt supply. He has given that the wattmeter reading also he has given. The wattmeter reading is minus 400 volts, it seems. All right. So if the question is given like this, and the pressure coil, if it is connected like this, so you can say the wattmeter reading is going to be VL, IL, sin phi. If you draw the phasor diagram, so this is the formula you are going to get. If you want me to draw the phasor diagram, I'll show you that also. VR phase, as it is a star connected system, you can say, you can take up like this, VR, VY, VB. Okay. So the pressure coil is connected between Y phase and B phase. So you can take the subtraction, or you can take the subtraction of this Y phase and B phase, and you will get the V by B will be, resultant will be here, V by B. And if it is IR, leading load or lagging load, if it is leading load, it will be 90 plus phi. If it is lagging load, it will be 90 minus phi. So from here, the angle between VYB and IR, it will be 90 plus phi for leading load, 90 minus phi for lagging load. So if you solve that one, so this could be like, what could be the general wattmeter reading? The wattmeter reading will be VPC, ICC, and the angle between, cos of angle between VPC and ICC. All right. So if you solve this one, you will get this formula you will get. So please substitute the values of line voltage, line current, and the wattmeter reading. So if you substitute the wattmeter reading, he has given it as 400. Line voltage also he has given it as 400, and the current, current flowing with through the current coil is given it as 2 amperes. So if you solve this one, you will get the sin phi value. Sin phi value will be around 0.5. Of course, 400 can be cancel कर सकते हो आप, तो आपको मिलेगा 0.5. Sin inverse of 0.5 will be 5 मिलेगा आपको 30 डिग्रीज. तो उन्हें पूछ रहे क्या पूछ रहे, पावर फैक्टर पूछ रहे हैं. तो पावर फैक्टर कितना हो जाएगा, cos 30 सब्स्टिट्यूट कर लो तो आपको मिलेगा cos 30 0.866. So that could be the probable answer. All right, so this is the question which he has given in measurement. Very simple question, directly from formula only. Each and every year I used to say this, especially on measurement of power. Okay, so is that clear for everyone? Surendra sir, fire. Okay, fine. All right, Bhargav, is that okay? Bhargav, everybody, anybody did this question? Fine. All right. Chalo, next, कौन सा subject sir?
Power electronics.
Power electronics. Ashu sir is going to take up power electronics. Chalo.
So hello guys, I hope you are enjoying. Okay, so let's come to the next question, and the next question is from power electronics. Okay, and yeah, let's set the question. Actually there were 3 questions from power electronics, so I have solved 2 questions already. So now I'm going to solve this question. So let's look at this question, and this is again a classroom question. Okay, even I have designed so many MSQ on this topic, and if you have followed my lectures, and if you have followed my MSQ series of power electronics, I mean this question is, I don't know how many times I have covered it even in the classroom, in the paid course, in the open platform. Okay, so let's look at this question. The semiconductor switch need to block the voltage of only one polarity. This polarity it should block, and it is during the off state. Obviously the blocking voltage should be under the off state. Okay, and the carry current in both the directions. Okay, it should carry the current in both the directions when it is closed. Okay, just give me 1 minute so that I can yes. Okay, so when it is closed, the current can flow in both the directions. Okay, current can flow in both the directions, and when it is open, this should be the blocking voltage. This is the blocking voltage. This is the blocking voltage. Now we need to check which option is correct for this, which configuration is correct for this switch. I mean, which switch we can use here. Now it is an MSQ question. Okay, now in this question you can see that, look at the first option. This is MSQ question. This is multiple select question. Okay. In this question, you can see that the current can flow in this direction via this diode and via this transistor in this direction. So both the direction current can flow. Okay. In both the directions current can flow. But the blocking voltage, it cannot block this polarity. It cannot block this polarity because diode will not be able to block this. So the blocking voltage has to be of this polarity. Is it clear, guys? This should be the blocking voltage. It means A is correct. Okay, because the blocking voltage is this polarity and the conduction current is in both the directions. Now come to this. In this case, you can see that current cannot flow in both the directions. Okay, because of this diode, current cannot flow in both the directions. So B is wrong. Now let's come to this. Again, current cannot flow in both the directions, so it has to be wrong. Now in this question, you can see that the current can flow in this direction as well as in this direction. You can see that if current is flowing from P to Q, then it will flow like this path, and while from Q to P, it will flow via this diode. So current can flow in both the directions, but it cannot block this polarity. If this point is higher and this point is higher, so the diode will start conducting. It will not be able to block this polarity. So the blocking voltage should be of this polarity. This polarity can be blocked because this switch will block. This diode will not be able to block, but this switch will be able to block it. So you can see that now the blocking voltage has to be this polarity. So answer is Delhi also. So answer is Agra and Delhi. A and D both are correct. Okay, so let's come to the next question, guys, and the next question start from the machines. Okay, electrical machines. Now let's come to the next question. So wait a minute, let me check. Okay, okay, so let's come to the next question. Just give me 1 minute, guys, and let's move to the next question. Wait a minute. No. Okay, let me change the slide. Yes, now it's fine. Yes. Okay, so look at this question, guys. This is from electrical machines. An electrical machine, you can see that a 10 pole 50 hertz 240 volt single phase induction motor runs at 540 rpm. Now can you tell me the synchronous speed of the motor? Synchronous speed is 120 f by p, and f is 50 and p number of pole 10. Okay, so it is 600 rpm. So the synchronous speed is 600 rpm, and actually it is running at 540. So now we can calculate the slip. So slip will be equal to ns minus nr divided by ns. Okay, divided by 600. So it came out to be 60 upon 600, that is equal to 0.1. Okay, so the slip came out to be 0.1. It is driving a rated load. The frequency of the induced rotor current due to backward field, if you remember, the frequency due to backward field is 2 minus s into f. Okay, this is the frequency due to the backward field. So now you can just put the value of s and you can calculate the frequency due to the backward field. Okay, so the backward field frequency will be 2 minus 0.1, that is 1.9 into 50. Okay, so 19 into 5. Is it clear, guys? Now you can calculate 2 minus 0.1 is 1.9 into f. F is 50. Okay, so 19 into 5. Now can you tell me which option is correct? So it will be 95. Okay, so the answer is Agra. Tell me, guys, is it clear? Is it clear? So the question was simple. Let's come to the next slide. Let's come to the next question. How many of you have corrected it? Tell me, guys. This was again very simple question. This was again very simple question. Tell me how many of you have corrected this question. Tell me, everyone. Tell me. Tell me. How many of you have corrected this previous question, the slip question? Wait a minute. Let me check. Okay. So let's come to the previous slide. Yes. How many of you have corrected this this question? Tell me, everyone. So the answer is for this question. Let me start from the beginning. So this question. Tell me. Answer was Agra and Delhi. A and D. Answer was A and D. Okay. Agra and Delhi. How many of you have corrected this? Tell me. Okay. And the next question. Let's come to the next question, guys. The next question is. Wait a minute. Yes, next question is this. Answer is Agra. Let's come to the next question. Let's move to the next question. I hope it is clear. Let's come to the next question, and the next question is on your screen. Wait a minute. Okay, this is the question, guys. Now let's try to solve this question. This question came from a DC motor. Now a separately excited DC motor. So first, since the DC motor is given to you, so what we are going to do, we are drawing the diagram. So this is the diagram of DC motor, separately excited, and these are the field supply. Okay, so we have a separately excited DC motor rated at 400 volt. Okay, so the rating of the DC motor is 400 volt, 15 ampere, and 1500 rpm. Okay, this is the rating. Okay, this is the rating of the machine, and it drives a constant torque load, and the torque can be defined as Ke phi Ia. So this is constant, this is given as constant. Okay, so the torque is given as constant, Ke phi Ia is given as constant. Now he's saying that it's operating from 400 DC supply, drawing a rated current. So it is drawing rated current and operating at rated supply. So obviously the back EMF will be, we can calculate the back EMF. RA is already provided to you. RA came out to be 1.2. RA is given to be 1.2 ohm. Now, if the supply voltage is dropped by 10%, it means he is decreasing the supply voltage. So the 10% of this is, tell me what is the 10% of this is 40 volt. Okay. Now it is decreasing by 10%. So the voltage will become 360. Now the voltage will become 360. He is saying if the supply voltage drops 10%, with the field current unaltered, it means Ke phi remains constant. If the torque also remain constant and Ke phi remain constant, then the current will also remain constant. Okay, current will remain constant. If you are dropping the supply voltage, then also the current will remain constant. Why it will remain constant? Tell me, guys. Because torque is constant, Ke phi is constant. That's why the current will remain constant. Okay. It means the current will keep flowing 15 ampere. Now in the first case, the voltage was 400 volt and the current was 15 ampere. So now you can calculate the back EMF. So the back EMF in the first case was EA is equal to, tell me what is EA? EA is 400 minus 15 into 1.2. Okay. 15 into 1.2. Now you can calculate this value. This is back EMF this is my back EMF, and it came out to be Ke phi omega m. Omega m I can write in RPM, n into 2 pi by 60. Okay, and this RPM is already given to you. In the first case, the RPM was 1500. Okay, so now what we can do is we can replace this n1 as 1500. Now in the second case, the voltage is 360. So voltage is 360. And the current remain as 15, into 1.2 is equal to Ke phi into N2 into 2 pi by 60. Okay, and we need to calculate this N2. Okay, we need to calculate speed in the second case. Okay, so if I take the ratio, then this will cancel, 2 pi by 60 will cancel, N1 is 1500, and this value you can calculate. So this difference, please tell me what is this difference? Tell me, guys, what is this difference? Everyone tell me. So 400 minus 15 into 1.2, what is this value? Tell me. Let me calculate on the calculator. So 400 minus 15 into 1.2. So this value came out to be 382. Okay, so this is 382 divide by, tell me this value, 360 minus 342. Okay, this came out to be 342 is equal to 1500 upon N2. Now you can calculate the value of N2. So tell me the value of N2. N2 will be equal to, tell me, guys, 342 into 1500 divided by 382. Now you can calculate this value. So this value came out to be 1351.35. 1351.35. Please check this. Please check the calculation. So I think this is correct. How many of you have corrected this question? Tell me, guys. This question was I think 2-mark question was there. Okay, so this was 2-mark question, I suppose. So tell me, everyone, how many of you have corrected this question? Tell me, guys. Okay, let's move to the next. Till then, we can solve the other question. And okay, let's move to the next question, guys. Let's move to the next. And the next question is again from electrical machines. Yes. Let's move to the next question. Yes, this is the next question. Again, I think it's a 1-mark question. Okay, it's a 1-mark question. So in this question, the following column represent the various mode of the induction machine operating and the range of slip. Okay, so the range of slip is given to you, and the modes are already provided to you for induction machine. Now we need to match the column, which option is correct. Okay, so tell me guys, we know that the characteristics of induction machine is like this. If you remember, this is the characteristics of induction machine. Now we know that at this point S is 0. This is motoring mode, this is generating mode, and this is braking mode. Okay, if you know this, then you can easily solve it. Now tell me, running in generator mode. If the machine is running in generator mode, what does it what does it represent? If the machine is running in generating mode, it means the slip has to be negative. Okay, so slip varies from -1 to 0. You can say that. So it means A, for A, R is correct. And now in motoring mode, we know that slip varies from 0 to 1. Slip varies from 0 to 1. At this point, slip is 1, na? Okay, so you can say that in motoring mode, and now in plugging or braking, because plugging is the type of braking, na? So you can say in plugging the slip has to be from 1 to 2. Okay, so the answer is for A it is R, for B it is P, and for C it is Q. Okay, so answer is Delhi. Answer is Delhi. Okay, I hope everyone has done it correctly. Sir, 1342.5 tha. Okay, let's see the last question. Wait a minute guys, let me see the last question. Yes, for this question, tell me what was the answer? 1342, and what I have calculated, 1350 I think, 1351 I suppose we have calculated. Yes, so please check my calculation. I think I have done it correctly. Only thing is you have to check the calculation. Okay, let's come to the next question guys. Let's come to, so for this question answer is Delhi. Let's come to the next question. Yes, this is the next question for again it's a 3-phase circuit, and let me solve this question. We have a balanced delta connected load consisting of series connection of R and C. So this is my R, this is C. R is given as 15 ohm, this is 15 ohm, and C is given as 212.21 microfarad. Okay, so let me erase this. Yes. So now you can see that 212 point, wait a minute. Yes, 212.21. This is my capacitance value, 212.21 microfarad. Now the load is connected in delta, and it is given that the load is balanced. Now look at this L. What is the value of L? L is 31.83 millihenry. This is 31.83 millihenry. Okay. Now what I need to do is consider the charge in the supply terminal voltage with consider no charge. I think consider no charge. Consider no charge in the supply terminal voltage with loading to be negligible. I think there is a mistake in the typing. Okay, I think there will be. Okay, considering no change in the supply terminal. Okay, this is the question. The magnitude of the voltage across the terminal AB. This point is A, this point is B. We need to calculate the voltage across the terminal AB. So it's a simple question, guys. Now what we can do is first let's connect this load in delta. Okay, let's connect this load in delta. Let me simplify this and let me connect this load in delta form. Now can you tell me what is the value of R and what is the value of C? R is 15, and if you calculate this value, it will be 1 by j omega C, and omega is given as 100 pi. Okay, omega is given as 100 pi, so it will be 1 by j 100 pi into 212.21, and this is microfarad, so 10 to the power 6 will be in the numerator. So it came out to be minus j15, I suppose. Okay, this is 15, this is minus j15. I think this is correct. Okay, and the load is balanced. 15 minus j15. Okay, 15 minus j15. Now what I did is I connected an inductor here. Okay, and the inductor value, please calculate the inductor value also. J omega L you can write, na? J omega L. J omega. Omega is 100 pi. What is the value of L? L is L. What is the value of L? L is 31.83 millihenry. Okay, so now if you calculate this, I think this came out to be J10. Please check this. Okay, so this value is J10. Now what we can do is we need to calculate this voltage, A point and the B point. We need to calculate the voltage difference between A and B. So it's a simple question. First you convert this delta into star. Okay, if you convert this delta into star, then the circuit will look like this. And can you tell me the value of the star connected load? The value of the star connected load is 5 minus J5. Okay, so it will be 5 minus J5. Okay, and on every phase it is 5 minus J5, and then I connected J10. I connected J10 here. I hope it is clear. So this is J10, and here also we have J10. I hope it is clear. Now, you know that on this phase, if I combine this, it will become 5 plus J5 on this phase also, 5 plus J5 on this phase also, 5 plus J5. It means including this inductor, again it's a balanced load. Now if it is a balanced load, then what we can do is, we know that the line voltage on the supply side, the line voltage is 415 RMS value. Okay, so the phase voltage will be 415 by root 3. This is the phase voltage. Let's take it angle 0. Now what we can do is, we have to calculate this voltage. This point is A and this point is B. You remember in delta connection, I have 2 points, A and B. So this point is A, this point is B. I need to calculate this voltage difference. So what I need to do, if I calculate this phase voltage now, multiply by root 3, I'll get this line voltage. It's simple. And how to calculate this phase voltage? We know the supply voltage. Supply voltage is 415 RMS value, line voltage. So what I did is, I divided with root 3 to calculate the phase value. So this is the phase value at the supply side. Now what will be the current? Can you calculate the current due to this phase voltage? This, I mean, the neutral point, if the system is balanced, you can connect the neutral of the load to the neutral of the source. It means you can say that whatever the source phase voltage is, the same phase voltage will appear here. Okay, so now the phase voltage will be 415 by root 3, angle 0. Let's take angle 0. Now what is the current which will come in this phase? So the current will be 415 by root 3 angle 0 divided by the total impedance, and the total impedance is 5 plus J5. Okay, this is the total current which will flow like this. Okay, once you get this current, you can calculate this drop. Okay, and this drop will be this current into J10. Okay, we found this drop. Once you get this drop, the phase voltage minus this drop, you will get this phase voltage. Okay, so this phase voltage will be, tell me what is the supply phase voltage? Supply phase voltage was 415 by root 3 angle 0. This was the supply phase voltage minus this drop, and this drop is this. Okay, so minus 415 by root 3 and J10 divided by 5 plus J5. Okay, so this is the voltage across this phase. Now what I do is, we know this phase voltage, multiply by root 3, again multiply by root 3, you will get the line voltage across this load. Across this load you get the line voltage, and we require this line voltage VAB. We require this VAB. So if you calculate this root 3 will cancel, and now what will you get here? It will be 5 root 2, this is 5 root 2, and in the numerator you will have 2 angle 90, in the denominator you have root 2 angle 45. So the final result will be 415 angle 0 minus 415 angle 0 minus 415 root 2 angle 45 degree. Okay, I hope it is clear. Now you can calculate this, and the answer again came out to be 415. Okay, I think this difference will again came out to be 415. Tell me guys, how many of you have corrected this? I think this difference came out to be 415 volt. Please check it. Please tell me how many of you have corrected this. This was again a very good question. I think it's a 2-mark question. So tell me how many of you have corrected this. Tell me guys. It's not a tough question. You can't say that this was a tough question. Actually, yes, the calculation was little bit, the calculation was more. Otherwise, I don't think that this was difficult. Okay, so please check this question and check this calculation. According to my calculation, I think the answer is again 415. Okay, please do it. So let's come to the next question, guys. Let's come to the next question. Okay, I think this question I need to solve. Okay, so up to this question I have solved it. I think 2-3 questions, next 2-3 questions I have to solve it. Okay, so let me check how many of you I have solved for you. Yes, now you can see that I have solved, I think, 5 questions for you now. there was one question from power electronics, and the answer is this was MSQ, and there is yes, this question was 95, and next question is tell me guys, for this question 1351 was the correct answer. And yes, I need to solve this question. I will come, maybe I have to solve this question because I haven't solved this. So maybe after next I think sir will take the session, and then after that I will come back and then I will try to solve those questions also. Okay, so I think you can continue with the network theory. So sir, please continue.
Thank you. So hello everyone. So कैसा हुआ आप लोगों का एग्जाम? As you know, we have already solved 2 questions of network theory. Now we are solving the remaining 2 questions. So according to our analysis, approximately 4 questions has been come from network theory. 2 I have already solved. Now we have remaining 2 questions here. Okay. So if I say means अब तक जितना मैंने network से question देखे, 1 या 2 क्वेश्चन है जो थोड़े लेंदी है, but yes, paper of network theory is simpler as compared to the last year, right? Can you agree with me? Now see this question. In this question we have given that current is sine 1000t or 100t, I guess. Okay, I guess it's 100 only, not 1000. So sine 100t, the instantaneous value of the Thevenin's equivalent voltage across the terminal AB at time t equal to 5 millisecond. So simple है, we need to find out the VTH here. Nothing more than that. VTH find करते हैं, and yes, यहाँ पर ना 4ix होगा. There is a typing mistake. There will be a 4ix here. Okay, so let's solve this question. First of all, this is a current given, I guess sine 1000, you know. So I can represent it in a phasor form, which is 1 angle 0. Now here we can apply the source transformation, because source transformation लगाओगे simple से एक node हटेगा, then you will get simple loop and you can apply the KVL there. So let's apply the source transformation. So dependent source हमारा आ गया 4ix. डेटा में कोई मिसिंग हो तो आप मुझे बता देना, ठीक है? एंड हियर, एंड इफ आई एम नॉट रॉन्ग, ये J 0.4 भी नहीं है, इट्स अ माइनस, एक सेकंड में देखना पड़ेगा, प्लस J10 है ये. ओके बच्चों, यहां पर इंडक्टर लगा हुआ है J10 का, तो वो ठीक कर लेना. तो वी हैव J10 हियर. ओके, वोल्टेज सोर्स प्लस माइनस लाइक दिस, and we have one branch, this is 10 ohm, this is minus J10 ohm, यहाँ से आगे हमारे पास Ix. ओके ओके, तो कुछ बच्चे कह रहे हैं कि सही क्वेश्चन, टफ क्वेश्चन. बट टफ क्यों था क्वेश्चन, मुझे बताओ रोहित, टफ क्या था इसमें? क्या टफ था? आपको सिंपल केवीएल लगाना अब यहाँ पर, ठीक है? फिर भी कोई डाउट हो पूछ लो अभी. तो ये 10 हो गया. एंड वन मोर थिंग, यहाँ पर ना सिर्फ इंडक्टर लगा हुआ है, ठीक है? सो 10 J10, ये कितना हो गया? सिंपल 1 मल्टीप्लाई बाय 10 प्लस J10, है ना? सिंपल हमने यहां पर सोर्स ट्रांसफॉर्मेशन लगाया है, 10 प्लस J10 को मल्टीप्लाई किया करंट सोर्स से, तो हमारा कन्वर्जन कितना हो गया? वोल्टेज सोर्स, ठीक है? फाइनली, सो वी नीड टू फाइंड आउट VTH हियर. तो फर्स्ट ऑफ ऑल आई कैन अप्लाई द KVL. ओके, so if I am applying the KVL and I am going to apply the KVL in this direction, okay, so it will be minus 10 plus J10 plus 10 plus J10 multiplied by Ix. Yes, we have Ix here. Then we have a dependent source of minus 4Ix. Finally, no problem. Then here plus 10 minus J10 Ix equal to 0. है ना? सिंपल ही आया. अब आप यहां से देखो, सिंपल Ix कॉमन लो, so J10 minus J10 cancel out, 10 plus 10, 20 minus 4, 16. So simply we got 16 times of Ix is equal to 10 plus J10, है ना? एक बार मैं चेक कर लूं, ठीक है? So from here Ix comes out to be 10 plus J10 divide by 16. ओके, Ix इतने आ रहा है, कोई डाउट इसके अंदर किसी को? कोई भी डाउट हो पूछ लो. Ix इतना आ रहा है मेरे पास. Now if I have a Ix, we can find out VTH also. Okay, so let me add a page. Let me add a page here. So we have got that Ix is equal to 10 plus J10 divide by 16. And if you see the question carefully, we need to find out the VTH here. So what is VTH? IX multiplied by this impedance. So VTH will be IX multiplied by 10 minus J10. So it comes out to be 10 plus J10, 10 minus J10 divide by 16. And if I'm not wrong, so it comes out to be VTH equal to 200 by 16. है ना? But remember, it is in phasor form. Okay, remember this. ये सब कुछ हम काम कर रहे हैं phasor form में कर रहे हैं, ठीक है? Now trigonometric form में अगर मैं इसको चेंज करूं तो क्या आएगा? VTH equal to 200 by 16 sin 1000 t. Okay. Now they are asking what will happen at t equal to 5 millisecond. So at t equal to 5 millisecond, it will be 200 by 16 sin 1000 multiply by 5 into 10 raised to power minus 3. Now एक बात याद रखना यहाँ पे, जहां पे बच्चों की मिस्टेक हो सकती है ना, प्रोबेबली होगी कुछ बच्चों की, ये जो एंगल आया ना, दिस इज अ रेडियन, ठीक है? गलती से भी इसको डिग्री में मत ले लेना, बिकॉज आपको पता होगा कि जो भी एंगल हमारा साइन या कॉस के अंदर होता है, दैट इज अ रेडियन एंगल. नाउ यूज द कैलकुलेटर हियर. सो इट कम्स आउट टू बी बच्चों minus 11.98 volts. Okay, क्वेश्चन अच्छा है. वी हैव सॉल्व दिस क्वेश्चन मैनी टाइम्स इन आवर विजन क्लास एंड ऐप क्लासेस, बट इसके अंदर आपको सिंपल VTH निकालना है. एक बात ध्यान रखना बस, यहां पर जो एंगल आएगा वो रेडियन का होगा, डिग्री में ले लोगे तो आंसर रॉन्ग हो जाएगा. तो सिंपल आंसर इज minus 11.98. ओके, तो लेट मी राइट डाउन आंसर हियर. 0.98 volt. Okay, now next question. Okay, so next question. हाँ, so बच्चों दिस इज द लास्ट क्वेश्चन फ्रॉम अ नेटवर्क थ्योरी. तो 5 क्वेश्चन आए थे, हमने 4 क्वेश्चन सॉल्व कर लिए, ये लास्ट क्वेश्चन है. इसका आंसर है आप लोगों का, वी हैव टू फाइंड आउट इंडक्टर वोल्टेज एट t इक्वल टू 0 प्लस. सो टेल मी, हैव यू सॉल्व दिस क्वेश्चन और नॉट? सिंपल क्वेश्चन ट्रांजिएंट का है, सेकंड ऑर्डर दिया हुआ है, लेकिन सेकंड ऑर्डर का इतना कोई यहाँ पे यूज नहीं है. आपको सिंपल सबसे पहले इनिशियल वैल्यू फाइंड करनी है. इनिशियल वैल्यू कहाँ फाइंड करोगे? t इक्वल टू 0 माइनस पे. वो फाइंड करने के बाद देन यू कैन ड्रॉ द सर्किट एट t इक्वल टू 0 प्लस एंड उसको फाइंड कर लोगे, ठीक है? तो लेट्स सी, एट t इक्वल टू 0 माइनस, फर्स्ट ऑफ ऑल व्हाट विल हैपन? इंडक्टर बिहेव लाइक शॉर्ट सर्किट, behave as short circuit. Capacitor behaves as open circuit, and we can find out the initial values here, right? So if I draw the circuit properly here, so this we need to find out IL 0 minus plus minus VC 0 minus. This is 2 ohm, 2 ohm. And here we have a current source also of 10 ampere, and finally here we have 3 ampere. Okay, simple. t equal to 0 minus पे ये सर्किट बनेगा हमारे पास. Now अच्छा, now we need to find out IL 0 minus here. So simply you can see 10 ampere current will divide into these 2 branches only, because this branch is open circuit. So using current division rule, what will be the IL 0 minus? That will be 10 multiplied by 3 divide by 3 plus 2, it comes out to be 6 ampere. It comes out to be 6 ampere. So IL 0 minus 6 ampere, then what will be the VC 0 minus? Here you can see there will be no voltage drop across 2 ohm resistor. So VC 0 minus will be 2 multiplied by 6 equal to 12 volt. So we have find out the initial conditions here, or according to a property, IL 0 plus will be equal to IL 0 minus, it is 6 ampere, and VC 0 plus equal to VC 0 minus equal to 12 volt. Okay, so 6 ampere ना, sorry 6 ampere हो गया यहाँ पे. 6 ampere. Okay, now again in the end we have to find out the inductor voltage at t equal to 0 plus. So t equal to 0 plus पे हम अब नेटवर्क ड्रॉ करेंगे. So at t equal to 0 plus, what will happen? Inductor behave like current source. Inductor behave like current source. Capacitor behave like voltage source. Okay, and the switch has been open. Switch open हो चुका है. तो अगर switch open हो गया, so we can draw the circuit like this. This is 10 ampere. In place of inductor, we have a current source, and here we have a voltage source here. This is 12 volt. This is 6 ampere. Okay, and I guess it was 2 ohm. 2 ohm, okay. So we have 2 ohm here, 2 ohm here, and here we need to find out the voltage across inductor. So we need to find out plus minus VL. Okay, now simple है. देखो ये 10 एम्पियर है, यहाँ पर 6 एम्पियर गया है ना, तो यहाँ पर कितना चला गया? There will be a 4 एम्पियर. कोई डाउट है? यहाँ कितना चला गया? 4 एम्पियर चला गया, right? Now simply now apply the KVL here. So if you apply the KVL here or in any direction, you will find out we have VL, then we have minus 12, then we have minus 4 multiplied by 2, and then we have minus 6 multiplied by 2. No, sorry, plus 6 multiplied by 2 equal to 0. So simply we got VL comes out to be 8 volt. So at t equal to 0 plus, inductor voltage comes out to be 8 volt. Correct? Huh. Okay, understood this? Fine. So there was a 4 question that आपके गेट एग्जाम में आए. 4 क्वेश्चन हमने सॉल्व करे नेटवर्क थ्योरी से. Now next will come Ankit sir, and he will solve question from the कौन से सब्जेक्ट से होगा? Now he will solve question from signal and system. Yes रोहित, माइक्रो प्रोसेसर का क्वेश्चन जो है था वो हम कह सकते हैं कि आउट ऑफ सिलेबस है. Let's wait for IIT what they will say. आइए सर.
Good afternoon, students. You would not have expected so many questions from signals and system. Am I audible to all of you? So, as usual, the questions from signals and system are very simple. One question may be little bit tricky, but everything is based on the concepts. So, if you are aware of the concepts, then the level of questions you will find easier. So, you can find this question, and similar to this question we have taken in our vision courses, in rank up course, and of course in our various YouTube sessions also. A signal x of t signal x of t 2 cos 180 pi t and into cos 60 pi t. So this signal is first sampled with a sampling frequency of 200 hertz and then passed through an ideal low pass filter. This model we have seen in our classes many times. So we have to first find out the two frequencies present in the signal x of t. So easily you can just apply the cosine formula and just expand this x of t. 2 cos a cos b, simple basic trigonometry, cos a plus b plus cos a minus b. So cos a plus b, 180 and 60, 240 pi t, plus cos a minus b, 180 minus 60, this will be 120 pi t. So here we can say that one frequency is say f1, which is 120 hertz, and from here another frequency is f2. Are you all following? 60 hertz. So these are the two frequencies, and once these frequencies are sampled with a sampler whose frequency is 200 hertz, it means fs is also given. I'll just note down here fs, 200 hertz. This is the fs. So we have the formula to find out the spurious frequency components, nfs plus minus fm. I'll just use this space, nfs plus minus fm. Here in place of fm, once we write f1 and another time we write f2. So students, Fs is 200. So 200n plus minus. What about F1? F1 is 120. And in this case, Fs is 200 n plus minus. What about F2? F2 is 60. So all my dear students, for different values of n, we'll just find out what are the frequencies available here. Yes. So students, when you put n equal to 0, you are getting one frequency component 120 Hertz. For n equal to 1, 200 plus 120, this will give you 320 Hertz. 200 minus 120 will give you 80 Hertz. If you select n equal to 2, the frequencies will be far beyond the cutoff frequency. So no need to put n equal to 2 here. Just put n equal to 0 here. You will be getting 60 Hertz, one component. For n equal to 1, you will get 260 and 200 minus 60 will be 140. So students, the frequencies will be much higher than this when you put other values of n. Now, out of these frequencies, we need to find out which all frequencies are covered under this cutoff frequency 100 Hertz. So we can clearly say that below 100 Hertz there is 60 and 80 Hertz, two frequency components. But this is a numerical answer type question, and they asked about what? They asked about the maximum frequency present in the filtered signal. So of course our answer should be 80 Hertz. So answer should be 80 Hertz. This should be our answer. Can I have your response? Students, this model we have seen multiple times in our session. Multiple times. So students, let's move to the next question. So this was the first question from signals. This involves Fourier transform. This involves the basics of signals. Also this involves the sampling process. Now, so students, this second question was from Z transform. The Z transform of a discrete signal x of n, a signal x of n, its Z transform is x of z, and ROC is given as R. Students, by equating the denominator to 0, we can just find out the various poles. So poles here, what are the poles? Where are the poles? Z equal to 1 by 5, Z equal to 2 by 3 and Z equal to 3. So we have got 3 poles. So 3 poles हमारे पास आ गए. Just a moment, students. Just go through the question meanwhile. There are 3 poles with us, and out of these 3 poles, just wait. Yes, students. So we have got 3 poles here. Z equal to 1 by 5, Z equal to 2 by 3, 1 by 5, 2 by 3 and 3. So students, if you plot the ROC, you will be getting 3 poles. 1 by 3 is the smallest radius. 1 by 5, then 2 by 3, and at last the circle of radius 3. So we can clearly say that there will be 4 possible ROCs. But which ROC will be giving you the stable system? The ROC which includes the unit circle. So ROC which includes unit circle will be this one, between 2 by 3 and 3. So this is the ROC. So in this ROC, that is mod Z lying between 2 by 3 to 3, unit circle is included. So if unit circle is included in the ROC, that system will be stable, and when system is stable, its DTFT will be convergent. So DTFT will be convergent only if the Z transform ROC will include unit circle. So this is the only ROC which includes unit circle. So let us go through the options. DTFT of x of n converges if R is such that x of n is a right-sided sequence. For right-sided sequence, ROC will be outside the outermost circle. Definitely it is not including the unit circle. So strike out option A. DTFT of x of n converges if R is lying between 2 by 3 to 3. 2 by 3 is somewhat less than 1 and this is 3. So ROC is starting from a value which is less than 1 and moving up to 3. It means the ROC is covering the unit circle. So of course the answer is option B. Just go through the other options also. DTFT of x of n converge if R is mod z greater than 3. This is not at all possible. DTFT of x of n converge if R is such that x of n is a left-sided sequence. For a left-sided sequence, ROC will be lying inside the innermost pole. Inside the innermost pole means mod z less than 1 by 5. Will it cover unit circle? Of course not. So option C and D are also striked out. So this is an MCQ, maybe for 1 mark or 2 mark. It should be for 1 mark only, simple question. Let's move to the next question. Next question. No, not this one, next. So students, which of the following statements are true? So this question covers the vague idea about the stability of the impulse response, stability targeted through impulse response. So this covers in the very basic classes of signals and system everywhere. The impulse response is denoted by h of n and its modulus is lying between 0 to 1. It means amplitude is non-zero. H of n is non-zero. Okay. H of n is non-zero for all n, then the LTI system is stable. Is it? Suppose they are giving you the idea about, its amplitude. But what about the time duration? That is not mentioned. So if my signal is continuing from minus infinity to plus infinity even with a finite amplitude, definitely that will represent what? That will be representing a signal which is not absolutely summable. So if it is not absolutely summable, definitely it will not represent a stable system. So we are just striking out this. Just go to option B. It is a discrete time LTI system. It should be if a discrete time LTI system has an impulse response h of n of finite duration. No doubt they are saying that h of n is having a finite duration. H of n is having finite duration. H of n is having finite duration. But what about the amplitude? In option B, they have not mentioned about the amplitude. Yes, I am getting some beautiful responses from the students. Thank you, Rohit. Thanks a lot. Thank you, everyone. So this kind of comments actually made our day. Students, thanks a lot for being here with us, believing on us. Thank you. In option B, they are mentioning that h of n is having a finite duration. But what about the amplitude? That is not mentioned. So if amplitude is unbounded, it is infinite, then this cannot be absolutely summable. So option B is also a strikeout. If an LTI system is causal, it is stable. No, this is not. This is actually a blunder. A discrete time LTI system is causal only if its response to a step input u of n is 0 for n less than 0. Of course, if h of n is 0 for n less than 0, we call that system to be causal system. So option D is the correct one. So out of these 4 options, option D is the correct answer. Yes. Harinath Raju. Yes, only D is the correct answer. And gate first student, may I know your name please? Student, gate first student, saying that vision batch really help us. Thanks BEP. Thanks to all our students on believing on us. Payash Kumari, if this is MSQ, then also it has got only one correct answer, option D. Other three are wrong. And these are the memory based questions. Whatever data we have collected from our students, based on that data, based on that information, we have framed this question, and we are trying to give you the solution as soon as possible, as correct as possible. But definitely, if there may be a change in some wordings, then definitely the options, correct answers or number of correct answers may vary. So with this data, option D is the correct answer. Yes. Rityaksha, whatever data available with us, this is the correct answer. Option D is the only correct answer. Option C, Siraj Ahmed, देखो बेटा, if an LTI system is causal, it is stable. It does not guarantee stability. See, if your system is causal, it is just right-sided. But if the ROC is not covering, unit circle or j omega axis, then we cannot call it as a stable system. For example, I'm just considering sigma versus j omega plot. See here, suppose my transfer function is 5 upon s minus 2 and s minus 1. So there are two poles at s equal to 2 and s equal to 1. S equal to 2 and s equal to 1. So s equal to 1 and this is s equal to 2. And say your system is causal. So where is the ROC? ROC will be to the right side of this. So this is not covering the j omega axis, so it cannot be stable. So causality does not guarantee stability. That's why option C is wrong. Option D is the correct answer. Yeah. So student, this was really a good question from Fourier transform, and I believe that the level of question or the concept involved in this we already dealt in our classes, vision batch. So student, x of omega is given as 1 for mod of omega less than omega naught. So if you plot the graph for x of omega, then it will be rectangular pulse against omega from minus omega naught to plus omega naught. This spectrum is having amplitude 1. Now, if you try to take the inverse Fourier, then what happens? X of t will be, what is x of omega? X of omega is rect omega upon 2 omega naught. This is, now x of t will be sin omega naught t upon pi t. This is x of t. Now student, x of 0 decreases as omega naught increase. We have a mapping. What kind of mapping? The relationship between x of 0 and x of omega. What is that? X of 0, it is 1 by 2 pi times area under x of omega. So integration minus omega naught to omega naught x of omega. Now students, what they are saying that omega naught increase कर रहे हैं. So if you increase omega naught, so area will increase. If area increase, then x naught should increase. So we are having a direct relationship between x naught and omega naught. So if omega naught is increasing, x of 0 should also increase, but they have given it as decrease. So this is a blunder. Got the mapping? X of t tends to be an impulse as omega naught tending to infinite. This is quite obvious. See, if omega naught becomes infinite, then you will be getting x of omega will be a line parallel to omega axis. It will look like this. See, this is your omega axis. and this is the spectrum when omega naught tending to infinite, and this spectrum is the spectrum of your impulse signal. So of course the time domain counterpart will be impulse. What is the inverse Fourier transform of this one? This will be 1. So x of t tends to be an impulse. Coming on to these options C and D, when you put t equal to pi upon 2 omega naught, t equal to pi upon 2 omega naught, put here. What you are getting? See, sine omega naught pi upon 2 omega naught. So omega naught cancelled, pi by 2. So sine pi by 2 will be 1. At the same time, what happens in the denominator? Pi into this factor. So pi square upon 2 omega naught. So 2 omega naught is lifted to the numerator. So this should be the value of x of t at this position. None of the options are matching with this. So x of t value at t equal to pi upon 2 omega naught, it should be 2 omega naught upon pi square. None of the options are matching. Option C and option D are the wrong ones. So students, as usual, electrical students basically feel that number of questions from signals and system will not be very high, but this year we have got 5 questions from signals and system. Already I have given you the solution for 4 questions, and one more question will be definitely coming in few minutes from now. Maybe my colleague will be bringing that question. Yeah. So this is the question. If you just observe this, just by observation we can solve this. How many of you got the answer for this one? Response is Chali. So students, ZT is the convolution between x of t and y of t. We are going to convolve these two signals. You can do this question by 2 approaches, but both of the approaches will take some time. Both of the approaches will take some time. So this can be solved just by observation. If you are a keen observer, if you have the basics of convolution with you, then this can be solved in some fraction of seconds. See, when you convolve x of t with y of t, for this x of t, I am plotting the graph for x of t minus tau. So that will also be a rectangular pulse like this. Since this graph is from minus 1 to plus 1, for this it will be t minus 1 to t plus 1. You can closely observe this. Okay, amplitude is 1. This amplitude is 1. You can closely observe this. When you convolve this pulse with y of t, what you have to do? You need to slide this over y of t, and simultaneously you have to multiply. This is the law of convolution. So when you slide this signal and bring this signal about this graph, what happens? After this signal multiplication with this negative pulse, it will go negative. That cannot be maximum because it is negative. It is further shifted to the right side, and when it is brought along this position, when it is brought along the positive pulse here, amplitude is 1. If you brought this pulse here, in that case, here you will be getting the maximum amplitude. So amplitude of y of t is 2 and amplitude here is 1. So maximum amplitude is occurring at this position. And what will be the value for t? When this t plus 1 equal to 5, you are getting the maximum. So t plus 1 equal to 5, then you will be getting t equal to 4. So for t equal to 4, that is for t1, they mentioned this time instant as t1. So when t1 is equal to 4, you will be getting the maximum value of z of t. So this is how you can solve it very quickly. Otherwise, you have one more approach. You can just represent them in the form of unit and ramp. Take the Laplace, then multiplication, then further you have to take inverse Laplace and plot the graph. That will be a lengthy approach. So just by observation, you would have done this and you would have got the answer. So that's all from my side. Now your favorite Sanjay Rathi sir is coming, and Let's try to fill up the comment box with all the beautiful comments and hearts. Let us welcome legendary Sanjay Rathi sir. Sir, over to you.
Hello students, so hope so आपका पेपर अच्छा गया होगा. Now I am going to discuss some important numericals from what analog. We have around 2 numericals, right? And what is the answer for this question? Yes guys, that is again I have discussed in my classes that you have to check that Jenner diode whether it is in a forward bias direction or reverse bias or it is in breakdown region in every question. You have to solve this. So please tell me what is the answer for this one. 1 minute. Okay guys, now this is the Zener diode in a circuit, has a breakdown voltage of 5 volt. This is the Zener diode and breakdown voltage is 5 volt. The current gain of beta of the transistor in active region is 99, and ignore the base emitter voltage drop VBE. Right, this time normally we are taking what VB is equal to 0.7, but in this question it is written that you have to neglect it. Means what is the value of the VB? 0. Right, ignore the base emitter voltage. The current through the 20 ohm resistance in milliampere. Where is the 20 ohm resistor? Here. 20 ohm resistor is connected here, and now 25 volt battery is connected here. Now guys, in this case just I am giving you right, try to understand, redraw the diagram. Simply redraw the diagram. This is the transistor. This one resistor is connected here, another resistor is connected here. Right, one resistor 7 kilo ohm is connected here, and one Zener diode is connected here. This point here, okay, and this is 25 volt, 7 kilo ohm. Right, and this is the 10 ohm and this is what, 20 ohm. Please check the value, na? Please check the value. Okay, so these are the values, 10 ohm and 20 kilo ohm. And what is the value of the beta? 99. Beta is 99. So what is the answer? Arik, please everyone give me the answer in comments box. Yes please. Not solved, Silva Kumar. Okay, analog answer, please check. Now my dear friends, in every question I have given you the idea that first of all check whether this Zener diode is simply reverse bias or it is in breakdown region. So we are considering that it is in what? Reverse bias. That diode is reverse bias. Once it is reverse bias, it will act as open circuit. Then what is the direction of the current? The direction of the current, this is IB. This will become IE, and what is the IE? 1 plus beta times of IB. That is nothing but 100 times of IB, because beta is given as 99. And what is the value of VBE? 0. You have to neglect the value of the VBE. So now what is the current here? Same current IE, because what is the Zener diode current? Initially we are considering that it is what? Reverse bias, means it will act as what? Open circuit. You have to verify it. Right. Now write down the KVL from this point to up to this one, and that is the path of KVL. Okay, so now what is this? 25 is equal to 7000. Please convert it into ohm. So this is will become 7000 IB plus this is 0, no need to consider it, plus 10 plus 20, 30. Directly you can write, because there is no current through the Zener diode. 10 plus 20, 30 times of IE. And what is the IE? 100 times of IB. 100 times of IB. So it will become 3000 plus 7000, that is nothing, 10,000. So what is the value of the IB? 25 divided by 10,000. Right? Now check my calculation also, and this is the value. Okay, so I have written the KVL from 25, that is the 7000 times of IB. Then what? 10 plus 20, that is the 30 times of 100 and IB, that is the 3000 plus 7000, that is the 10,000. I think that is the value of the IB. Okay, now these are the values. Okay, please check my 1 minute. Values are same, that question is similar, everyone same question. Okay, Right, that is the question. Okay, so this is the 25 7 kilo ohm 5 volt general diode. I have taken it what reverse bias. Now guys, you once you write down the KVL, you can find the value of the IB. Similarly, now what is the current through the 20 ohm resistor? The current through the 20 ohm resistor is 100 times of what? IB. 100 times of IB. So 100 times of IB means I is equal to 100 times of IB, that is 25 10,000 into what? 100, and that is answer in what? Ampere. Now milliampere, it will become 25 divided by 100 into 1000, that is in milliampere, 250 milliampere. This is the current, right? But we have to verify whether it is in reverse bias, yes or no. So we can verify it. What is the voltage at this point? This is the voltage at this point is VB. And what is the voltage at this point? Like this is the Vx. So what is the value of the VB? You can verify it. 25 minus 7,000 ohm into IB. Oh, okay, I have checked this IB. Put the value of IB. 25 minus 7,000 into 25 divided by 10,000. Right? Now this is cancel out. And you can subtract it 25 and this one, and you will get around 7.5 volt. Please check. Now, so what is the voltage at this point? 7.5 volt. Now, what is the voltage at this point? What is the Vx? Then Vx will become I into 20. I already we have proved, that is the 25 by 100. I am writing it in what? Ampere, because it is in ohm, into 20. Cancel out, and you will get what? 5 volt. So what is the drop across the Zener diode? The drop across the Zener diode is, this is 7.5 volt, this is 5 volt, so this is 2.5 volt. 2.5 volt, it is less than what? Breakdown voltage, that is given as 5 volt. Means Zener diode is in reverse bias, and that's why what is the answer for this question? 250 milliampere. 250 milliampere, that is the answer. Okay, so normally we are considering that Zener diode is what in a breakdown region. So number of students have considered, but in number of cases, number of same numerical I have solved in my sessions, continuous session. Okay, now next one. Now I am going to solve the next question. So this is the given as decimal in milliampere, rounded off to 2 decimal places, but we are getting exact value 250 milliampere. Now next one. Now this is the question. Find the minimum and maximum value of the output voltage, right? Assume the ideal diode, right? And Vz is given as 5 volt. Breakdown voltage is 5 volt, right? Okay. So what is the supply voltage given? 15 and minus 15. This is called plus Vz. This is minus Vz. These are the ideal diodes. And input signal is given as 100 sine omega t, and what is the value of omega? 100. It is not required because minimum and maximum value. That question is right. Similar question. Is there is any change? Okay, so what is the answer? Now try to understand. When we are considering 100, for to calculate the maximum or minimum value, you have to consider the maximum. So 100 volt when we are considering, because it is connected to what? Inverting terminal, because of 180-degree phase shift, what will be the output? Negative, right? And in this case, what is the path of the current? Just watch this diagram. This is the operational amplifier. This value is R. This is R, and one diode is connected, right? And in this path, one Zener diode is connected. Okay. One Zener diode is connected and one diode is connected. Okay, and that is the case. Now, when I am considering 100 volt, the current will flow from this point to this point and to this point. And this voltage is what? Negative. This voltage is negative because of 180-degree phase shift. And because of this negative voltage, this diode is on, and it will act as what? Short circuit. it will act as short circuit. Now this is R, this is R. So what is the output? Minus R by R into what V in. This is minus 100 volt. But always remember, it maybe never exceeds the what biasing voltage. So what is the biasing voltage here? The biasing voltage is 15 volt. 15 and minus 15. And that's why answer will be what? Minus 15 volt. This is the minimum value of the output. It will never exceed the biasing voltage, the 15 volt. Right? This is the first answer. Now second, when it is a plus 100 volt, what will happen then? Okay. Now, this is 100 minus 100. Now consider minus 100. Because of 180 degree phase shift, you will get the positive voltage here. Right? Because of this positive voltage, this diode is what? Off. When this diode is off, now consider this path only. When we are considering this path, this is R. We have sufficient voltage. That's why this Zener diode is in breakdown region and this diode is forward bias. Why? Because this is minus 100 and what is the path of the current? This is the path of the current. This current will pass through this and that's why this diode is forward bias. This diode is in a breakdown region. So V0 will become what? 5 volt. According to virtual short concept, Vp is equal to Vn is equal to 0. There is negative feedback, virtual ground process. So write down the KVL from this point to this point. Okay, this voltage is 0, this is 0, this is 5 and that's why what is the maximum value of the positive voltage? That is the 5 volt. So what about your answer, guys? So give me the answer in comments box. Got the same answer, 5 volt and that is what? Minus 15 volt. Minimum value is minus 15, maximum value is 5 volt. Okay. Now Rakesh sir is ready to solve some questions from signal and system. So sir.
Thank you, sir. How is analog, sir?
Analog, sir. Moderate.
Moderate. All right, guys. Chalo. Okay, so guys, one question from signals and around 3 questions from control system we'll be discussing. Okay, so let's go back. Just a second. Hanji, here it is. हाँ नहीं हुआ. This is discussed. Ankit sir told me to discuss this. Are you sure? अच्छा ठीक है guys, if this is discussed, no problem. Okay, I thought this is not discussed. So let's go to the next. Let's go to the next question then straight away. Let us start with control system then. Okay, that question was discussed. So let's start with the control system, dear. So in the Nyquist plot of the open loop transfer function of the GSHS, which is equal to, there's a note. Yeah. Okay. So GSHS equal to 3s plus 5 divided by the s minus 1, corresponding to the feedback lobe shown in the figure. This infinite semicircular arc of the Nyquist contour in the s plane is mapped into a point at, right? What do you feel, guys? A conceptual question from Nyquist plot. ज़्यादा क्या difficult नहीं है, but it is just conceptual question. It is just a conceptual question. Tell me, guys. 3s plus 5. 3s plus 5 upon s minus 1 corresponding to the feedback loop shown in the figure. The infinite semicircular arc. So guys, infinite semicircular arc किसके लिए आती है? The infinite semicircular arc of the Nyquist contour. You must know, only thing is you must know कि when that semicircular infinite loops come in the Nyquist contour and that infinite loops, okay, it turns up from plus j infinity and to the minus j infinity. This is taken when the s tends to infinity. This is taken for the case when s tends to infinity, right? So only thing is the infinite semicircular arc of Nyquist contour is mapped to what point, dear? Okay, so देखो GSHS में s tending to infinity रख देना है. Okay, so when s tending to infinity, what is going to be the GSHS? GSHS can be written as 3s है ना? 3s है. Okay, so I can write it as 3 plus 5 by s divided by 1 minus 1 by s, but s tending to infinity, it becomes 3 by 1, and so the answer should be equal to 3. Yes, guys, did you attempt this question? See, if you have studied Nyquist plot fundamentally, then this is not a difficult question. If you have only studied how to draw Nyquist plot, how to draw polar plot, then you will be stuck in this question. Okay, so Nyquist contour pe, this is the particular question. Answer is GSHS equal to the 3. Is that clear to everybody? Let's go to the next question. Okay, the marks is not mentioned. If you know, you can let us know the marks for this question. Chalo, next question ki taraf jate hain then. So what is the next question? Yeah. Consider a lead compensator of the form Ks equal to 1 plus s by alpha upon 1 plus s by beta. What is the Ks given to me? It is 1 plus s by alpha divided by 1 plus s by alpha beta, where beta greater than 1. Acha, it has to be beta greater than 1. I'll explain you why. Because when I talk about the 0 is at minus alpha. And if I talk about the pole, s will be minus alpha beta. Beta is greater than 1, and this is fundamentally true because I'm talking about a lead compensator. And dear, for a lead compensator, the lead compensator 0 minus alpha should come first, and that is why beta is greater, so that alpha beta magnitude is more. So sorry, this is the pole minus alpha beta. Okay, 0, it has to be 0 dominant system, then only it is a lead compensator. Okay, अब क्या given है आपको इस lead compensator के बारे में, थोड़ा यहाँ पे देख लेते हैं क्या given है आपको इस lead compensator के बारे में. Let's have a look into it. Okay, so you are given some transfer function 1 plus s by alpha upon 1 plus s upon alpha beta. So guys, what should be the formula for the omega m? What should be the formula for the omega m? It is geometric mean of the corner frequencies. Isn't it the geometric mean of the corner frequencies? Okay, if I talk about the corner frequencies is given by the formula reciprocal of the time constant. So that means reciprocal of 1 by alpha and reciprocal of 1 by alpha beta. These are the corner frequency, and omega m, always remember, it is the geometric mean of the corner frequencies. Right. What is the geometric mean? Root over of AB. So root over of alpha into alpha beta, and that is given by alpha root beta. और आपको given है alpha root beta should be equal to the 4. That is given to you. Given omega m, that is alpha root beta, that is equal to the 4. Okay, एक equation यहाँ से आ गया. अब आगे और क्या बोलता है question? Okay, आगे और क्या बोल रहा है question? आगे और क्या बोल रहा है क्वेश्चन. अब यहां पे आ जाते हैं. ओके, द फ्रीक्वेंसी इज 4 यार, दिस इज 4 रेडियन पर सेकेंड, वो मैंने यूज कर लिया. एट दिस फ्रीक्वेंसी द गेन एम्प्लीकेशन प्रोवाइडेड बाय द कंट्रोलर अज्यूमिंग असिम्प्टोटिक बोडे मैग्नीट्यूड प्लॉट ऑफ Ks is 6 decibel. What is the value of alpha beta? Okay, from the asymptotic Bode magnitude plot the gain should be 6 decibel. तो चलिए इसके Bode plot की तरफ अगर थोड़ा सा चल लें. Okay. So gain will be 0 decibel up to the first corner frequency. First corner frequency किसका होगा? First corner frequency 0 का होगा, and due to the 0 the slope will increase by 20 decibel per decade, and as soon as the pole comes, it is going to change again by minus 20. So this is the alpha point, this is the pole point alpha beta, और जो इनका geometric mean है, that is alpha root beta, which is equal to 4 at this frequency, dear. At this frequency the gain is given to you as 6 decibel. The slope of this line we know due to the 0 becomes the plus 20 decibel per decade. So simple सा logic apply करना है that the slope, which is 20, should be equal to change in the height, change in magnitude. 6 minus 0 divided by change in the omega in terms of log scale, right? So log of alpha root beta minus log of alpha. Log of alpha root beta minus log of alpha. Okay, that means यहां से हम लिखेंगे तो 20 is equal to 6 divided by log of a by b, तो अल्फाबेट कैंसिल, log root beta. तो गाइस यहां से आपका सबसे पहले log root beta का वैल्यू आ गया, that is 6 by 20 और that is 0.3. So what is the value of root beta? That is 10 raised to the power 0.3, जो कि approximately 2 आ जाएगा and you will get the beta equal to 4. अब अगर beta 4 आ गया, तो alpha root beta is also 4. तो अल्फा इंटू रूट बीटा 2 होगा इक्वल टू 4. अल्फा का वैल्यू 2 आ गया. अल्फा 2 बीटा 4. Alpha 2 and beta 4. If I go to the answer and mark alpha 2 and beta equal to the 4. Alpha 2 and beta equal to 4. Option number A is the very correct option for this. चलते हैं अगले क्वेश्चन की तरफ. हाँ, ये आ गया 2 and 4. Next, the magnitude and phase plot of an LTI system are shown in the figure. What is the transfer function of the system? What is the transfer function of the system? देखो, now magnitude is flat for all frequency. There is only the phase term coming up here, but magnitude is flat, and such a system is possible. Okay, such a system is possible where magnitude is independent of frequency. Only a phase term is coming. So GSHS should be of what form? इसको देख के समझ में आ रहा है. GSHS should be of the form k e power minus st. Magnitude is always constant. Only a phase term is coming up due to the exponential term e power minus st, and that also is going linear. It's a omega graph. Bode magnitude plot is again with respect to log omega, but if you talk about the phase plot, it is only omega, and that too a linear graph. What is the type given? Linear, and this one is constant. Okay, linear means e power, matlab if you convert into the frequency domain, gj omega hj omega, that is k e raised to the power minus j omega t, right? Linear function. That is why we take the e power minus j omega t. ठीक है, चलिए. Now, what should be the value of k? That is given in the decibel. That is given in the decibel. So हम बोल सकते हैं that 20 log of k is equal to 8, right? Okay, so what is the value of log k? Log k is equal to 8 by 20, that is 0.4. K निकाल लेंगे 10 raised to the power 0.4. We will calculate this shortly. Okay, and then if we talk about the phase is minus omega t. Phase is minus omega t, and at omega equal to 1, phase minus 60 है. Radian में ले लेंगे proper, because in the e power j omega t, omega is in the radian. So we have minus of pi by 3 is equal to minus of 1 multiplied by t. So hence guys, t is equal to pi by 3. Pi by 3 का value तो approximately 1.05 लिख लेते हैं, right? So and then what is this? 10 raised to the power 0.4. मेरे ख्याल से एक ही ऑप्शन मैच होगा. So let me write this as 2.51. Let me write this as 2.51, and the correct answer hence is going to be B. E power, हाँ, इसको हर एक ऑप्शन में s होगा. This has to be multiplied with s, of course. That is very well understood. That is very well understood. Clear है guys? ठीक है dear. So these are the control system questions. Total I think 5 control system question discuss कर चुके हैं. I will say 1 or 2 questions are conceptual. Difficult बिल्कुल नहीं बोल सकते. Some of you were telling in the beginning. Nyquist plot का भी जो question है, if you have studied fundamentally कि Nyquist contour को कैसे प्लॉट करते हैं, इफ यू हैव सीन व्हाट नाइक्विस्ट कंटूर इज, तो वो भी आपसे सॉल्व हो जाना चाहिए. बाकी तो ये सब सिंपल, ये तो बहुत सिंपल सा क्वेश्चन था. एंड आशुष सर, मशीन्स,
machine and power electronics, sir.
Okay guys, so we have again the core subjects coming up. Machine and power electronics के साथ आशु सर आ चुके हैं, and he is going to continue the further discussions. Thank you sir.
Thank you sir, thank you. So hello guys, and I hope you are enjoying. Okay, so let's go with the power electronics, because in the power electronics I have solved 2-3 questions, and now I'm starting with this question. So I got this question, and let's try to solve this question. And previously I took a one question, and in that question actually the statement was a little bit changed, so I'll also take that question also. So let's look at this question. This is again very good question. I don't know how many of you have corrected it, but let me tell you guys, a circuit shown in the figure has reached steady state with a thyristor T in off condition. So first, thyristor is in off condition. It means this circuit will work properly. Okay, it means this circuit will work. Is it fine? And this circuit has reached its steady state. It means the capacitor is charged at, let me let me tell. So the capacitor is charged at 100 volt. Okay, capacitor is charged at 100 volt, and after that this circuit will remain off. This is off, this is off. So under steady state, capacitor is charged at 100 volt. Okay, now what he does is, he is assuming that the latching and the holding current of the thyristor are 0. The thyristor is turned on at t equal to 0. At t equal to 0, we have fired this thyristor. So this is turned on. At t equal to 0, it is turned on. As soon as you turn it on, then there will be two current which will start flowing. One is this current, okay, which is 100 upon 4, that is 25 ampere, okay, and one current is this current, okay. So now if I write the equation for the current, this current is 25 ampere, so one current is going downward with 25 ampere, and there is one more current, that is this path current, and this path current is, we know that Vs root C by L. Vs root C by L. C is 1 microfarad and this is 4, so 1 by 4 and sine of 1 by root LCT. Okay, now you will ask me, sir, from where you have written this, from where this equation came. So this equation came from the LC circuit. Okay, now if you apply the Laplace transform, you can see that this is Vs by S. Okay, this is 1 by Cs, and you have Ls. Okay, if you not remember it, then I'm telling you. So the current in this path, LC circuit, so the LC circuit current is Vs by S divided by 1 by Cs plus Ls. Okay, now you can simplify this, so it will be Vs by S into Cs divided by, tell me, LC S square plus 1. Take LC common. Okay, if you take LC common, this S will cancel, and Vs by L. Okay, now you have 1 upon S square plus 1 by LC. Okay, now you multiply with 1 by root LC in the numerator, and in the denominator 1 by root LC, and you can see that it will become sine. Okay, and this will become Vs root C by L. Okay, Vs root C by L. So this is correct. I hope you remember this, na? Vs root C by L sine. So there is one more current, sinusoidal current is this current, and one current is 25 ampere. So total current is 25 plus 50 sine of 1 by root LCT. Now if you look at this, you have 125 ampere, and there is one more current which is a sinusoidal current. Okay, which is a sinusoidal current. Now you can see that this is the instant, we call it pi root LC. This is pi root LC instant. Okay, this is pi root LC instant, and this peak value is 50 ampere. Now we know that the thyristor will turn off at the instant where the current has become 0. Okay, where the current has become 0. Now tell me, you can see that if I come to this point, at this point this inductor current has reached 0, but the thyristor current has not become 0. You can see that at this instant the total current is 25 ampere. The total current is 20, because you are adding, na, this current plus this current. Okay, so if you are adding the current, then the resultant current will look like this. The resultant current will look like this. Okay, so it will be like this. This is my resultant current. So it means the thyristor current will be 0 at what instant? You can check that instant where the thyristor current is 0. The thyristor current will be 0 somewhere here when this current has become minus 25. Okay, when this current has become minus 25, at that instant the thyristor current will become 0. Okay, the thyristor current will, and now the question is the duration in microsecond for which the thyristor would conduct. We need to calculate the duration by which the thyristor would conduct. Now look at this. At this instant the thyristor current has become 0. Up to this instant now the thyristor current is positive. At this instant the thyristor has to turn off. The thyristor has to turn off. But there is a problem. There is a problem in this question. What's the problem? We can calculate this time. There is no problem, and maximum teacher or maximum student will do that. Now you can see that the time will be, let me calculate the time also. This is pi root LC, and this is pi by 6 root LC. How can you say that? Pi by 6 root LC. Because we know that if this angle is pi, so this has to be pi by 6. If in radian, if I say, let's call it pi radian. This is 1/6 of that. How can you say that it's 1/6? How can you say that it's 1/6? Because we know that this 50 sine of omega t will be equal to minus 25. So this angle has to be 30 degree. So out of this 180 degree, the 30 degree has 1/6 part. So it means if this full length is pi root LC, this has to be pi by 6 root LC. So if I add these two values, so it will become pi root LC plus pi root LC plus pi by 6 root LC. Okay, and you can put the value of LC, take this pi common and take this root LC also common, so it will become 7 by 6. Is it clear, guys? Now pi root LC, what is pi root LC? Pi into root LC value, put the value of L and C, so it will become 2 into 10 to the power minus 6 into 7 by 6. Okay, so this should be the answer. Now I have calculated this value, but let me tell you, there is a catch. There is a catch in this question, and I'll tell you that catch, but let me first calculate this. So this came out to be, please check the calculation, because it might be possible that I do the calculation mistake. So it came out to be 7.33 microsecond, and maximum teachers or maximum student has done the same thing. Okay, maximum student or maximum teachers had done the same thing. So answer is 7.33 microsecond, because the current is becoming 0 at this instant. At this instant, the current has become 0. So we have calculated pi root LC plus pi by 6 root LC. So I have done the calculation. I just added these two values, pi root LC and pi by 6. So the answer came out to be 7.3. But this is a problematic thing. Why? Because at this instant, if you look at this carefully, at this instant, the current in the inductor is reversed. The current in the inductor is reversed. And you can see that the current has developed some value in the reverse direction. Current has developed some value in the reverse direction. How much current how much current this inductor has achieved? Obviously 25 ampere in reverse direction, and one more 25 is flowing like this, and this 25 is coming like this. So then the resultant current is 0. What will happen after that? After that, this inductor will not stop conducting. Why? Because it has developed some current, and the current cannot flow in reverse direction. So this thyristor will turn off and the current will flow via this path. Okay, it means this answer is correct. Okay, I mean, you have to analyze this part also, but maximum student have not analyzed. It's not a mistake actually, but remember that the time is 7.33 microsecond if the calculation is correct. Obviously you have to check the calculation. If I have done the correct calculation, then this is the correct answer. Okay, but you have to analyze this part also, because it might be possible that, look, if this resistor was not in the circuit, then the thyristor will not turn off at this instant, because it will keep inductor will keep on flowing the current. But since current cannot go in the reverse direction, or current has to flow in this direction then, because current cannot flow in this direction. So after switching, after turn off this point, inductor current will go like this. Okay, and this thyristor will turn off. So the thyristor will conduct only for this duration. So this question is correct, totally correct, and this is the correct answer. I hope it is clear, guys, because maximum student will do pi root LC. Okay, this is not correct. So you have to add this 25 also. No, you have to check by how much time this resultant current is positive. Okay, that should be the correct answer. Anyway, 7.33 microsecond is my answer. Let's come to the next question, guys. So the next question is, let me check the next question. Yes. So the next question is, yes, let's move to the next question. Yes, this is again a very good question. In this question, what we have is, actually there is a figure, there is a diagram, and the diagram is, I think the diagram is in the next slide. So let me read the question and let me draw the diagram, and let's check the diagram also. The four stator conductor A, B, C, D rotating machine are carrying DC current of the same value, direction of which are shown in the figure 1. Okay, so let's look at the figure 1. So if you look at the figure 1, then these are the stator winding, and we call it A. A is given as dot. Okay, you can see that A is given as dot. Okay, A has dot polarity, and this has cross polarity. Again, B has cross polarity, and B prime has dot polarity. Okay, so these are the polarity of the current which is provided to you. Now if you look at the direction of the flux lines, then the direction of the flux lines due to this conductor, the flux will flow in this direction. Okay, and due to this, the flux will flow in this direction. So you can call it north. Similarly, this will become, now you can see that the flux are entering here, and here also the flux are entering here. So it will become south. It will become north, it will become south. So there are 4 poles. So there are 4 poles. P is equal to 4. There are 4 poles. Now if there are 4 poles, then can you tell me this coil AA prime, if you look at this coil AA prime, because there is one coil, na, AA prime, and the total voltage I have to add, the total voltage I have to calculate VAA prime and VBB prime. We have to calculate that. If you look at the mechanical angle between A and A prime, I don't know the polarity of this voltage, but it's not required actually. The voltage in AA prime coil is 0. Why it is 0? Because the mechanical angle is 180 degree. If you calculate the electrical angle, 180 into P by 2, 4 by 2, okay? So it will become 360 degree. So if you look at the electrical angle between two sides, it will be 360 degree. It means they are in the same phase. So the voltage difference, if it is the voltage induced is like this, then in this coil also the voltage induced will be of same polarity. So you can say that the phase difference is 90. So if you add the total voltage, this total voltage has to be 0 volt. Okay, this voltage has to be 0 volt if you take the difference, because the phase difference between these two coils is 360 degree. 360 means they are in the same phase. Similarly, the BB prime, the BB prime, look at the BB prime. BB prime is again, we have 180 degree mechanical angle and the electrical angle is again 360 degree. So the resultant voltage will be again 0. Okay, so you can say that the voltage induced EA prime and EBB prime are 0. Now, please tell me, was this question MCQ or MSQ? Tell me guys, was it MCQ or MSQ? Tell me, is there anyone who has solved this? Was this question MCQ or MSQ? Tell me everyone. Tell me. Was it MSQ or MCQ? Do it fast, tell me. Because if it is MCQ, then this answer has to be correct. But it is if it is MSQ, if it is multiple select question, then I have to look at this option also. EAA prime and EBB prime have finite magnitude. They have finite magnitude. 0 is a finite magnitude. This voltage is 0, this voltage is 0. 0 is a finite value and are in same phase. I mean 0 has no phase, so you can say that they are in same phase. So if it is MSQ question, I have to go with the C part also. But if it is MCQ, then I have to correct B option. Correct. Okay. So I hope you understood this point. Let's move to the next question. So the next question is, let's move to the next question, guys. Okay. So the next question is this. Now you can see that we have a 3-phase 415 volt 50 hertz 6 pole 960 rpm 4 HP squirrel cage induction motor drives a constant torque load. So we have TL constant. Okay, TL is constant. Fine. We have a constant load at rated speed operating at rated supply delivering rated output. Okay, if the supply voltage and frequency are reduced by 20%, it means voltage is reduced by 20%, 0.98 V, and frequency is also reduced by the same value. Okay, previously it was V naught or F naught, now it's 0.98 V naught and 0.98 F naught. So you can say that V by F is constant. So you can say that V by F is constant. Okay, so he is taking V by F constant. The resultant speed of the motor in the RPM. Okay, he is reducing the voltage and the frequency and want to calculate the speed in the RPM. Load torque remains same. Now we need to calculate the torque expression, and we know that the torque expression is VTH square divided by omega S into RTH plus R2 by S, and take the square of that plus XTH plus X2 square into R2 by S into R2 by S. You know that this is the expression for the load torque. Now we know that nothing is provided about, I mean no information is provided for XTH and X2 and RTH, and okay, nothing is given, but we know that the machine is operating at very low slip. You can see that. So R2 by S has very high value. So you can neglect this component with respect to R2 by S and you can neglect this component with respect to R2 by S. Now the torque will be VTH square divided by omega S into, from here you can say that it's R2 by S square and here you have R2 by S. Now what we can do is we can cancel one R2 by S. So you will have R2 and S in the numerator. Okay. Now you can see that this is the expression for load torque. In the first case, let's call VTH as V naught. In the first case, VTH as V naught, and this omega S is proportional to F naught. Okay. So in the first case, the slip, we have to calculate the slip also. So slip in the first case was 120 F by, let's calculate the synchronous speed now. 120 F by P. Okay. So it is 1000. Okay. So 1000 minus 960 divided by 1000. So you can say the slip was 0.04. Okay. So if you put the value 0.04, into VTH square. VTH, let's call it V naught square, divide by omega S is 2 pi F naught, okay, and R2. This was the torque in the first case. In the second case, we need to calculate this slip, okay. In the second case, when the voltage and frequency are reduced, the slip is S, let's say, and the voltage is reduced to 0.98 V naught, okay, square, divide by 2 pi F naught is also reduced as 0.98 F naught. Frequency is also same as 0.98 into R2, okay, into R2. Now we have equated them equal. Why? Because it is given that the machine is operating at rated load, okay. Now you can cancel it and calculate the value of the new slip, okay, and from that new slip you can calculate the new speed, okay. So from here you can calculate the value of the slip, and let me check how much value I got from this expression. Wait a minute, guys. So the new slip came out to be 0.05, okay. S came out to be 0.05. I hope it is clear. S came out to be 0.05. Now we need to calculate the rotor speed, but there is a catch here also. What is the synchronous speed now? So the synchronous speed is 120 F by P. In F we have to write because we have reduced by 20%, na? So it should be 0.8. It should not be 0.98. Wait a minute, guys. So let me erase this. Oh, okay. Wait a minute, guys. I made a mistake actually. I made a small calculation mistake. Let me write it again. Previously the voltage was V naught, and then it will be 0.8 V naught. Okay. Previously the frequency was F naught. It is now 0.8 F naught. I hope this was clear to you, because 20% you have to reduce. I reduced 2%, not 20%. So the new voltage is this and the new frequency is this. Now the torque, I told you that the torque will be equal to VTH square divided by omega S into R2 by S. This will be the torque expression. So in the first case, the torque will be V naught square. S was, what is the slip in the first case? Slip in the first case was 0.04, we have just calculated, divide by omega S. Omega S is 2 pi F naught, okay, 2 pi F naught into R2, okay. Now in the second case, the voltage is reduced to 0.8 V naught, take the square of that, into S divided by 2 pi, what is F naught? F naught is 0.80 F naught, okay, into R2. Now from here you can calculate the new slip. So the new slip came out to be 0.8, okay, 0.8, okay. Now what you can do is, now we can say that because of using that new slip, we can calculate the new speed. Now tell me the new synchronous speed. So the new synchronous speed is 120 F. F is 0.80 into F naught. F naught, previous frequency was 50. Divide by number of pole. Number of pole was 6. Okay. So this is the new speed. This is the new synchronous speed. Okay. And this is the new slip. So now we can calculate the rotor speed. Using this synchronous speed and this slip, we can calculate the rotor speed. NR equal to this new synchronous speed NS, because new synchronous speed has changed, because the frequency has reduced, no? That's why the new synchronous speed has changed. So the new synchronous speed is 20 into, you can calculate this as 4. Okay, no, 40. This is 40. 40 into 20 is 800. NS into 1 minus slip. Okay, so we can calculate 1 minus, I think, is it 0.8 or 0.08? Tell me, guys. Tell me how much value you are getting. So this synchronous speed is 800 into 1 minus S2. I need to do that. 1 minus S2. What is 1 minus S2? Tell me what is the new value. I think this slip is wrong. Okay, wait a minute. I made again a mistake. So the slip is wrong actually. So this slip came out to be 0.05. Excuse me, 0.05. This new slip came out to be 0.05. So I have to write it like this: 120 into 0.8 into F divided by P. Okay, so the new synchronous speed came out to be 800. 800 into 1 minus S. S is 0.05. So now if you calculate it like this, so the answer came out to be 760 RPM. Okay, 760 RPM. I hope it is correct now. So please verify this, because I did a mistake in calculation. So I think this is correct now. 760 RPM, and the new slip came out to be 0.05. Let's move to the next question, guys. Let's move to the next question. And the next question is, let's look at the next question. I think this is over. Yes, this is my next question. You can see that a three-phase synchronous motor has synchronous impedance of. Now the synchronous impedance is ZS. ZS is given as 0.1 plus J 0.3. Okay, per unit per phase, has a steady state stability limit of 2.5. Now what is the steady state stability limit? It is the maximum power which a generator can give or a motor can take. Okay, so you can say that 2.5 is PIM. Okay, maximum input power to the motor. It is given like this, and we need to calculate the EF in per unit. VT is not provided to us, so VT we have to take as 1 per unit. Let's assume that, because by default we have to take VT as 1. So if I take VT as 1 per unit, then the PIM, what is PIM? Let me check the expression for PIM. Now you can put the expression for PIM and you can calculate using that expression. So I have done it for you. Wait a minute. Yes. Now the expression for PIM, motor maximum input power, is EF VT by ZS plus VT square RA divided by ZS, and that came out to be 2.5. Okay, this is PIM. So I have calculated PIM, and the expression for PIM is this: maximum input power to the motor. Now VT value is 1, so you can put EF upon ZS. ZS is magnitude of this quantity, so magnitude of this quantity is 0.32. Okay, plus RA is 0.1 divided by ZS again 0.32 is equal to 2.5. So from here EF you can calculate, and EF value came out to be 0.7, I suppose. Okay, so please check the calculation, because it might be possible that I make some calculation mistake. So EF should be 0.7. Okay, let's come to the next question, guys. Let's come to the next question. So the next question is, I think this was the okay, from now onward, I think Astos sir will continue. And let me tell you guys, there was a problem where I made a calculation mistake again in a DC motor question. There was a question in DC motor. Just give me 1 minute so that I can check that question. Just 1 minute I'll take. Yes, there was a question, guys, regarding DC motor. In that question, there was a mistake. Okay, in this question, actually I made a mistake, a calculation mistake I made. So the answer is, that answer I provided was 1351, I suppose, but actually the answer is 1342. Okay, so please check the calculation mistake in that, and please rectify that. Answer is 1342. Okay, so these are the questions. Now you can proceed with Astos sir, and Astos sir will take power system. Okay, so I hope you are enjoying. Don't forget to like this session, and don't forget to share this session. Thank you, guys. Sir.
So hello electrical guys, how are you and how was your GATE 2023 paper? Everybody just tell me. I hope you are enjoying the discussion, because we are coming up with one of the most authentic solution, you can say. I was waiting for my turn and I was discussing machines questions with other faculties also. So machine questions, I think Ashu Jhangra sir has already presented. So I will be presenting only power system questions. Power system questions, if you personally ask me, whatever marathon session, whatever in batches, paid batches we have taken, I think students must have benefited a lot, because if you see this year, power system question was more conceptual based. Calculation was very less. It was more about that how much confidence you have on your basics, how much confidence you have on your fundamental conceptual part. The diagrams are very big, the language is very big, but if you know the real concept, it is going to be quite easy. So I will be starting with the first question for power system. You see, it is a question based on the relays protection, and you see this diagram. There is a generator and there are 9 relays presented, and 2 RL loads are connected. One is at the B8, breaker 8, and one is at the B6. Now he is asking that which of these relays are going to be directional, and it should be the minimum number of relays should be having the directional feature, so that you can provide a complete protection for this transmission line or the different sections of the transmission line. Now in this question, you have to understand that basically there are 2 criteria. The relays at the generator side are going to be the non-directional. The generator side relays are going to be non-directional, whereas the load side relays are going to be directional. This is the first input which you should be taking into account. What is the second input? The second input is, suppose I want to protect this line, the line L3, which is having the breaker B5 and B7. So whenever a fault is going to occur on this section of the line, always the relay which is towards the generator side, it has to operate first. And this is how you provide the time differentiation when it comes to the protection. Now, if you observe the first statement, these are the two criteria you have to apply. Number one, that the generator side relays are going to be non-directional in nature, because whether it is a normal condition or fault condition, the generator will always supply current towards the load or the fault. But if it is a load, then in case of load, the direction of current or the power may reverse in case of a fault condition. That is the reason the relays at the load side are going to have the directional feature, whereas at the generator side they are non-directional. This is the first criteria. What is the second criteria? Whatever line section you are going to protect, whenever there is a fault, the breaker or the relay towards the generator has to operate first. So let us read the statements. Option A, R3 and R4 are directional over current relays. So R3 and R4 are going to be the directional. Why? Because this is the load side. For this section, this is the load side. Are you getting this? What is the normal direction of flow of current or power? In this direction. Yes or no? So if there is a fault, then the direction is going to reverse. So B3, B4 are going to have the directional feature. This part is correct. And it is blocking the fault towards bus number 2 and I think it is R7. This is R7. This is R7. Bus number 2 and R7. Where is bus number 2? This is bus number 2. Where is R7? Breaker 7. So whenever there is going to be a fault in this section, B3, B4 are going to operate. And this statement is going to be the correct statement. Statement B says R3, R4 are directional over current relays, blocking towards line 1 and line 2 respectively. Line 1, line 2 respectively. Now you please imagine, if there is a fault on line 1 and line 2 and the relays R3 and R4 are going to be opened, what is going to happen with this section? What is going to happen with this section? Are you getting this or not? So you are going to isolate a larger part of the system, which is not acceptable. Similarly, if you go for C option and D option also, you will see that these are incorrect. So option A is going to be the correct option. Let us go to the next question. Just a moment. Just a moment. Yeah, see this question. This question belongs to the transmission line performance. Yes, Tuhin, LM, how was your paper? Now this question is the performance of transmission line, but it was quite easy question. He is giving you the RLC parameters of the line. So you very easily you can find what is the Z. Z of the line is going to be R plus J omega L multiplied by the length of the line. So if you put the values, I'm not going to do a lot of calculation. I will just give you the final values because time is very less. So you have to observe. Yes. The Z value you will be getting as per my calculation 14 plus it is J 125 point and this is 6. This is ohms. Now very easily you can find the ABCD parameter. Very easily you can find the ABCD parameter, and because it is a nominal pi representation, it is a nominal pi representation. For the nominal pi representation, if you write what is the B parameter, the B parameter is going to be mod Z only. Now what he is asking in the question, he is asking the VS, VR are given and he is asking for the maximum possible active power to be delivered to the receiving end. What is the phase angle difference theta between VS and VR? So the situation is something like this. This is a generator. This is a load bus. Okay. This is the sending end, suppose. So it is VS angle del. This is the receiving end. So it is VR angle 0 degree. And suppose this is going to be your line parameters ABCD. Now you know the real power which is transferred to the load. How it is given? The equation is real power received is mod Vs mod Vr upon mod B cos beta minus del minus mod A mod B mod Vr square cos beta minus alpha. But if you see this line, you will very easily observe that only this Z parameter is going to be present. So we are assuming it that alpha is going to be 0. So what is going to be the maximum power? Please understand, the maximum power is going to happen when, and even if you don't assume, because we don't need to solve for alpha here, so even if you don't assume, suppose you are not assuming alpha to be 0, directly also you can say that this received power is going to be maximum when this angle del is going to be equal to beta, because rest all are going to be constant. A is a line parameter, B is a line parameter, receiving end voltage is fixed, you are not changing it. Beta and alpha are the phase angle for B parameter and A parameter, they are also line parameter, not changing. So the only variation you can do is in del. And for this to be maximum, this has to be maximum. When it is going to be maximum? When cos beta minus del is 1. Or you can say del is equal to beta. This beta is nothing but angle of Z. What is angle of Z? Z is given. What is the angle of Z? So del is going to be equal to theta tan inverse. That is 125.6 divided by 14. If you solve this as per my reference, you must be getting the answer as 83.638. 83.638 degrees. Everybody just tell me, are you getting this answer? Everybody just tell me, are you getting this answer? How many of you have attempted and got the same answer? Let us see the next question. Now see, this was very interesting question. In this question, the Y bus is mentioned. The Y bus is mentioned, already mentioned here. And he is asking, he is saying that there are no shunt inductor connected to any of the buses. Now he is asking which of the following are not to be true. Not to be true. And this is not NAT actually, this is MSQ. This is a MSQ question. Multiple select question it was. Now please understand, any row, if you add the element, you will get whether the shunt element is connected to that particular bus or not and what is its nature. For example, if you add all the elements of row number 1, it is going to be 0. So you can conclude that there is no shunt element connected at bus number 1. Now bus number 2, if you add, you will be getting J 0.5. Now you understand, this is a Y bus matrix. In a Y bus matrix, if one element you are getting positive, it means it is going to be capacitance only, yes or no? So this is going to be capacitor or capacitive in nature. Similarly, for the third row, if you add the element, it is going to be J1. So this is also going to be capacitive in nature. So I'm just making a random circuit diagram for this particular Y bus. Thank you so much, Tohin. Thank you. Listen. So I'm making a random diagram. Suppose this is bus number 1, this is bus number 2, this is bus number 3. 1, 2, 3. There is a connection between 1 and 2, 2 and 3, and 3 and 1. Suppose this kind of situation is there. Now you understand, there is capacitive element connected at bus number 2. Hello? Capacitive element connected bus number 3. Hello? No shunt element connected bus number 1. Are you getting this or not? So line charging is going to be present. Line charging capacitor is going to be present only in section 2 to 3. Section 2 to 3. Are you getting that? Everybody. Now read the statements. Line charging capacitor of finite value present in line 2, 3 only. This is 100% correct. And shunt capacitor of finite value present in bus 3 only. This is wrong. The second part of this statement is wrong because shunt element is connected in bus number 2 also. So this is a wrong statement, but in the question he is asking which is not true. Which is not true. This is not true, so this is correct. Read the statement B. This is B. Line charging capacitor of finite value present in line 2, 3 only and the shunt capacitor of finite value is present in bus 3 only. I think this is I think this should be a little bit, let me read the, I don't have the, I think there is a mistake in this, typographical mistake. But if you read the statements, all three lines line charging present, this is wrong, because for bus number 1 we don't have a shunt element. It means this is also wrong, and we have to select the wrong. So this is also correct as per the MSQ. Now these statements, I think something is written wrong. One statement was like this only. That the shunt element is only connected to bus number 1. This is wrong. So this is also going to be correct for us, because we have to choose the wrong statements. Now option D. The line charge, it was written, I remember it from the memory, that the line charging of finite value is present in line 2, 3 only, and I think no shunt element is connected to bus number 1, something like that only. So only one option is going to be correct. You read the if you are having the question, just read the question, then you will understand. And in the PDF also we will be updating the options. There is some typographical mistake, but I hope you understand the logic. You have to find these conclusions, and according to this you have to select the MSQ. And 3 options are going to be correct, because 3 options are wrong. Okay, so let us go to the next question. Now this was a little lengthy question. I want to open the note here. Okay, I want to open the note here. Now you see, in this question, it was economic load dispatch question. Little bit calculation also I have to do, so I will take just little bit of time. So the input energy or cost functions are given as F1, that is given as 0.1 A. A is a constant, Pg1 square plus, it was 40 Pg1 plus 120. This was rupees per hour. The second cost function was 0.2 Pg2 square plus, it was 30 Pg2 plus, it was 100, and this is rupees per hour. Now the limits for the generation is also mentioned. For Pg1 it is from 0 to 350 megawatts. 0 to 350 megawatts, and for second generator it is 0 to 300 megawatts. The total demand is given as 290, and he is saying for this demand the contribution of generator 1 and generator 2 are 175 megawatt, and for generator 2 it is 115 megawatt. Now the question is very simple. He is saying now this A constant value is going to be increased by 10%, and then he is asking what is the conclusion. Now please understand, if you are going to increase the A value, by 10%, then the cost is going to be increased, yes or no? This is the cost expression. You are increasing the value of A, so it is going to be increased. So definitely the total cost F, that is F1 plus F2. Now you are increasing A by 10%, so F1 is increasing, so total cost is also increasing. So the part of the statement that total cost F is going to be increased is 100% correct. Now you have to check whether Pg1 increase or decrease. Now whether Pg1 increase or decrease, you understand, again you have to follow the economic load dispatch, and you have to find dF1. Okay, dF1 upon dPg1 is equal to dF2 upon dPg2. Again you have to apply, but this case you have to put the A value as how? A value you have to change as A dash, which is 1.1A. The Pg1 and Pg2 for this case you will be getting, I'm just writing it because we have very less time, very fast I have to do. Yeah, Pg1 I am getting 169.329 megawatts. Pg2 is 120.67 megawatt. So initially Pg1 was 175. Yes or no? Yes, Pg1 reduces. Soumya, I think this is, you must have done it correctly. Not 159, you should be getting 169. Please cross check it. Cross check the values. Okay. So Pg1 is increasing, total cost is increasing. So you have to go. Yeah. So if you see option, so option B is going to be correct. PG1 will decrease and F will increase. F will increase. Yes or no? Because you are increasing the A value by 10%, so it is increasing. Let us go to the next question. Now see this question. Now this is a very fundamental question. No need to solve anything. Just you apply your brain if you have a little bit of concept for how you decide which bus is going to be a slack bus, which bus is going to be a load bus or generator bus. You can easily do it. Now understand. This diagram is given. So there are basically 3 buses. I think, let me just check the diagram first. Yes. So this is going to be bus number 1. This is bus number 1. This is bus number 2. And this is bus number 3. The moment you observe the real and reactive powers are mentioned on any bus, you understand that is going to be the PQ bus, because PQ bus, P is known, Q is known. P and Q both are known at this bus. So bus number 2 is going to be PQ bus. Come to bus number 3. Bus number 3, the voltage magnitude is mentioned, the phase angle is mentioned, and it is an infinite bus. It means you can say it is the largest generator. And generally we take largest generator as the slack bus. What is the purpose of slack bus? To supply losses, aggregate losses in the system. So bus number 3 is going to be the slack bus. What about bus number 1? Now bus number 1 is having a controlled current source. What the control current source is going to do? It is going to have only voltage control capability. Because of that voltage control capability, this is going to be a PV bus. Now you check the options. Bus number 1 slack bus, wrong. Bus number 1 PV bus, correct. Bus number 2 PQ bus, correct. Bus number 3 slack bus, yes. So B is going to be the correct option. Everybody just tell me, are you able to follow? Let us see the next question. Let us see the next question. Now this was a fault question. It was a very direct question. Already he has given you everything. In this question, how much easy GATE exam has become for you? They have already mentioned all the sequence networks for you. If they have not given this, still you can solve it if the values are given. But they have given you spoon feeding, only spoon feeding. He is saying there is a line to line fault. There is a, where it is mentioned line to line fault. Yeah. So there is a line to line fault. There is a line to line fault between phase B and phase C. Now he is asking what is going to be the fault current. What is fault current? Can you tell me? Fault current is minus J root 3 EA upon Z1 equivalent plus Z2 equivalent. In case of line to line fault, the ground is not involved in the fault. So there is no need of zero sequence network. Even they have given it just to confuse you. Perfect. 7.2. You must be getting 7.2. Mishara. Perfect. So what you have to do is find what is Z equivalent, short these sources. What is Z equivalent? These are, I think this is in this is 0.1, I think. Just a moment. Yeah, 0.1. 0.1 only. 0.1, 0.1, it is going to be 0.2, 0.2 in parallel, 0.3, you can find what is Z equivalent. Yes or no? For the negative sequence network, you will see again, very easily you can find. So it is going to be Z1 equivalent is going to be J0.12. Similarly, the negative sequence equivalent impedance is going to be J0.12. So just put the values. EA is going to be 1 per unit. You will find around 7.2 something. You will be getting the fault current. Is it clear, everybody? So now let us see the next question. Okay, so now power system is over. I think my favorite and your favorite and the great faculty Ankit Joshi sir is going to come to help you. So thank you so much, friends. Just enjoy your day. Sir.
Students, once again, welcome to our YouTube channel. And I hope you all have got many of the questions correct. So I'm here with the mathematics questions. So students, in the figure, the vector u and v are related as AU equal to v. So this is based on the transformation. Transformation rule is given AU equal to v, and they have given you the coordinates for u and v vectors. So it's very simple, students. I will just assume this equation AU equal to V, matrix A. Let us say the 4 components are A, B, C, D. As of now, we are assuming that we don't know the components. U, it is directly starting from 0, 0. So this will be 4, 3. Components of U will be 4, 3. And components of V, what it can be? This will be 5, 0. So 5 and 0. So students, you can form 2 linear equations here. 4a plus 3b equal to 5. And another equation is 4c plus 3d equal to 0. Now you can check with the options. If you check with option B, what you are getting? See, this is the value of A, B, C and D. So value of C is minus 3 by 5 and value of D is 4 by 5. So if I put minus 3 by 5 here, I will get minus 12 by 5 plus, what is the value of D? 4 by 5. So 4 3s are 12, 12 by 5. So ultimately you are getting 0. It means second row is satisfying the values of C and D. What about the first row? 4 by 5 and 3 by 5. Put here value of A, 4 by 5. So 16 by 5 and of course you will get 9 by 5. 16 by 5 plus 9 by 5, 25 by 5, which will come out as 5. So if you just check with option B, you will get the correct answer is option B. All others will not definitely will not match. So option B. So this is simple question based on transformation. Let's move to the next. Yeah. So students, this question is from numerical methods because this word numerically is involved here. Okay. But as you would have seen in the syllabus for engineering maths, numerical methods is not mentioned. But I'm not good at the power systems, but I know that in your core subject power system, they utilizes numerical methods to solve differential equation. So that concept you can utilize here. You can easily solve this using Euler's forward method. So student, we'll just draw a number line here first. I'm drawing a number line and I will be solving this in 2 steps. So this is my initial condition, then first T1 and then T2. Corresponding to T0, the value of y is y0. Corresponding to T1, value of y is y1. And corresponding to T2, value of y is y2. Value of T0 is 0. I am taking step size as 0.5. Yes. So 0.5 and again step size of 0.5 will make it 1. Initial condition y of 0 is given as 0. Y of 1 we need to work out first. So in order to calculate y1 I am using Euler's forward method. Y0 plus h f of T0 comma y0. So students, y0 is 0, h is 1 and f of T0 y0. So in this function, in this right hand side, just you need to replace t by T0. And what is this T0? T0 is 0. So e raised to 0 will be 1, 2 plus 0 will be 2. So this will be 1 by 2. So just a moment. H is 0.5, right? H is step size is 0.5. So 0.5 into 1 by 2, y1 will be 1 by 4, that is 0.25. So we have got this value now, 0.25. Now we need to work out y2. y2 कैसे आएगा? Again by Euler's forward method, y2 will be y1 plus h f of this time T1 y1. So y1 is 0.25 h is 0.25, and in this function, this time you need to put t1, and t1 is 0.5. So e to the power minus, what is the value of a? 0.01 into value of t1, it is 0.5, divided by 2 plus a is 0.01 multiplied by t. The value of t we are taking as t1, which is 0.5. When you solve this, it will work out as 0. I have pre-calculated this to save your time, 0.7462. So this will be the answer, and y2 is nothing but the value of y at t equal to 1. So value of y at t equal to 1 is 0.746. I can simply write this as y of 1. Got it? So yes. So students, this particular question, in this particular question, you can find the concept of numerical methods, though numerical methods was not in your syllabus, but they asked you a question assuming that you would have prepared for power systems. So let's move to the next question. Now, this particular question is a surprise for all of you. They are asking a question from fitting of curves. So students, in your branch, if you would be dealing subjects in which there involves estimation and costing, then these things are important. So these things are usually covered under the core subject, though they are from mathematics. So fitting of curves, we want to fit a straight line. So what is the approach? I am just assuming this equation of a straight line that should be fitted here, y equal to a plus bx. And what they are asking? They are asking the value of the slope. The value of the slope of this line. It means b is required here. B chahiye hame. Now, in order to find b, what you have to do? You have to form normal equations. So normal equations has to be formed. How many normal equations has to be formed here? It depends on the number of arbitrary constants. So here the number of arbitrary constants are 2. So you need to form two normal equations. So first normal equation is corresponding to a. What is the coefficient of a? It is 1. Multiply by 1 throughout the equation. And then take the summation. So summation y. Summation of a is n times a. B summation x. This is the first normal equation. Now second normal equation. What is the coefficient of b? Sir, x. Multiply by x throughout the equation. So x into y equal to ax plus bx square. Take the summation. So we have got two normal equations. Now students, which all summations are involved here, that needs to be calculated using this data. So ultimately the values of x and y are given. Values of x are -1, 0 and +1. Corresponding values of y 0.8, 2.2 and finally 2.8. Now please focus here. I need summation x, summation y. So I will be putting summation x here, which you can see is 0. Summation y, which will come out as 5.8. 5.8. Now x into y. Why x into y? Because I need one more summation here. In the second equation, I need summation xy. And then summation x square. So summation xy, x into y, -1 into 0.8. It is -0.8. Then we have 0. 1 into 2.8 is 2.8. So summation of xy will be, yes, it will be 2. Summation x square. Square the values of x. And you will be getting summation x square as 2. Now students, just put the summations here. You will be getting the two equations in A and B. So summation y, क्या है भाई summation y? Summation y is 5.8. N is 3. 3 sets of data, so n is 3. B summation x 0 आ गया. So value of A is 1.93, which is not required here. We need the value of B. So equation 2 will directly give me the solution. Summation xy कितना है? It is 2. A x summation x is already 0. B times summation x square, which is 2. So ultimately value of B is 1. So we can say that the slope of this line is B, and the value of B is nothing but 1. So students, this was an easy question, but you need to be well prepared with your core subjects also. So students, that's all from my side, and now your favorite Ashu sir will be joining, and he is with some more stuff. He will be taking machines and power systems question. So let us welcome Ashu Jangla sir here. Sir.
Thank you, sir. Thank you. Hello, guys. So don't forget to like this session. So please like this session, and I have two more questions. So let's try to solve this question. In previous question, I made a mistake actually. So I will try to rectify that mistake because there was a problem there, and let's take the question. So this is the question, and this is a very good question actually. In this question, this is electrical machine question. When the winding CD of the single phase machine 500 hertz, a 2-winding transformer is supplied from an AC current source of frequency 50 hertz. The rated voltage of 200 volt RMS 50 hertz is obtained at the open circuit terminal. So here you are obtaining 200 volt. Okay, so you are getting 200 volt here. Okay, at the open terminal, and this is the current source. We don't know the current source value. I think it's not provided. If it is provided, even if it is provided, we don't require that. Okay, now the information given is the cross section of the core is. So the cross section is, please check whether it is 500 or 5000 mm square. Please check the cross section. I think it's 500 mm square. Okay, 500 or 5000. Please check it, guys. Please check it. What is the value of area of cross section? I think it is area of cross section is 500 mm square. Please check it. Please tell me. So I'm considering it's 500. Okay, I'm considering it's 500, not 5000. Okay, and the average core length is 500 mm. Again, it's 500 mm. Average core length is 500 mm, and the maximum value of flux density Bm is given as 1. Bm is given as 1. And the relative permeability of the core is mu r. Mu r is given as 5000. Okay, mu r is 5000. The leakage impedance of winding AB and CD. This is the leakage impedance for winding AB, and this is the leakage impedance of winding CD. Okay, consider the magnetizing characteristics to be linear. Neglect the core loss. The self-inductance of the winding AB. We need to calculate the self-inductance of winding AB. Okay, the winding AB is on this side. I need to calculate the self-inductance. Now, we know that this transformer is not ideal. So let's separate the ideal part and the non-ideal part. So if you separate the ideal part, then this is the transformer. This is ideal transformer. Okay, and the non-idealities I have separated like this. Okay, I have separated the non-idealities like this. Okay, these are the non-idealities, and here we have the current source. And on this side, obviously, we have some LM, okay, magnetizing inductance, LM. So you can write this magnetizing inductance either on this side or on this side. It's no problem. On this side, you are getting, obviously, you have some resistance and leakage reactance. So you have the voltage 200 volt, okay. Now tell me, if it is the ideal part, if this transformer is ideal, then you can say that on this side, there is no current. This is 0 ampere because this coil is open. So obviously, this current has to flow somewhere. And the only path that the current can flow is this path. The only path which this current will take will be this path. Okay. So you can say that this current will be 0. It means this side winding is of no use. Okay. This side winding is of no use. Now we have only this. I mean, because there is no current. There is no current, and you are looking the inductance of the coil from this side. If there is no current in the transformer, if this ideal transformer is not taking any current, then how to calculate the self-inductance? Then the self-inductance can be calculated as n square upon reluctance, n square by reluctance. You can apply direct formula n square. Now we need to calculate this number of turns. This side number of turns we need to calculate, so that we can calculate the value of Lm. Okay. Now how to calculate this number of turns? That is very simple. We know that this is 200 volt. So 200 has to be equal to root 2 pi f n phi m. Let's call it n. Okay, n phi m. Now we can calculate the value of n from here. First you have to calculate the value of phi m. So the value of phi m is equal to Bm into cross section area. So if you multiply Bm and cross section area, then you will get the value of phi m as 500 into 10 is to power minus 6 into Bm is 1. Okay. So I think this way you can calculate the value of phi m. Okay, and you can put the value of phi m and you can calculate the number of turns. So I think in my calculation I have taken the value of phi m as 5 into 10 to the power minus 3. It means I have taken area as 5000. Okay. Okay. So if you have taken area as 5000, let's not take it 500. Let's take it 5000. Okay. Let's take it 5000. This is 5000. Please check it. Check the values. Okay. If it is 5000, then area into B will be the value of phi m. So phi m in my calculation, which I have done it. So this is 5000 into 10 to the power minus 6. Okay. And if you put this phi m here, you can calculate the number of turns. So the number of turns on this side will be equal to 180.18. 180.18. Okay. These are the number of turns which we have calculated on this side, if the area is 5000 into 10 to the power minus 6. Now, if you know the number of turns, you can apply the direct formula. Okay, to calculate the inductance, we know that the formula should be n square upon reluctance. Now, n is 180.18. You can put the value. We have to calculate the reluctance of the core, and the reluctance of the core will be L. L is the mean path length, 500 into 10 to the power minus 3, L by mu naught into mu r into area of cross section. Okay, mu naught is 4 pi into 10 to the power minus 7. Mu r is already given to us as 5000, and the value of the cross section area is also provided to us. Now we can put the values, we can get the reluctance, and we can put the reluctance value here and the number of turns value, and we can calculate the self-inductance of the coil, and the self-inductance of the coil will be equal to 20.39. 20.39. Okay, please check this value, guys. So it came out to be 20.39. I think this is the this way you can calculate the value of the inductance. Okay, let me repeat this again. The value of inductance is n square by reluctance. So what I need is number of turns first. How to calculate the number of turns? It's very simple. We know that the RMS value is 200 volt, and from there you can calculate the number of turns, and you can put the number of turns here, and you can calculate the value of inductance. The question is, why I am using this formula? Because there is no current which is supplied on this side. Okay, from this side onward, no current is coming. It means this coil is separate. This coil is separate, so you can take it separately. Okay, I hope it is clear. Let's move to the next question, guys. If I move to the next question, so yes, look, there is one more question. No, not this. Yes, actually in this question, I have previously solved this question, but there was a mistake. There was a mistake in the formula. Okay, I did a small mistake. PIM. It is given that the synchronous reactance is this. So ZS is provided to us. ZS is equal to 0.1 plus J 0.3. Okay, this is my ZS. And stability limit is 2.5. So I told you the PIM is equal to 2.5. Okay, it is given to us. Now, the PIM, what is the formula for PIM? The formula for PIM is EF VT by ZS plus VT square RA by ZS square. Actually, previously I written it ZS, not ZS square. Okay, and it has to be 2.5. Okay. Now VT is not provided to us, so VT we can take 1 per unit by default. Okay, so if you take VT as 1 per unit, then the EF upon ZS, what is the magnitude of this impedance? So the magnitude of this impedance came out to be root of 0.1 square plus 0.3 square. It came out to be 0.32. 0.32 plus VT is 1, RA is 0.1 divided by ZS square, 0.32 square. Okay, and equal to 2.5. Okay, so if you calculate this, EF upon 0.32 is equal to 2.5 minus this value, okay, minus 0.1 upon 0.32 square, okay. So if you calculate like this, and if you calculate EF from here, so you will get EF is equal to 0.4875. Please check the calculation, guys. Don't rely on my calculation because I do a calculation mistake, okay. So please do your own calculation. I think EF will be equal to 0.4875. I hope it is clear. So now Saket sir will continue from this point, and Saket sir, EMFT? Okay, okay. So you enjoy with the Saket sir. Please continue, sir.
Good evening, everyone. So I hope that you have done well in this examination. And now we are going to start with the subject EMFT. And as you all know that the questions that have come from the subject EMFT, we have done already this type of question in our vision and the rank up batch. So many of you have done this question very easily in the GATE examination also, because we have already done this in the vision batch and the rank up batch and any other practice session also. Okay, so let's start with the first question. It is very basic question. So what is the answer? Yes, so I have already got the answer from this particular topic, because as I said that we have done this question many times before, so that is why it was very easy question. So let's start with this. If the K is given, that is the surface current density 5 AX cap ampere per meter is given, then we want to calculate the magnitude of magnetic field intensity at 0.111. So we know that what is the formula, that is the direct formula based question. So we know that this H is equal to 1 by 2, and that is your K cross AN. So this is the very basic formula based question. And what is K? K is the direction of current, and that is surface current density we can say, and that is the direction which is given as 5 AX. So let's write 1 by 2. This is 5 AX cross AN. What is AN? AN is the unit normal vector from the surface current density to the point of interest. So what is our point of interest? So you can see that the current is flowing in the X direction and our point of interest is 1. So we have point of interest at Z is equal to 1, and we have to move from the surface current density to point of interest. So we will move in the upward direction. So we will move in the upward direction. Always we move from in the positive final direction, that is from the current density to the point of interest. So that is our initial point, and the point of interest will always be a final point. So we are moving in the positive Z direction. So this is AZ, and hence we will get 2.5 as magnitude, and this will be minus AY cap. And in this question, because it was a numerical answer type question, so the answer is what? That is plus 2.5. That is your magnitude. Okay, that is your magnitude of H. It is plus 2.5. So that is our final answer. Yes. So I have got one answer already. Now next is, so this is the next question that we have. This is a very conceptual question, but we have already done this again in our JEE and NEET preparation. Most of you may be from the JEE already. NEET obviously you will not prepare, because if you prepare for the NEET then you will not be here. So yeah, so this is a question in the figure, the electric field and the magnetic field pointing in the direction of X and Z. Okay, and have the constant magnitude. A positive charge Q is released from the rest from the origin, and which one of the following statement is or are correct? So this is an MSQ question, and we have 4 options. The trajectory of the charge will move in the circle, and the charge will progress in the direction of Y, and the charge will always move on the XY plane, and the charge will move in the direction Z with the constant velocity. So A and C, you have marked the answer as A and C. Here you can see what are the two, this is an MSQ question, guys. So as you can see that this direction of magnetic field is in the positive X direction and the electric field is in the Z direction. So when the charge is at rest, that means the velocity is 0. So we know that the force that will exist because of the electric field is given by Q times of E, and because of the magnetic field it is Q into V cross B. So when the charge is at rest, then the magnetic field will not exist, the force because of the magnetic field will not exist, and that's why the charge will move only because of the electric field. Okay, so the charge is at Q and it will move only because of the electric field, and that will again in the direction of electric field, means the velocity will also be in the direction of electric field. So the charge will start moving in this direction. The charge will start moving in this direction. Okay, once the charge will start moving, then virtually we have the magnetic field also now, because force due to the magnetic field also, because now the charge is motion, charge is in motion. So now the force will exist because of the magnetic field. So initially there was no force because of magnetic field, but when the charge start moving, then the force will also exist because of your magnetic field, and it will start deviating in the this direction, that you can calculate from V cross B. Okay, that is you can calculate this force because of magnetic field. It is Q into the velocity is in the direction of Z. Okay, and the magnetic field is in the direction of X, so that is the peak value and X. So we will have V naught into B naught into A Y. So it will start moving in the positive Y direction. So it will move in this direction. Okay, then again you will apply the right hand rule, that is V cross B at this point. Then it will take this path. So the trajectory will be like this, and it will again start moving in this direction, because here the velocity will be again 0. So again the charge will move in this direction, and again because of the magnetic field, it will again deflect from this side. So this will be the path that will be followed by the charge. Okay, so can we say that it is a circle? Obviously not. It will be a cycloid. The trajectory will be cycloid. So the correct answer will be B and C only. The charge will progress in the direction of Y because it is traveling in the positive direction, and the charge will move in the XY plane. So it will be in the XY plane. So these two options will be correct. Okay, so answer A will not be correct, right? So you can tell, because the center will also move because of the electric field, and in this way we have the path in this direction. This will be the trajectory. So we cannot say this as a circle. Okay, we cannot say this as a circle. This will be called as the cycloid. So many of you have done this, is you can say semicircle also, but in any direction if you see, it will not look like a circle. So we should not take the option A. Okay, option B and C will be more appropriate. The question statement, yes, it is a contradictory question that many of you have. I have got the question in this way. The diagram is given in this way, but the statement was in the opposite direction. That is, in the statement, the electric field is in the X direction and the magnetic field is in the Z direction. So obviously it will be your marks to all. It will be marks to all. If both the statements are different, then definitely it will be marks to all. But according to the diagram, I am giving you the solution, and according to that, the answer B and C would be more appropriate. Yes, the charge will follow the electric field, and because of that, initially as it starts following the electric field, it will move upward, and when it will be in motion, then the force because of the magnetic field will also exist. Okay, so initially magnetic field, force due to the magnetic field was not there, and as it moves, it starts acting on the charge, and it will deflect it from the z-axis. If suppose many a times we have seen this type of question where the electric field and the magnetic field are in parallel. So what will happen? Can you answer me? What will happen if the electric field and magnetic field will be in parallel? What will be happening when the electric field and magnetic field will be in parallel? So here we have the perpendicular, right? Okay, in the statement that is not written. So electric field and magnetic field are in parallel. So the charge will move in the Y direction, then how it produce B in the X direction. B is already in the X direction. It is already there. It is not generating it. Magnetic field is already in the direction of X, and it is continuously acting on this particular charge particle, and because of this relation, that is V cross B. You can apply the V cross B here, and you will see the velocity will be in this direction. V cross B. So the velocity is in this direction. So when you will turn this right hand rule, when you apply, that is the velocity, and this is the magnetic field. So when you will apply this right hand rule like this, when you will apply the right hand rule, then you will see that it is continuously bending the charge. It is continuously bending the charge. It is a very basic thing. It is very basic. We have already learned it. Actually, I am not going into the detail of this derivation because this is something where the time force you have to consider, that time varying field that you have to consider, and the force acting on the charged particle because of the electric field and magnetic field, that is the Lorentz force equation. So if you are clear with the Lorentz force equation, then there will be no problem in this particular question. So yes, any more doubt? And I heard that there are 3 questions from the EMFT, but I have got only 2 questions. So do you have the third question? So can you write in the comment section? Can you write in the comment section the third question of EMFT? Okay, so I think the Rakesh sir has come and he will be discussing the engineering aptitude, right sir?
Aptitude and control digital कुछ mixed questions हैं.
So there are multiple questions are here.
ठीक है guys, quickly let's move forward. Few questions are there. Okay, so let me write down this question here. There is a question coming up from maths. Okay, the expected number of trials, the expected number of trials for first occurrence of a head in a biased coin. This is a question जो उनने biased coin पे पूछा है. In a biased coin is known to be 4. Is known to be 4. Okay. Question simple सा ही है. Only thing is you must be able to identify this distribution. The probability of the first occurrence of head. The probability of first occurrence of head in the second trial is dash. कितना होना चाहिए? What is the probability of the first occurrence of head? Okay, in the second trial. So guys, the probability, the expected number trial for first occurrence of a head. So this is explained by what? This is explained by geometric distribution. So what you have is a geometric distribution, and in any geometric distribution, the mean value, the expected value is given by 1 upon p, and that is given to be 4. So p is 1 by 4. बोला है ना biased coin. P means probability of head. Biased coin is one in which probability of head and probability of tail are different. Otherwise, if they are equal, it becomes an unbiased ties. Okay, now what is the probability of first occurrence of head in the second trial? Okay, so in the second trial you should get the first head. So this is like second trial mein first head aaya, so what comes before that? Of course, what comes before that is the tail. So P of TH, what is the probability of tail? If head is 1 by 4, tail will be 3 by 4 and then 1 by 4. So your answer has to be 3 by 16. Clear everybody? Your answer has to be 3 by 16. एक बार exactly निकाल लेते हैं इसको. Yes. So 0.1875. 0.1875 is the answer. Correct है? ठीक है? Yes, Misra, correct answer. So this is a NAT type question from engineering mathematics. Let's move ahead to the next question. The next question that I have here इस पे आ जाते हैं हम लोग. Just a moment. Yeah. Fundamentally simple question that is regarding to the units digit, and that is 3 power 999 is multiplied by 7 power 1000. What is the units digit of this? 3 power 999 is multiplied by 7 की power 1000. Quickly करते हैं guys, and you share your answers if you have done. So 3 power, we know that whether it is 2 3, अब derive नहीं करेंगे, फटाफट से बताते हैं इसका 2378. ये जब भी केस आता है साइक्लिसिटी 4 की होती है, चाहे तो प्रूव कर सकते हैं आप. सो साइक्लिसिटी बिकॉज इट इज 4, तो आई विल राइट डाउन दिस नंबर एज अ क्लोजर टू अ मल्टीपल ऑफ 4, एंड 7 पावर 1000 is already a multiple of 4. But because of cyclicity, see 996 is a multiple for 4, right? So answer will repeat after every 4 values, right? So 3 power 3. Only take 3 power 3 because after every 4 interval value repeat ही करेगा, and 7 power 4k. So take the first multiple of 4, means whatever is the answer for 7 power 4 will be 7 power 8, will be 7 power 12, etc. यही चलता रहेगा. 3 power 3 is 27, unit digit is 7. 7 power 4 is 49 का square, 2401, तो units place लिखेंगे केवल, answer is the 7. Is that okay everybody? The correct answer is 7 as you are able to mention. ठीक है, चलो. Yes, yes, yes. Struggle, बढ़िया. चलिए, next question. Next question, next question, next question. What is the next question we have? There it is. Okay, one more decent geometrical question है aptitude में. So there is a square, okay, with the sides equal to 6 centimeter. Okay. Question लिखते हैं सीधे. Find the area of shaded region. Okay. ये भी मेंशन कर देता हूं that the diameter of semicircles, the diameter of semicircles is equal to the side of the square. Now let me give you the picture that is given. जो picture given है उसको देख लेते हैं. So first of all, yes, we have a square. Now within that square there are two semicircles actually, but the diameter of the semicircle is equal to the side of the square, and one of the semicircle is resting on the base. इस तरीके से दो semicircle given है, and the question is find the area of this shaded region. Yes guys, tell me if you have done this. Okay, and the side of the square एक बार लिख देते हैं, that is a 6 centimeter. Okay, एकदम fundamental तरीके से इसको solve करेंगे. Share your answers. Yes guys, share your answers. What are you getting? So first of all, everybody knows the area of the semicircle, but that is not the question. उससे ज़्यादा कुछ नहीं होगा, because if you calculate, I'll tell you the approach first. If you calculate the area of semicircle, that is pi r square by 2. Another semicircle, that is pi r square by 2. Okay, but we don't want this unshaded portion, and this is common to both. So minus twice of some area. Let's suppose इसको मैंने a बोल दिया. I have to find this one separately. I have to find this one separately, and then minus twice of this. Minus the twice of this. That is what you have to do. Now let us see how we can find out the value of a. Okay, या इसको यहाँ पे इतना लिख देते हैं. This is pi r square minus 2a. r का वैल्यू कितना है? Okay, 6 is the diameter, तो रेडियस हो जाएगा 3. रेडियस हो जाएगा 3. So 9 pi minus 2a. So guys, आपको जो एफर्ट करना है, that is mostly on finding the a. Lavanya and Mithra says 6 pi. Now let us find out the a. Let us find out the a. उसका भी एक सिंपल सा अप्रोच है. इसको बीच से हम अगर डिवाइड कर दें, ओके, एंड इफ यू ट्राई टू फाइंड आउट वन ऑफ दिस पोर्शन, ठीक है, या टॉप वाला कोई भी, देखिए look into this. Okay, this makes a quadrant. This makes a quarter of the circle, and ये जो dotted line मैंने ली है, इसको cover up कर लेते हैं. Okay, now what is the area of this portion? That is the area of quarter. Quarter of a circle area pi r square by 4 होगा, minus the area of triangle, that is half, into base into height. So r square is again 3. So this is equal to 9 pi by 4 minus 9 by 2. इसको यहीं छोड़ देते हैं अभी, ठीक है. Now dear, this is only the area of this top portion, but they are symmetrical to each other because of symmetry. नीचे वाले का double हो जाएगा. So what is going to be the answer for a? देखो, 9 pi minus 2a. A itself will be double of this area. Double of how much? Double of what I have written here. That is 9 pi by 4 minus कितना लिखा? Minus 9 by 2. चलिए, अब इसको सॉल्व कर लेंगे. So guys, this 4 got cancelled. So 9 pi minus 9 pi. इसको यहीं लिख देते हैं. 9 pi minus 9 pi, ये तो कैंसिल हो गया, and then one of the two got cancelled, plus 18 आ रहा है. So answer becomes to be 18 then. Answer becomes to be 18. बोल दीजिए. Answer turns out to be the 18 then. check out the options. There are 4 options also. आप देख लेते हैं 18 कहाँ पे था. Yes, there are the 4 options. That is the 18, then 9 pi, then 6 pi, and then 20. That's it. Okay. And then 20. 6 pi is also an option, Misa and Lavanya, but answer according to me is coming to be 18. एक बार check कर लेना. This is the approach that we can apply here. Okay. Main thing is we have just figured out this area. We have figured out this area, and how we have figured out ये approach आप लोग के सामने अलग से मैंने रख दी है. ठीक है. Done it, dear. चलो. So let's move ahead to the next question. Next question I think मेरे पास PPT में है. Yes. Slide numbers. This is not. Wait. छोड़ो. Just 1 second, guys. Yeah. Okay, dear. Okay, so let's go for this question. So 5 questions of control we discussed. This is one more question. So all 6 questions of control system will be there. Okay. Semicircle radius is not 1.5. No, that is total equal to 3, Lavanya. Okay. The side of the square which is 6, that is the diameter. So radius is of course 3, na, Lavanya. शायद वहां मिस्टेक कर दिया होगा आपने. चलो guys, let's come to this question now. तो consider a unity gain negative feedback system consisting of a plant 1 upon s minus 1 and a proportional integral controller. Proportional gain and integral gain is 3 and 1. For a unit step reference input, what is the final value? Steady state value पे question है of the controller output and the plant output. Okay, so we have a PI case, and what is the proportional gain? 3. And integral gain 1 by s, they will be in parallel to each other, so 3 plus 1 by s. Then comes the plant, and the plant gain is 1 upon s minus 1. This is the final output of the system, and unity negative feedback given hai. The unity negative feedback is given to me. Okay, so dear, what is the steady state value? First, can we find out the entire transfer function? उससे काफी कुछ story solve हो जाएगी. So what is the overall forward path gain? What is the effective forward path gain now? That will become 3s plus 1. These two are in cascade, so divided by s minus 1. ये लिख दिया. So what is the final transfer function C by R? That will become 3s plus 1 divided by s minus 1. तो नीचे लिखेंगे direct s square minus s plus 3s, so that will become s square plus 2s s square plus 2s plus 1. ये देख लीजिए. Okay, that is the C by R. Okay, now what is the final value of the plant output? Plant output is the actual final output also. Plant output is the final output also. ये भी देख के चलना है हमें. So if I want to talk with respect to plant output, C, that is the output C, and that will be equal to input. What is the input? 1 by s, because unit step input hai. 1 by s into this expression. Into this expression. Clear, everybody? Okay. Now tell me, dear, what is the steady state output? So that will be equal to final value theorem apply करेंगे, limit s tending to 0, s into 1 by s into 3s plus 1 upon s square plus 2s plus 1. s cancel हुआ, s tending to 0 रखा, this is coming to be 1. So plant output is 1. Plant output is 1. Okay, C बोल रहे हैं, यहीं से आंसर आपका C हो जा रहा है, but still what is the controller output? Still what is the controller output? So let's say guys, ये जो controller output है, let's say this is equal to W. Let's say this is the W. Let me just go here. मैं सिर्फ इतना तो बोल सकता हूं ना, W when multiplied by the plant gain will give you the output C. So what is the W? That is just C minus 1 into S minus 1 into the C. Okay, so what is the W? That is S minus 1 into the output. Output अभी हमने निकाला 1 upon S into the so चलिए जितना मुझे याद आ रहा है लिख देते हैं 3s plus 1 upon s square plus 2s plus 1. Now what is the final value of the output WSS? Limit s tending to 0 कर देंगे. Limit s tending to 0 s into s minus 1 into 1 by s into 3s plus 1 upon s square plus 2s plus 1. S और s cancel, s tending to 0 किया. Minus 1 into 1 by 1. Answer is minus 1. Anyways option match हो गया था. प्लांट से ही आपको आंसर समझ में आ गया था, बट दोनों हमने सॉल्व कर लिया है, एंड द करेक्ट आंसर इज इक्वल टू द सी. द करेक्ट आंसर इज इक्वल टू द C. That's it, dear guys. So I think electrical team is ready. Okay, control system के सारे questions यहाँ पे discuss हो गए हैं. Okay, so guys, we are here to finally conclude the session. But before that conclusion, very important things. And what are the very important things? Sir, cutoff कितना होगा? Sir, toppers कितने mark expect करेंगे? Toppers कितने marks expect करेंगे? ठीक है. हाँ. There is something else also, guys. हम इसका भी update कर दें. Very soon, for all electrical students. Okay, now by evening you will sit back and analyze how many marks you are finally obtaining. What are your gate marks and what can be the expected rank for this year? Ashu Jhangra sir and Ashutosh sir is bringing up the session. So sir, ये session exactly कब planned है बच्चों के लिए?
Sir, we are planning this session actually tomorrow, but I think we are going to do it today itself because I think electrical guys are going to be free now.
Yes.
So I think in the evenings or anytime we are going to plan it.
So guys, just stay updated to the channel. ठीक है, अभी हम लोग just immediately after this we are going to go for the electronics analysis and probably just after that सर लोग आएंगे और इस सेशन को आपके लिए पूरा एकदम फैंटास्टिक एनालिसिस दे आर गोइंग टू कम अप, राइट? इसके अलावा भी आई थिंक
Yeah. So guys, there is a big surprise now, or this surprise is going to help you not in just your other competitive examinations apart from GATE, because GATE में आपके पास current affairs नहीं होता है. Okay, so current affairs के ऊपर एक बहुत बड़ा सरप्राइज है और वो हम डिस्कस करेंगे आपसे, बट उससे पहले एक बार वेटेज एनालिसिस देख लेते हैं कि किस रैंक पर आपकी क्या पॉसिबिलिटी बनती है, क्या आपका मिनिमम क्वालिफाइंग मार्क्स होगा इस बार के डिफिकल्टी लेवल को देखते हुए दोस्तों. तो सर, आशीष सर.
सर अगर पेपर को देखें तो ज़्यादा हम इजी नहीं कह सकते, मतलब पेपर वाज मॉडरेट एंड मेरे हिसाब से जो कट ऑफ रहेगी वो तो ऑलमोस्ट सर वैसी ही रहेगी, ऑलमोस्ट थोड़ा बहुत फर्क रहता है कट ऑफ में, तो ज़्यादा नहीं है. बट द थिंग इज आई थिंक जो रैंक वाला जो एरिया है वो थोड़ा सा वेरी करेगा सर.
बिल्कुल,
मतलब इस बार अगर 70 प्लस मार्क्स अगर आपके पास हैं तो आप बहुत अच्छे जोन में हो, क्योंकि पेपर थोड़ा सा लेंदी भी था और थोड़ा कंसेप्चुअल क्वेश्चन भी थे बहुत सारे. एंड अगर सब्जेक्ट डिफरेंट सब्जेक्ट्स को देखोगे तो उनमें एक दो क्वेश्चन तो ऐसे भी थे जो सच में बहुत अच्छे लेवल के थे, जिनमें टाइम भी लग रहा था.
करेक्ट.
तो इस बार इस चीज को देखते हुए मुझे लगता है कि 60-70 अच्छी रेंज है. 70 प्लस अगर आप है तो बहुत अच्छी रेंज है. तो यही है सर. बाकी तो आप बताइए सर, ये हमने कुछ
सर हम लोगों ने एक्चुअली क्या किया है कि हम लोगों ने कंपेयर किया है 2021 को और 2022 को, और हमने एक्सपेक्ट क्या हम कर रहे हैं, पूरी टीम बायजूस एग्जाम प्रेप की पूरी टीम क्या एक्सपेक्ट कर रही है. तो दोस्तों अगर आप 2021 को देखोगे तो जनरल ओबीसी SC ST का जो कट ऑफ था, जो एक्चुअल गेट का जो प्रोजेक्टेड था वो था 30.3, 27.2 एंड 20.2. 2022 इट हैज बिकम 30.7, 27.6 and 20.4. But observing the level of difficulty for this year electrical, bringing MSQ questions into the picture for the first time in last 3 years, we are expecting that 26 to 28 marks is going to be the qualifying marks for general category, 23 to 25 marks for OBC, and for SC ST it is going to be 16 to 18 marks. So it is going to be more or less in this range only, sir.
And इसके पीछे जो हमने सोचा, it's just like guys कि number one, paper is not difficult but at the same time it is not easy also, and question students को सोचने, थोड़ा बहुत सोचने पे मजबूर कर रहे हैं और कुछ नहीं. You have to think. It is not difficult. Once you get that approach, question goes away. But yeah, if you compare to previous year, it is a better paper because previous paper was just laddu. बहुत लड्डू था पिछले साल का, तो it is better. Number two, 8 MSQs. So MSQs are always a little challenging, right? Number 2 factor. Number 3 factor, aspirants also going little down. ये भी एक फैक्टर देखना है. इस ईयर के एस्पिरेंट्स थोड़े कम हैं, ठीक है. और जब भी किसी ब्रांच में नंबर ऑफ एस्पिरेंट्स एंड कंपटीशन इज लेस तो कट ऑफ डेफिनेटली गोज हाई, थोड़ा सा हाई हो सकता है. तो न्यूट्रलाइज करने की कोशिश की गई है यहाँ पे दोनों फैक्टर्स को रखते हुए.
सर एक पॉइंट और मैं ऐड करूंगा. हम सभी लोग डिस्कस कर रहे थे कि इस बार एक नई चीज देखने को मिली गेट में. सर जो क्वेश्चंस कोर से आए हैं उसमें जो लैंग्वेज है वो बहुत लेंदी है, बड़े कॉम्प्लेक्स से डायग्राम बना दिए हैं, 7-8 लाइन की लैंग्वेज लिखी हुई है, बट जो फाइनल कंक्लूजन है अगर आपके पास कॉन्सेप्ट है तो आप उसको इजिली कर सकते हैं. सो फ्रेंड्स, आई एम गोइंग टू इनवाइट द होल EC इलेक्ट्रिकल टीम फॉर द फाइनल वर्ड्स फॉर Electrical GATE 2023 analysis.
Yes.
Sir, please.
All right. So, guys, this is the analysis ki if you are, aiming rank under 10 and if your marks are 85 above, Okay, it's almost certain कि आप under rank 10 हो सकते हैं, and if you want to have a rank under 100 as per our discussion, as per our analysis, we believe 75 plus can be a 77 plus can be a good score for that. Correct है? चलिए sir.
So students, जैसे कि as Ashutosh sir has already concluded, number of aspirants are less, level of question paper was bit difficult. So now the situation will be cutoff will be something around what we have seen in the previous years only. There will not be surprises, there will not be any change. But the observation from my side is, in my subjects, I deal with the subjects maths and signals. I've seen that the questions or the level of questions is not difficult, but the level of questions is comprehensive. Means if you have not covered some basics, if you have missed out some basics, then you would not be able to pick up those questions.
Fundamental paper, it's like core, going to the concept.
Yes, sir.
लास्ट ईयर सर अगर आप देखें ना, तो लास्ट ईयर इवन लास्ट ईयर सर अगर हम देखते हैं तो लास्ट ईयर तो 3-4 क्वेश्चन तो ऐसे थे जो बहुत बढ़िया थे, बाकी जो क्वेश्चन थे वो बहुत ही मतलब बहुत ही सिंपल क्वेश्चन थे. बट इस बार ऐसा नहीं था. इस बार मतलब क्वेश्चन अच्छे भी थे और मतलब ऐसा नहीं है कि सिर्फ 3-4 ही बढ़िया थे. काफी अच्छे क्वेश्चंस भी थे और काफी मॉडरेट लेवल भी थे, काफी इजी क्वेश्चंस भी थे. इस बार पेपर थोड़ा सा बढ़िया बनाया गया था. मतलब इलेक्ट्रिकल का अच्छा पेपर था, आप ये नहीं कह सकते हो. तो मॉडरेट लेवल पेपर था ये, और ज्यादा डिफिकल्ट भी नहीं था, ज्यादा इजी भी नहीं था.
करेक्ट.
कोर से अदर देन जो सब्जेक्ट्स थे उसके भी जो आपके कोर है मशीन पावर सिस्टम पावर इलेक्ट्रॉनिक्स, अगर उनको हटा दे बाकी सब्जेक्ट्स का भी अच्छा खासा क्वेश्चन का लेवल लगेगा आपको. टफ है लेकिन टफ नहीं था, बस वही जैसा राकेश सर ने कहा ना, थोड़ा ध्यान देना था और क्वेश्चन आपसे बन जाता. लेकिन ऐसा एग्जाम अब के बाहर बोलना आसान होता है, एग्जाम हॉल में डेफिनेटली कई लोगों से नहीं बना होगा. तो इसलिए परवाह मत कीजिए और इस पेपर के बाद अगले की तैयारी भी स्टार्ट कर लीजिए. जो आपके सामने 2 वीक बचे हैं फॉर इंजीनियरिंग सर्विसेज एग्जाम के लिए.
आप में से कई सारे लोग शायद इंस्ट्रूमेंटेशन के लिए भी आगे प्रिपेयर करेंगे. दैट्स अ रियल गुड अपॉर्चुनिटी फॉर डबल एज वेल एज ईसी एस्पिरेंट्स, राइट. और बहुत बड़ा एडवांटेज मिला है दैट यू हैव आईएन सेपरेटली ऑन नेक्स्ट वीकेंड. सो गाइस यू हैव 5-6 डेज रिवाइज अप. ओके, और थोड़ा बहुत बस एक्स्ट्रा अगर एक हाथ सब्जेक्ट पढ़ने का टाइम मिलता है तो कर लीजिए, एंड यू कैन क्रैक इन दैट एग्जामिनेशन आल्सो.
और सेकंड अपॉर्चुनिटी सर इंजीनियरिंग सर्विसेज
जस्ट कमिंग अप नेक्स्ट Sunday 19 the ESC is there guys. बार्क एग्जामिनेशन अनाउंस हो चुका है. सो देयर आर हेल लॉट ऑफ अपॉर्चुनिटीज, यू डोंट हैव टू वरी अबाउट, राइट. ठीक है, अगर अच्छा गया है तो अकॉर्डिंगली आप आगे बढ़िए, राइट. प्रिपेयर फॉर IITs इंटरव्यूज एंड PSU इंटरव्यूज. और अगर आपको लगता है थोड़ा बहुत डिविएशन हो सकता है तो यू कैन अकॉर्डिंगली प्रिपेयर फॉर द अपकमिंग एग्जाम्स एज वेल.
सर मैं आप थोड़ा रोकूंगा सर, एक बहुत बड़ा सरप्राइज है बच्चों के लिए.
बिल्कुल बिल्कुल सर, आई नो दैट.
पूरी बायजूस एग्जाम प्रेप की जो गेट टीम है उसकी तरफ से है. दोस्तों हम सबने सर ये फील किया है कि हम जब भी इंजीनियरिंग की तैयारी करते थे या कॉम्पिटिटिव एग्जाम्स की, तो जो सबसे बड़ा क्वेश्चन आता था कि करंट अफेयर्स कहाँ से पढ़ें. क्योंकि सर करंट अफेयर्स हमें बैकग्राउंड तो पता नहीं होता है, हम तो अल्फा बीटा गामा में रहने वाले लोग हैं. हमें क्या पता कि पार्लियामेंट में प्रेसिडेंट भी होता है अपर हाउस लोअर हाउस के अलावा. तो मैंने सर ये सोचा और पूरी टीम ने एक प्लान किया कि क्यों ना हम सिर्फ इंजीनियर्स के लिए डेडिकेटेड करंट अफेयर्स की एक मंथली मैगजीन लॉन्च करें. और दोस्तों मैं सीरियसली बता रहा हूँ, आप देखेंगे इसका साइज बहुत कम है, 30 पेजेस का है. और हर महीने हम लोग इसमें 25 से 30 नए क्वेश्चंस ऐड कर रहे हैं. और मैं आपको एक थोड़ा सा इसका प्रीव्यू भी दिखाऊंगा. और ये स्पेशली इंजीनियरिंग सर्विसेज और जितने भी स्टेट लेवल के या सेंट्रल लेवल के कॉम्पिटिटिव एग्जामिनेशंस हैं जिसमें आपको हेल्प करती है, वहां पर आपको हेल्प करेगी. तो ये जनवरी 2023 का कंप्लीट करंट अफेयर्स है. इसको आप एक्सेस कर सकते हैं, जो हमारे पीडीएफ्स भी होंगे उसमें लिंक भी दिया होगा. यू कैन एक्सेस इट फ्रॉम बायजूस एग्जाम प्रेप ऐप आल्सो. एंड आई विल जस्ट शो यू वन सैंपल. Yes, so this is for it is from BYJU'S Exam Prep January 2023 current affairs PDF for ESC and PSUs. सर एक पॉइंट मैं ऐड कर देता हूँ कि अभी IRMS को लेके थोड़ा डिलेमा है, पता नहीं क्या होने वाला है. बट डेफिनेटली अगर IRMS में आपको जाना है तो आपको करंट अफेयर्स तो पढ़ना ही पड़ेगा. और वो जो सिविल सर्विसेज वाला है ना, उसके लिए आपको थोड़ा बैंडविड्थ बढ़ानी पड़ती है. बट कहीं ना कहीं इंजीनियरिंग स्टूडेंट्स के लिए एक लिमिटेशन हो जाता है, क्योंकि उनको 10-12 सब्जेक्ट्स भी पढ़ने हैं और फिर पूरा करंट अफेयर्स कहाँ से पढ़ें. तो उसके लिए हम लेकर आ रहे हैं कि इंजीनियर्स के लिए डेडिकेटेड एक करंट अफेयर्स का एक कंप्लीट सोल्यूशन. और इसमें हम आपको क्वेश्चंस भी देंगे हर महीने, और ये बिल्कुल ओरिजिनल क्वेश्चंस हैं. इसमें कहीं से भी कुछ कट कॉपी पेस्ट नहीं है. It is completely from authentic government sources, national and international organizations. So I will just go through some pages, sir. So this is the basic syllabus mentioned in the engineering services notification from past years, if you see. So there are social issues, national and international level, economic issues, industrial issues, and environmental issues. So it is going to be around 30 pages. So you can see the quality of content. Every single image has been worked out so that if you zoom it, अगर आप इसको बड़ा करेंगे ना, कहीं पर भी अगर आपको कुछ confusion है तो बिल्कुल आपको clarity मिलेगी. बहुत अच्छी quality का ये आपको PDF मिलेगा. और इसमें जो डेटा है दोस्तों वो बहुत क्रिस्प है. जैसे मैं आपको एग्जांपल देता हूं. अब अगर ABDM पे क्वेश्चन आया तो बहुत सारे बच्चे इतना डेप्थ में नहीं पढ़ पाएंगे कि ये आभा नंबर क्या होता है. तो वो हमने अलग से दिखा दिया कि आभा नंबर इज अ 14 डिजिट अकाउंट नंबर फॉर ABDM अकाउंट नंबर. तो इस तरीके से आप देखेंगे. मैं आपको क्वेश्चंस भी दिखा देता हूं. थोड़ा जल्दी मूव करते हैं बिकॉज वी हैव इलेक्ट्रॉनिक्स डिस्कशन ऑल्सो. या सो जस्ट आफ्टर दिस आई थिंक वी आर हैविंग द क्वेश्चंस after environment. So friends, these questions are very you can say original, and if you follow these questions, test your knowledge. So the title is going to be test your knowledge, and this time इस बार हमने इसमें 25 questions ऐड किए हैं, but हर बार ये थोड़ा बहुत चेंज होगा क्योंकि कंटेंट हमेशा करंट अफेयर्स का चेंज होगा. But all these questions are highly good in quality, in terms of quality. So friends, if you want to access this current affair magazine, this is a big opportunity for all the engineers who are aspiring for any competitive examination which deals with current affairs. So this is the ultimate solution from BYJU'S Exam Prep to all our engineers in terms of the PDF you can access. It is completely free of cost, and every month the first week it is going to be published. It is completely free of cost. The link is given in the description of this video. You can just click on that link, and separately also BYJU'S Exam Prep you can directly, I think it will be available and you can download it. So friends, now coming to the some more information. Rakesh sir, please. Sorry for interrupting you for this long, sir.
This is really important for engineers. So I think, sir, we are done.
Yeah.
Let's
Some questions.
Sir, we are done now. Let's conclude the session.
Okay.
Okay, guys. So that's it. That's it for the session, and we shall see you for the electronics analysis soon, right? In some time. Bye bye. All the very best. निराश नहीं होना. अगर अच्छा नहीं गया, opportunities बहुत, and if you are done good, all the congratulations actually.
All the best.
Bye bye.
Bye.
Close.